Hi everyone, welcome in today's session of data science. Data science is one of the most buzzing words of this century. At one point of time, we all have thought of becoming a data scientist. But some doubts, some questions are not letting us do that. To answer all those questions and all those doubts, we have got our colleague in this session today who is going to help us understand if this is really the career for us or not. Hi Hemant, thank you so much for joining with us in this video. People who are watching this video, they are in the process of becoming a data scientist or they are planning to become a data scientist in the future. So this course that you have designed with Intellipaat, how is it going to help them to become one?
Okay, so guys, the way we designed this course was we basically had a look at all the resumes and the job postings which are related to data scientists, right? We noted down all the skill sets that are required and then we got them confirmed from hiring managers who basically hired data scientists day in and day out. Later, what we did was we came up with the curriculum and we got them confirmed by data scientists who teach with us, and once they basically affirmed us that this curriculum looks good, we made it available to our learners, right? So somebody who is enrolling with us for the data science course, he can be rest assured that each and every skill set that is required by a data scientist or for a data scientist is covered in this course.
Alright, so my next question is, how easy or how tough it is for someone to start a career in this domain?
Alright, so guys, there is nothing easy or hard, Shiv. So I think what you're trying to ask is who should pursue this data science course. So guys, anyone and everyone who basically feels that they have a good logical ability, they are able to solve logical problems and are excited when you get faced with problems where you need to find patterns, right? So for those kind of people, the data science domain is. And if you are interested in things like these, obviously you will go ahead and succeed in this domain. Now, talking about the day-to-day work that a data scientist does, just to give a brief idea to the audience, would be that a data scientist is a guy who has to come up with questions himself and then give answers to the question himself as well, right? For example, you go to a business, that business, the business owners over there, they will basically not tell you the questions that you have to find the answers for. They will give you a data, or they will give you a data set which you have to analyze and basically come up with problems which you will solve with that data. So that is basically the difference between a data scientist and a person who probably is a statistician who knows mathematical formulas. To a statistician, you will ask questions and give the data and probably he can give you the answers, right? But when a data scientist is hired, all he is given is data to which he basically has to analyze, give questions to which he will also find the answers from that same data, right? So this is what a data scientist does. And if you're interested in this kind of a work, then I guess the data scientist domain is for you.
Alright, so now the most important question, which I'm sure all our viewers must be wondering, do I really need to know coding before I think of starting a career in this domain?
A very good question indeed, Shiv. So guys, I would be very honest with you. Any job that you do in the IT field where you have to tell a machine what has to be done, right? You need to know coding. But the main difference which comes is to what extent do you need the coding skills? For example, somebody who is a software development engineer, obviously he would need to know a lot of things such as data structures, algorithms, and a lot of other performance related expressions in coding. But somebody who is a data scientist, he would not need to know coding in that much detail. What he needs to know is about how you can play around with the data, how you can create a model in machine learning using any programming language. It could be either Python or R or any other programming language as well for that matter. So that is the level of coding that you need to know, right? And that is why what we have done is whatever essentials of coding are required to become a data scientist, we have also included that in this course, right? So rest assured, like I said, you do not need to know programming language as good as a software development engineer, but yes, basics of programming language will be required and that is covered in this data science course.
All right, good to know, Hemant. Thank you so much for that. One more question and one more doubt basically which keeps popping in someone's head who is having around 7 years, 8 years, 10 years of experience in the industry, and now they want to become a data scientist. So they want to understand, what future do we have as a data scientist? Can I see a sustainable career in this domain? What do you think?
All right. So, guys, imagine it like this: when computers were invented, not every company in the world started to use computers. But today, everyone is using a computer. Without a computer, you cannot imagine any company which is basically working, right? So, similarly, whatever progress we have seen in the data science domain till date, it's just a tip of the iceberg, right? Imagine you are a company who deals in some product and you have a lot of other competitors as well, right? You started to use data science, and because of that you basically came up with insights, and those insights are making profit to you. Now your competitors, if they are not making use of data science, they are basically lagging behind, right? So this is how the ecosystem basically works. So slowly and gradually, as more and more companies have started to adopt data science, their competitors will also have to adopt data science. And in any job in the future that I can see, every job is going to need data science in some way or the other. So do you have a future in data science if you start today? Absolutely. I would say this is the best time to start with data science, because still I would say there are a lot of jobs which are vacant, to which people are not there to fill out the position, right? So learn data science today and future proof your career. That would be my advice to you.
Alright, guys, so now let's go ahead and understand what data science has contributed to the world in terms of technologies, in terms of advancements. So, do you know that the Oscars that were conducted last year were basically predicted already by Microsoft? So, Microsoft used their AI engine to predict who will win Oscars last year, and 96% of their predictions were correct. Similarly, if we talk about Harry Potter, I hope every one of you knows what Harry Potter is. Do you know that Harry Potter has a eighth book as well? And that is not written by J.K. Rowling. It has actually been written by an AI, right? And this is legit, guys. If you see this book, just search this book on Google, you will find that this book exists, and this has purely been written by an AI. Now, here's another interesting application for you. So, you all must have encountered fake profiles on the internet. I bring to you fake faces. So, a bunch of university researchers created an AI app which can create fake faces, and you cannot tell the difference whether it's a real face or not. Interesting, isn't it? And the way it is done is that they have a database of millions of faces, human faces, and what they do is they combine those faces using AI technology, and the algorithm which they use is GAN. You can search it on Google what it exactly does. And what that does is basically combines different features of faces and creates a face which looks exactly like a real face, but that person does not exist. All right. Now let's go ahead and talk about how data science has actually impacted businesses and has caused profits. So let's take a case study here of a finance company, and this is a real finance company, and let's understand how data science impacted their overall productivity. Alright, guys. So there was a bank which basically had a lot of loan inquiries. But the problem was most of the loan inquiries did not close. Very few of them closed, or very few of them actually took the loan. So what the bank had to figure out was how they can basically filter out the people who are actually interested in getting a loan from the bank. So what they did was they basically used data science, and what they did was they fed the machine all the use cases or all the customers who basically inquired about the loan and actually got converted, right? And the results which we got were astonishing. So the bank got results from data science which said that people who filled the form properly, when I say properly, they are using proper case letters. For example, if you talk about John Smith name, so if he is making use of the J alphabet as capital and S alphabet as capital, which is actually the way how you properly write a name, then that basically customer had a higher chance of getting converted. Now you might think it's a very simple observation which anyone could have done, but this saved the bank millions in terms of man hours, right? Because the executives over there had to call each and every customer, they had to follow up, and in the end, they got to know the customer is not interested. However, if they faced or if they basically focused on the customers who basically wanted the loan, right, using the criteria that data science suggested them, they were able to close the leads a lot faster, right? Now that you understand how data science has impacted the world, let's go ahead and understand what is data science exactly. Alright, guys. So, data science is basically a multidisciplinary field, which basically means it makes use of a lot of technologies, concepts, and it helps us to extract meaningful insights from data. In the most simple terms, this is what data science is, right? You would have heard a lot of definitions that it's a combination of AI, it's a combination of statistics, machine learning, but in the most simple terms, it is basically the use of multiple concepts and technologies to extract meaningful insights from data, right? This is what data science is. Now, a very common question that people have is that, is statistics required to become a data scientist? Or the common notion that only a statistician can become a data scientist. Now, let me go ahead and tell you what is the difference between a data scientist and a statistician. So, guys, a data scientist and a statistician have very different roles. And let me show you an example of how a conversation goes when a data scientist is being hired and when a statistician is being hired. So, in terms of a statistician, the interview panel will basically ask that, hey, here's a company data, how can you help us? So, the statistician will reply, what do you want to know from this data? Right? So, what you need to observe over here is that the statistician needs to know what exactly you are looking out in the data, and then he will implement the concepts of statistics to extract the insight that you're trying to gain from the data. However, the key difference is here, guys. Now, when the same conversation happens with a data scientist, so let's see how it goes. So, hi, here's a company data. How can you help us? Sure, I see your company has a high attrition rate. According to data, it's because they don't see any growth, right? So, the moment the data scientist sees data, you don't have to ask him any questions. You don't have to tell him what you have to find from the data. What all he can find out, he will tell you, and that's what exactly a data scientist does, right? So, a data scientist is basically never told that you have to find this particular thing from the data given. He analyzes the data and then he tells that these are the things that I can find out from this data. All right. Now let's go ahead, guys, and briefly see the responsibilities of a data scientist and statistician. So a data scientist basically finds problems from data and then solutions based on his findings. However, a statistician can only work on data but has to be told that what problems he need to work on from that particular data. Alright, so guys, this was a brief about the difference between a data scientist and a statistician. Now let's go ahead and get into the nitty-gritties of how data science functions by understanding what is machine learning exactly. Alright guys, so machine learning is basically training a machine how basically a certain task has to be done, right? In the most simplest explanation, this is what it is. I'll repeat it for you. So it is the science of teaching a machine how a particular task is done, right? Now, in the further slides, I will tell you how this process is actually implemented. But if someone asks you what is machine learning, this is what you tell them. It's the process of making a machine learn how to get a certain task done. Okay? Now let's go ahead and understand how machine learning basically works. How is this process basically implemented? So the first thing that you do as data science, the keyword says, it's all about data, right? If you want to make a machine learn something, it can only do so by making use of data. So first what you'll have to do is you will have to prepare your data in order for your machine to learn things. Okay, now let's say how you can go ahead and prepare data for a machine to learn. Okay, so let's take a very small example and then you can imagine it on a bigger scale. So let's say you have a data set which has been given to you by any company. Let's not get into the details of what this data set talks about, right? But let's just say there is a data set and there are 100 rows in that data set. Okay, what you do, the very first thing what you do when you have to basically prepare your data is you split this data into 70/30. Okay, so you will basically have 70 records in one file. So you had one file, now you have split it into two files. In the first file you will have 70 records and in the second file you will have 30 records. This is basically me trying to explain you that you have to divide the data set into a 70/30 ratio. Okay, now the data set with more number of records would be the training data set. So this would be the data that you will use to train your machine. And the latter part of the data set, right, the data set which is there in the second file which has less number of records, will be your testing data set. All right, this is clear to everyone? If it is clear, please write a yes in the chat. Okay, moving forward, now let's take an example to understand the same particular concept that I've told you. So let's imagine you have images of fruits. You want to make your machine learn how it can identify fruits. Okay, so what you have is you have 100,000 plus images of fruits. And what you do when you start preparing your data is you divide the images into 70/30 ratio. So you will have 70,000 images which will be your training data set, and then you will have 30,000 images which will be your testing data set. So whatever I told you earlier, I've just put it into perspective that when you use fruits as an example, when you want to make your machine learn how to identify fruits, you first need a lot of images of fruits. So you have 100,000 plus images of fruits. Now before you begin training your system, you will have to prepare your data. In order to do that, you will first have to divide the data into a 70/30 ratio. This should be clear to everyone now. Next, what you do is you start implementing machine learning. Okay, now that you have your data prepared, you go ahead and now you implement machine learning. So let's go ahead and understand how that is done. All right, so guys, in the process of machine learning is basically divided into three phases. The first phase is the training phase, the second phase is the testing phase, and the third phase is the predicting phase. In the training phase, you feed the machine with the training data set, right? And don't worry, just listen to what I'm saying right now. I will give you an example and things will be more clear in just a second. Okay, so the first stage is training. So you feed the machine with the training data set. Once the machine has been trained, then what you do is you test the machine with the testing data set to see whether the machine learning model is working as expected. The third stage is the predicting phase. So what happens in the predicting phase is that now you give the machine any random image and you ask it whether it is able to identify that image or that data or not. Okay, so first what you do is you train your machine, then you test whether that machine learning model is working as expected, and then you give your machine arbitrary data and it tells you whatever you have taught it. Okay, now let's put it into perspective and let's understand this process using an example. So we will be taking the same example forward. So we had the testing data set of 70,000 fruits. Okay, so we feed these data to the machine learning model, and now the machine learning model understands, okay, what a fruit is. Now to verify whether your machine learning model is working as expected, what you do is the remaining part of the data set, you feed it to the machine and you ask it what it is. So if it tells you that all of these are fruits, if they basically, the machine learning model predicts the correct value, because in this case you already know that the images that you're giving to the machine learning model are fruits, right? So if your machine now is successfully able to predict that yes, these are fruits, you have successfully identified that your machine learning model is working correctly. Okay. Now in the third phase, what you do is the predict phase. What you do is you give your image, or you give your machine learning model any random image, and it tells you whether it's a fruit or not. Okay. Now this is exactly how machine learning model works, but the only difference when you implement it in real life is that you basically take care of a lot of things, and we will be understanding that slowly and gradually as we move along in this course. Okay. Now let's go ahead and understand what are the different types of machine learning algorithms which are out there.
So in general, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's see them one by one. So starting with supervised learning. So supervised learning is the one in which we have a training data set, or you can say in which we have a labeled training data set, and the machine is trained on that particular label. For example, so there's a teacher or there's a supervisor who supervises the entire process and trains the machine according to the label. For example, you can see up here, here's a teacher on the screen who is teaching the machine by showing different images of the apple. So once the machine is trained, so in future, when we show a different image of an apple, the machine can easily identify that it's an apple with some accuracy. Okay, for example, the image shown up here is an apple with 97% accuracy. So this is supervised learning. So let's see some of the use cases of supervised learning. So first we have a spam classifier. So how do you think your mail is getting classified as whether it's a spam mail or not a spam mail? Well, the spam detection basically works on the basis of filter. These are settings that are constantly updated based on new technologies, new spam identification, and the feedback given by Gmail user about potential spammers. Spam filter uses either text filter, or it eliminates the threat based on sender and their history, whether the sender was previously reported or not. Okay, so there are mainly two types of filters: text filters and client filter. Text filter work by using algorithm to detect which word and phrases are most often used in the spam email. Phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. Spammers have gotten wise to this and often use blunt misspellings or even substitute of characters like free dollar character in order to make it pass the filter. Fortunately, the modern spam filter can also make allowances for these type of misspellings, and if a word comes up, even with character substitution, the message will still be blocked. Next is the client filter. In addition to the simple text filter algorithm, the top spam filter uses client identity and history to block malicious or annoying spam email. Now, how does a spam filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. If they send out huge amounts of email constantly, or if several of their messages have already been marked as spam through the text filter, in that case their email will be blocked entirely. So this brings us to the use of blacklist. Spam filters also include a blacklist. Blacklisting is simply the process of adding the known email addresses of a spammer to a list. This list prevents any inbound messages from the email address going forward. If you have marked something as spam, it will directly go in this blacklist. And it also helps Google to make a note of certain keywords found from that particular spam mail. So that's the outline of spam detection. The real-time process are a lot more complex and consume a lot of data. Okay. Next is fingerprint analysis. So for fingerprint analysis, what you do, you save your fingerprint in the machine as a record. So the machine checks the data and verifies whether this particular data belongs to you or not. Okay. So once the data is saved into the machine, so from next time, whenever you put your fingerprint on the machine, what the machine does is scan through all of its data. And if the data is matched, then in that case, your fingerprint is verified. This is another application of supervised learning. Next we have is unsupervised learning. Well, in case of unsupervised learning, there is no teacher and there is no label. What the machine does, the machine identifies clusters in it. It finds similar images and group them into a cluster. For example, over here, seeing some pattern in different images, the machine divides the entire image into 3 different clusters. Okay? Cluster 1, cluster 2, cluster 3. But the machine doesn't know that cluster 1 is an apple, or cluster 2 is an orange, or cluster 3 is a banana. All it knows that cluster 1 consists of similar item, cluster 2 consists of other similar item which are not at all related to cluster 1, and similarly cluster 3 consists of different item which are completely different from cluster 1 and cluster 2, and cluster 3 consists of other similar item which are completely different from the item of cluster 1 and cluster 2. Okay, so this is what unsupervised machine learning is. So one of the use case of unsupervised learning is voice-based personal assistant. So the device which you are seeing on your screen is Amazon Echo, and the brain or the voice of Echo is known as Amazon Alexa. The device has many smart built-in to do a number of tasks like playback music, make the light blink. It also recognizes the name Alexa. It's like when you say the word, it recognizes the word and start recording your voice. Amazon calls this word as a wake word. So it's like when you have finished speaking, it sends the recording over to the internet to Amazon. The service that processes this recording is called Alexa Voice Services, or AVS. It's run by Amazon, thus converts the recording into command that it interprets. It's more than a simple voice-to-text service. It is a fully programmable service that can work with other online services to do a large range of things for you. Once authorized by Amazon, anyone can use this service for free to build a homemade Echo. Amazon has also offered sample code for building an Echo using a Raspberry Pi, which is a simple $30 computer. It might sound extremely selfless of Amazon to provide the service for free, but as always, they have their reasons. Amazon want others to build their service into their product so that they can sell you this stuff. So every product that has Alexa built in is a device that can be used to buy stuff from Amazon. These commands that Alexa interprets can be very simple. It's like if you ask for a time, the AVS sends back an audio file to Alexa telling you the time, which the Echo plays back. They can also be more complex. If you ask Alexa to play a Pink Floyd, AVS will search the music service to have you set up for Pink Floyd, and then send a command back to the Echo that sets it playing the requested music. Alexa can also work with other technologies in your home. It's like you can even set up your Philips Hue smart lights to be controlled with Alexa. You can ask Alexa to turn on the living room lights, and the Alexa will send a command to the Echo that sends a command to these light bulbs to turn on. It can also work with various online services. You can link Alexa to Uber, and you can request Uber by simply asking Alexa. You can link it to Domino's, and you can just order a pizza with your voice. So this approach means that Alexa can do a lot of things for you, and the list is just getting longer. Amazon is adding more features and skills to Alexa, and if you are smart enough, you can build up on their own. So it means that you can use Alexa to control things that are not even on the list. Okay, well, however, Alexa needs internet connectivity and AVS to work. If your internet connection is slow or it's not working, then Alexa won't be available and your Echo will be useless. So if Amazon decides to charge for a service or just close it down, then in that case, you'll be just left with a useless device. Well, Amazon is not the only one in town. We have Google, Apple, and Microsoft, which offers similar services that can perform tasks by voice command in the form of OK Google, Siri, and Cortana. They use similar approach, voice commands that are processed in a cloud service. But most of them are not as flexible or as integrated with other services as Alexa is. So whichever of these services end up being the one we all use, hopefully they will be as polite as Alexa. I'll just give you an example. When I asked her how she works, she replied, "Lots of people had worked hard to teach me, and I'm still learning more. Wouldn't it be nice if all of our appliances were that modest and polite?" Right? So let's move ahead. So another use case of unsupervised learning is Netflix recommendation. So more than 80% of the TV shows that you guys watch on Netflix are discovered through the platform's recommendation system. That means the majority of what you decide to watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. Let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you the list of movies and find shows that you might not have initially chosen. To do this, what it does, it looks through a thread within the content rather than relying on board genres to make a prediction. So this explains how 1 in 8 people who watch Netflix Marvel shows are completely new to comic book based stuff on Netflix. Let me tell you about a guy named Todd Yellen. He's the Netflix Vice President of Product Innovation. He has explained the working of Netflix as a 3-legged stool. The 3 legs of this stool are Netflix members, the tagger who understands everything about the content, and our machine learning algorithm that takes all of the data and puts them together. So Netflix has more than 100 million worldwide users. If we count the multiple user profile for each subscriber, it comes to around 250 million active profiles. Now Netflix uses different kind of data from these profiles, like it keeps a track of what you guys are watching from your profile, what do you watch after completing your current video, and even what you have watched earlier. It also keeps a track of what you have watched a year ago or what you're currently watching and at what time of the day. Well, this data is the first leg of the metamorphical stool. Now what they do, they combine this information with more data to understand the content of the show that you are watching. The data is generated from dozens of in-house and freelance staff who watch every minute or every show on Netflix and tag it. Now all these tags and the user behavior data are taken and is fed to a very sophisticated machine learning algorithm that figures out what's most important and what should it weigh like. Or how much should it matter if a consumer has watched something yesterday? Should that count twice as much or 10 times as much compared to what they have watched a whole year ago? How about a month ago? Or how about if they watched 10 minutes of the content and abandoned it, or they binged through it in 2 nights? So how do we weigh all that? Well, that's where machine learning comes in. What those three things create for us is taste communities around the world. It's about people who watch same kinds of thing that you watch. Viewers are fit into thousands of multiple taste groups, and it's these that affect what recommendation pop up on the top of your screen. The tags that are used for machine learning algorithm are the same across the globe. However, a small subset of tags are used in more outward facing way, feeding directly into the user interface and differing depending on a country language and cultural context, as the tags have to be localized in a way that make more sense. For example, if you know English and you're watching Hollywood movies or movies in English, then in that case, Netflix won't recommend you German movies or Chinese movies or Japanese movie. Alright, the data that Netflix feed into its algorithm can be broken down into two types, implicit and explicit. Explicit is, for example, you gives a thumbs up to the series The Friends, so the Netflix get it. Okay, and implicit data is mostly the behavioral data. It's like you didn't explicitly tell Netflix that you like Black Mirror, but you just binged on it and watched it in 2 nights. So the Netflix understands that behaviorally. So the majority of the data is implicit. So this was about how Netflix is using machine learning to recommend you the movies. Fine. So next we have is the reinforcement learning. Well, in reinforcement learning, what we have is the agent and the environment. The agent selects some action using some policies. So there is no teacher in this case for training the machine. If the machine makes a right decision, the machine gets a positive point. If it makes a wrong decision, it gets a negative point for it. So repeating the process again and again and again, the machine learns it. So this process is of reinforcement learning. So let's take the example of a self-driving car over here. So initially, when the car was trained, so the car didn't know what way to choose. Okay. So what it did, it made an action, but the action it performed was wrong. So it got a penalty of minus 50 points for that. So from the next time, car realized that what it did earlier was wrong, and it updates its policy and then iterates the process. Okay, so this is reinforcement learning. So let me just explain you reinforcement learning with the concept of how Pavlov trained his dog using reinforcement learning. So there's a famous example of how Pavlov trained his dog using reinforcement learning. So it's like initially Pavlov gave food to the dog. So in response to the food, the dog started salivating. Okay, this was before conditioning. Then in the next phase, what he did, he just rang a bell, for which the dog did not respond anything. Okay, then the third phase, what he did, he rang the bell and then gave him the food. So seeing the food, the dog started salivating again. Then after that, he repeated this third step again and again and again until the dog learned it. Then after conditioning, whenever Pavlov used to ring the bell, the dog started salivating. He understood that whenever the bell is going to ring, his master is going to give him the food. So this is how Pavlov trained his dog using reinforcement learning. Okay. One of the application or the use case of reinforcement learning is self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. To err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive number of unnecessary deaths, lives that could have been saved otherwise through self-driving. So this is where self-driving cars comes into picture. The autonomous car or the self-driving cars are much safer than human-driven car. They are unaffected by factors like driver fatigue, emotions or illness. This makes them very safe. Self-driving cars are always active and attentive, observing the environments and scanning multiple directions. It would be difficult to make a move that car has not anticipated. So, how does a self driving car work? Well, self driving cars mainly rely on three technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensor available for a self driving car. For example, sensor for blind spot monitoring, forward collision warning, radar, camera, lidar, and ultrasonic. So, all of these IoT sensors work together to make navigation of a self driving car. Next is the IoT connectivity. Self-driving cars uses cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditioning among others. This helps them to monitor their surroundings better and make informed decisions. And next is the software algorithm. All the data the car collects need to be analyzed to determine the best course of action. This is the main function of the control algorithm and software, and this is where reinforcement learning comes into picture. This is the most complex part of the self-driving car since it has to make decision flawless. A flaw like in case of Uber's self-driving car can be fatal. Okay? In today's world, the most famous self-driving car are those from Tesla and Google. Tesla cars work by analyzing their environment using a software system known as Autopilot. Autopilot uses high-tech cameras to view and collect data from the world, same as what we do with our eyes. It's called as computer vision or sophisticated image recognition. It then interprets this information and makes the best decisions based on it. So this was one of the use case of reinforcement learning.
Linear regression. You all must be remembering the linear equation that we have, right? So what was that linear equation that we used to have in our school days? It was something like this, right? Y equals mx, sorry. So the form was y equals mx plus c, right? So the form was y equals mx plus c, right? This was the form of the equation that we used to be getting in our getting for a linear line, right? So we had this kind of line from that equation, right? It might be, but depends on the value of m and c. I am taking c somewhere is there, so this kind of lines we will be getting. And here let's say this point is x1 y1, so for this one is x1, so this point up here in the line will be x1 y1, right? This point up here will be x1 y1. So for the value of x1 we have this value of y1. So in here, if you see this variable, this was used to be called dependent variable, right? Dependent variable. Why dependent? Because it always changes with the value of x, but x doesn't have any limit. So this is called independent variable, right? This is called independent variable. So x is independent, y is dependent, right? So that kind of equations we used to have. Okay, and this aim here, right? This aim here, this aim used to be called slope of the line, right? This was used to be called slope of the line. This c was some constant which can be zero also, right? C is some constant which can be zero. So that's what we had in our linear line equations. Now the thing is, how do we use this for our class, like for this linear regression models to be built? Okay, so the entire thing is based on this concept only, y equals mx plus c. It is as simple as that. So we will have some kind of a equation which will be in the form of y equals mx plus c. We will predict the values of the data points that is being sent to our data set when it is deployed, and then we will get the values of y. Okay, so that's what is the whole concept of machine learning, linear regression. So linear regression is a technique to find relationship between two or more variables. Yes, right? So if we have more than two variables, then how the equation will look like? It will be, let's say y depends on more than one, right? So it will be mx plus ny, sorry, nz, something like that. So mx plus na plus let's say pc plus d, kind of this kind of equations, right? So here it will have three variables, three independent variables, x, a, and c, right? Three variables we will be having in that case, right? Three variables we'll be having in that case. So that's where this machine learning comes into picture, and that's how this machine learning thing works. Okay, that's how the machine learning works. Now let's see how we are going to use it for our model. So that's why So this is called linear because it is based on the equation of a linear line. Okay, it is based on the equation of a straight line actually. Okay, so as I told, change in dependent variable is associated with the change in one or more independent variables, right? So that's the basic concept of the equations. Okay, next is this picture. This is called Rick Thor, the dog bearer. Okay, so if you see the right hand side, guys who are aware with Avengers, they must be recognizing the right hand side guy is some kind of a Thor. It look like Thor. He carries a dog, right? Instead of carrying a hammer, he carries or a stormbreaker. He is carrying a dog, right? So he is named as Rex Thor, the dog bearer. So there is in the, we know, right, there are seven stars in the planet which has some kind of a shape. So it is one of them. Okay, this is a star pattern actually. So why we are taking this here is, this is the data point, right? In the left hand side, this is the data point, and this is how the thing looks like. So if you draw this line, then this is, I mean, you see like there is a lot of difference between lines, right? So that's how it looks. And there is a concept of r square. R square means mean squared error. Okay, that is also known as goodness of fit. Okay, that we will be covering in the next sessions. So you will see when r square gets minimum, that means the model has huge error. So here, see, the r square value is pretty small, right? It is 0.06. That means this line up here doesn't at all represent this model. Okay, so that's how this linear regression works, and with the help of this goodness of fit r square value, we can somewhat check the model's performance also. So that is a statistical test. At the end of the class, I will be telling you that, like the theory behind it, how those are calculated, and those part. Okay, so that is what is about linear regression. It's that much easy only. Okay, it's nothing more complex. More, not much of a complexity is there in the in this linear regression. So it's far too easy. So next, there are a few examples of linear regressions. Okay, so where, yeah, I told, right, Ravi. So r square I will be coming later. It is a mean squared error. So it is a goodness of fit test. That is a r squared test, you can tell. So I will be coming to that in the last part. Okay, I will tell you the theory and everything also. No need to worry. Okay. So this is the regression is a technique that displays the relationship between y and x, as you already know. So if temperature drops down, the guys will start putting more jackets, more jackets to avoid the cold, right? To keep them warm. So that's a straightforward relation between two variables. This is an example of linear regression. Okay, temperature versus number of cones sold at the ice cream store. If it's gets hot at outside, then the number of ice cream sold will be more, right? Inches of rain versus new cars sold. So that means in the rainy season, guys would like to avoid going out without their car, right? So that's how. Daily snowfall versus number of skiers. So if snowfall is higher, number of visitors at the skiing park will be increased, right? So that's how this works. Now this is the base of it. So if you think there is a relationship between two things, regression would help confirm it. That means if at all there is a relationship between those lines, let's say I will draw you a plot first. Okay, so let's say here is a plot I am drawing. Come on, why it is too large? I want something smaller. So if you see there is so some data points, let's say this one, say this one, say this one. So see, here is a perfect relation, right? But again, this is not a linear relation, right? So if you draw it otherwise, if we say there is kind of a this line goes in, so this is the best linear regression line that can be fit in, then also this doesn't seem to be a good relation between them, right? So linear regression will help you to understand if there is any relationship between two variables or not. Okay, so that's how linear regression works. So you will build a model. If the model performs poorly and no ways you can fine tune the model, that means there is not much of a linear relation between them, right? If there is a linear relation, then it will look good, right? So the goodness of it would look good. So here is an classic example. So if you see, the values here are categorical, right? Why categorical? Because y only has two values, y0, y1, right? Only two values. So in this two values, if you see, they are categorical values, and it comes under a lambda shift function, right? I mean, sorry, sigmoid function, this kind of. right? S kind of a function. So this is called sigmoid function, right? So that's how this thing goes in. Okay, so here if you draw the linear regression line, it will fail miserably. Okay, because if you calculate the r square fit for this, it will be too low number.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Because it is not at all a good fit, right? So this one is an example of linear regression, this one is for logistic regression. So to see how this linear regression helps here, if you draw this line, if you build this model using this line, then only it will be cleared that there is no linear relationship between these two data points. Okay, these two data points. Okay, so that's how it goes. Okay, so next we will be going to a few scenarios when we can use linear regression, and when do we go for logistic regression. Okay, these are a few types or a few factors which will help us deciding that. Okay, so see here, first of all, it will be continuous. For linear regression, the variables has to be continuous. That means it shouldn't be categorical or skewed at any 2 points, right? So it will solve regression issues. That means it should be a good fit. Okay, good fit to a point to some data points. Okay, and it should be somewhat it should be represented by a straight line curve. Okay, so in this case is match, so then it will be a perfect fit for linear regression. So it has to be continuous variables. That means the spread of the data, it shouldn't be skewed, so it should be somewhere it should be spread out evenly among this in the xy plane. Actually, it should have a straight line kind of a relation between them, and it should solve regression issues. Regression issues means where we have a lot of data, we churn those data to find out some basic data, basic inference. When I say this, both of these are supervised learning algorithms, so don't confuse that. So here what we'll have, we will be for both the cases, for both the cases we will be having this values, right? Like we will be having training values, right? But here we will have some output, that will be spread throughout the that will be somewhat significant, not some classification things like 0 and 1, the gender split, male or female. It is a classification issue. A spam or not, classification issue. Predicting housing price, linear regression. Okay, this kind of things comes under linear regression. So if you see if you build a model of a housing price predictor, there has to be some kind of a relation between all the variables, right? But for classification, it has to meet some criteria. There won't be any relation between those criteria individually, but there should be there should be a skewed value, and the variables will be categorical. Okay, when I say variables, so can anyone tell what is a variable? When we are telling variable, which one we are telling, like what we are actually trying to tell here when we are telling continuous variables and categorical variables? What are those? So if you get a data set, let's say there are 10 rows with 15 columns, so which one are we are telling about target variables? Okay, those parameters which impact the outcome, like dependent variables. So let's say if we have 10 rows and 15 columns, then 14 columns in that will be independent variables. Those are x values, they can go anywhere. Okay, the variables, the target variables will be the dependent variables, right? When we say continuous and categorical, that is the dependent variables, that is the y values, that is the outcome values, right? Because independent variables can be anywhere, right? It can be anywhere in the plane, correct? So that's why when we consider fitting a model, we shouldn't be looking at the feature first, we should look at what kind of output we are expecting. So is the output is somewhat categorical or regression? What is it? The outputs will be in continuous variables. Let's say housing price. If you have 10 lakhs rows of data, so you are most probably will be having all the numbers between 20 lakhs to 1 crore, right? Depending on the scenario. So that's a continuous space, correct? But categorical things, when we are deciding on mail classifier, spam classifier, right? Spam or not, it's two values, 1 0 or 1, right? So categorical things, right? So that's how we decide on this linear regression and logistic regression. Okay, so it's y here, it's Nancy, it's y here. So when I tell the outcome, that is a y, right? That independent variable. For x, those will be independent ones, they can go anywhere. Those will be the features of your data set. on which you will build the models. When you say y equals mx plus c, this x will be independent one. It can go anywhere, right? So you really can't judge from that, right? Because for a categorical, I mean, if you think for a spam classifier, what all things can be there? What all things? Okay, let's forget it. Okay, think about Titanic survival dataset. So let's say you have the dataset of surviving from Titanic mishap, and you have all rows in there, right? So the values will be like sex, age, which parts they were in, right? So those things will be there, right? So let's say we have a housing price dataset. Okay, so in the housing price, what kind of columns you will have? Let's say area. So let's say we have a point called area. Okay, we have something called garden space. Okay, we have number of flats, amenities. These all can be realistic features. These all can be realistic features of your housing price predicted dataset, right? So with the help of this, we will predict a housing price, correct? Let's say we have a survival dataset. Let's say cancer dataset. Okay, so for predicting cancers, we have a dataset like that. For that, we will have internal or external. Let's say some kind of some things like that. Come on, again it went to scratch mode. Internal or external, right? Then we will have a size. We will have malignant or benign, etc, etc. Okay, so what it will predict, yes or no. So you have a gland growth, is it a cancer or is it not? So yes, no. These variable types are called categorical ones. Okay, this kind of variables. So let's say if you are trying to buy a house somewhere in Mumbai, this value will range from 1 crore to 5 crore, and you are most likely to get this area because of this different size, different types of area values. You will get almost all the values between this range. Let's say 1 crore to 2 crore. Let's not go to 5. Let's go to 2. Okay, so you will get all kind of values. So this is the things. Okay, so that's how you need to predict which one to use, right? So usually fixed number or possible. No, Saran, actually categoricals will be skewed. Okay, so it can be more than one also. Let's say we have, when we are thinking about this kind of categorical problem, it can be yes, no. It can be yes, no, or moderate like that. So it can be anything. It will be fixed. Okay, as you rightly told, it will be fixed. But for continuous, it will vary. It will be in a range. Okay, so that's how we decide if the data set that we are having is categorical or continuous. Okay, so based on that we decide, is it a regression problem or is it a classification problem, and based on that we are going to choose our models. If it's a regression, then we are going to go with this linear regression. Otherwise we are going to go with logistic regression, naive Bayes, or xyz. Okay, that's how. So that's the line equation. These are the some variables. These are called observables. This red points, this line is called line of linear regression. That means this is the outcome of your model. This points will be observations, right? And this will be regression line. And how do we decide if the regression line is a good fit or not? We use least square method. Okay, least square method that we'll discuss. Okay, so how do we do that? It's time to discuss that. I will show you with the graph. So let's say we have this kind of a line. Okay, let's say we have a point here. This is x1 y1. Okay, we have a point here. This is x2 y2. Okay, we have a point here. This is x3 y3. Okay, let's keep it to 3 lines. Okay, and somewhere down here, based on this line outcome, okay, this one is regression line. This will have separate kind of xy value. So for this one it will be somewhere here, for this one it will be here, and for this one it will be here. So these are like, here is the y value, here y value for this will be somewhere here, for this value will be somewhere here. So mean of them will be this one. Okay, let me change the color. Okay, mean of them will be this 3, so somewhere around here. This is the mean. Okay, this is the mean of y. Okay, which will denote as y bar. Okay, we will denote as y bar. Okay, now see the basic concept. how do we calculate, okay, the basic concept of how do we calculate this, okay, how do we calculate the r square. So these points, if you see, these blue lines are called error from line, okay, error from regression line, okay. If I write the equation, that is, we are going to, so as you know, the point distance, how it looks like, x minus x1, y minus y1, right? So that is basically this. So here x1 will be common in both, so it will be the value outcome of this AC line, that is squared error SE for line SE. I am scrolling it a bit up. So we will, what we have, SE of line will be y1 minus y squared plus y2 minus y squared plus y3 minus y squared up to n. This is the standard line error, because this is, if we consider this as y1 and all these values are x's, right? So when I write x, when I write y, that means y actual, okay. When this y3 means y predicted, okay. So sorry, I just reverse it, okay. This is y actual, this is y predicted. So when I say y1, y2, y3, these are these points, right? So these are the original points that we have, so it will be y actual, y means y predicted, that is outcome from this line, okay. So y actual, y predicted, like that, okay, for x1, for x2, for x3, okay. This is what is denote squared error from the line of linear regression, okay. This is what is denoted by this. Now I will change the pen color. So if we see squared error from y bar, that is y mean, that is from this red line, I was using a red, let's go back. So this is the point, this is the red line, so this one is the squared error from line. So here is the point, so this one will be the squared error from the mean of the data set, okay. This is the squared error from the mean of the data set. So what we will have, we will have y1 minus y bar square plus y2 minus y bar square plus dot dot up to n, right? Now understand one thing, this value over here is how likely, how, what is the error between the linear regression line and the data points, right? This value up here is to find out the central tendency of the errors, right? So if you find out mean of these values, this y predicted values, and if you find out the difference between the actual points and the y predicted mean values, that means this is the variance, okay. This is the distance and this is the variance, okay. This part is the variance from all y values, this is the distance from each and individual y values. Now in order to get the r square estimate, that is the good fit line, or if it's a good fit or not, what we do, we calculate this value, that is se line divided by se y bar, okay. We have this kind of a value. So what this denotes, how unlikely the line matches the actual values, okay. This is what we denote by this part, right? Now if you want to know how good is the model, what we do, we subtract it from 1. This becomes our goodness of fit. For statisticians named it as r squared, or it is also known as least, this is also known as least squared error method, okay. So this up here denotes goodness of fit, that means how good our model is. Now see what happens to this, okay. After this, I will pause for questions. So the value that we have, right? So the value that we have is somewhere like 1 minus SC line. So 1 minus SE line divided by SE y bar. So if AC line is pretty smaller, right? What does that mean? The line is a really good fit. So this is small divided by SC y bar. This will also get very small, right? If the difference between each and individual data point is small, this will also get somewhat small. A small number by some number will yield you a small, even a smaller number, right? So that will approx reach to 1. Okay, but if for this equation, the the SE line gets higher and we have AC y bar which will get even higher, which will get somewhere around this, right? So, but it shouldn't be, as this is the higher but less than AC line. So we will have a high value up here. In the AC line, we will have a high value. Okay. So this, so how it works, this AC y bar, let's say for this equation, if we go back, if the points are even more down, right? So from, if the point is somewhere here, so somewhere here, all the values will be bigger, right? Based on this AC bar and the AC line, all the values will be bigger. So when we divide two big values, it will almost come to 1 and r square value will approx to 0. Okay, so that's what means when r square is small, bad fit. Okay, when r square is large, good fit. Okay, that's why this value r square is named as goodness of fit. Okay, so that's what is about this goodness of fit equation. Okay, these things I already told, this xy things. Now here is an example for you guys. Okay, so we have a few data points, we have plotted all this in the plot. Okay, we have plotted all these data points in here. Okay, now we will see using linear regression how do we calculate this. Okay, so x bar y bar is there, that is the mean of x and mean of y. Mean of x is 3, mean of y is 3.6. Now this is the line, this is the line, and this is the mean point is described with this red point, and this line, right, this green line is for the I mean the mean line. Okay, this is the mean line that we have, that is the y bar that we have. This is the mx plus c line that we have drawn till now. As we know from maths, this is the equation for m, that is the slope. That's how we calculate. So once we calculate m, you will see the value here. I am just scrolling through. Okay, these are some calculations, so I am not wasting time. So that's how we find out the value of m. Okay, so what does that mean? Let me show a few use cases. So if this is the line, now we need to find out value of m. M is x minus x bar into y minus y bar divided by x minus x square, x minus x bar square. Okay, now if we go in, so x minus x bar, when we calculate, that is the difference of the data points from its x mean. Okay, x mean. So these are the data point differences. We calculate this here, we put into the equation, then we go for difference of y, that is y bar, because we need to calculate y minus y bar here, right? So this will be the differences, so this one will be the difference, this one will be the difference, like that we will calculate. Okay, so that's how we will have y minus y bar. We already have x minus x bar, we will square it out here. Then we will find out m by summarizing all this. We will sum all these things up and we will divide it by sum of this thing, and we will get the output. Okay, we will get the output. So here m value goes to 0.1. Okay, now y will be 3.6, m will be 0.1, x will be, let's say for 3 we are calculating. Okay, for 3, x equals 3 we are calculating, because as we see, for x equals 3, the mean is 3 and 3.6, right? So for x equals 3, the mean, we are calculating based on the means here. Now we will get the c value here, that is 3.3. Okay, so our straight line equations now becomes y equals 0.1x plus 3.3. Okay, So that's how we do calculate our linear equations, logistic regression session. Okay. So one thing to understand, first thing is regarding machine learning, right? So broadly there are two types, like supervised learning and unsupervised learning, right? So for supervised learning, we will always have a definite objective. It can be something, a continuous set of variables, or can be categorical variables. Okay. And for like unsupervised learning algorithms, we will always be having a indefinite output, let's say cluster of points kind of things. Okay. That will be I mean, for supervised algorithm, whatever data we use, it will consist of a level. It can be a continuous set of variables, or it can be categorical, that doesn't matter. Okay. So it will always be, the data will be definitive. It will give you some kind of a output. Now if so why do we need this kind of a different set of algorithms, right? When we are dealing with linear regression, why don't we have, or why do we have this logistic regression, which is a classification algorithm? So the thing that you need to understand, for linear regression, if the data is continuous and spread across a good amount of range, then only the line can help you in predicting the values, right? But instead, if it's a categorical problem, like where the data is skewed in two ends, or three ends, like let's say values of 0 and 1 are the best scenarios that we have. So typical examples of logistic regression would include, typical examples would include, like uh, tumor prediction, is it a malignant or benign one? Okay. It would be spam classifier, it will be fraudulent transaction detection. All those kind of things will come under logistic regression. So as you can understand from the name itself, here the data will be too skewed, right? It will either have a yes or no value, or you can say it like 0 and 1. So if you have, let's say, 10,000 data points skewed between 0 and 1, there cannot be anything which sits in mid of it, right? It cannot sit between 0 and 1, right? So it should be at the two fag ends. So if you draw a line from two ends, what would do, that would be horrendous for a linear regression model to fit in, right? So why so? I Unweighted decision tree is something else, and the logistic regression is something else. So it's those two are different things. So don't just confuse the algorithms. Okay. So when I am going with one algorithm, stick to that. If there are any relations between them, I will also cover that, which is sadly there are nothing. Anyways, so to continue with it, for this kind of logistic regression problems, the data will be skewed between 2 points, right? So if we draw a line between point 1 to point 2, if it's a straight line, then also it won't fit the data. When I am telling this, what do I mean? I will shortly show you that. Okay, so what do I mean with that? The data will be skewed and the line can't fit it, right? So let me open this. Okay, when I say that the it cannot fit the data, right? We saw for linear regression how the models worked, right, and how the data points look like. But let's say what we are talking about today is, it will be some kind of a graph like this. If you plot the observations, right, then I mean, when you plot the outputs in a graph, in yesterday also we did the same thing, and we saw there was a continuous set of variables. But here what it will do, yeah, so it will be, let's say these are some data points which will be near 0, right? These will be some data points. So the output of this will always stack to 0, and output of all this will be stacked to ones. Like that, this kind of a set will be there. So if you draw a straight line, it would only fit 1. It can fit max of 2 values. It can fit max of 3 values, like that, right? So in that case, what would happen? The model will fail radically, because the error percentage will be huge, right? And it won't be fitting a good model. So that's why we won't be able to use linear set of regression, linear set of models to fit in this kind of a requirement. Instead, we would need this kind of a curve, right? See, now this fits in perfectly, right? This fits in perfectly in the under training example. So this curve is again called, sigmoid function, right? This x-shaped curve, S-shaped curve. So what is the features of it? It will it is an asymptotic curve, right? When do we say asymptotic? That means it will never reach 1, it will never reach 0. Okay, so what it will do at positive infinity, at positive infinity, it will asymptote to 1. At negative infinity, it will asymptote to 0. Okay, so it will never match the lines, but it will be asymptotic. So in this kind of shapes, we can have some kind of a good fit for this kind of classification problem. Yesterday's thing was based on a straight line equation, right? It was a y equals mx plus c. This kind of a straight line equation was yesterday's topic of discussion. But today's topic of discussion will be this kind of a asymptotic curve. Okay. So before going to this, I will be covering one more. Okay, I will come to that later. So this curve equation is this 1 by 1 plus e to the power minus x. So this curve, as you see, it will asymptote at the positive and negative infinities, right? So if you see e to the power minus x, then if you set the value of x as minus infinity, what would happen? A very large number will come at the denominator part, which will force this value to go to 0, but it won't be 0. But as you know, infinity is a big number, so infinity plus everything will be infinity itself, right? So it will be very near equals 0. But if it is positive infinity, then e to the power minus negative infinity will be too small to be considered as 0, right? So this value will asymptote to 1. So that's how the sigmoid function works. And we will establish our logistic regression functions and everything based on this function itself. Okay, this function itself. So now what I will do, I will go to the PPT and will cover the things that are there. Okay, then I will again come back to the curves and all. So this is how the basic concepts of logistic regression stands. So this is how this sigmoid function comes into picture instead of a linear regression line. Okay, so I explained the basics of it. Now let's see with an example. Okay, so someone is asking you to, hey, see, I want to buy a property which will have a bigger garden area for some amount of money. Okay, so what we will do, we will do a simple linear regression, right? So what we will do, we will have the dependent variable as property size. So we will have an independent variable of money. So it's obvious, right? If you want bigger garden area, that means your property size has to be bigger, right? So you need to spend more money than before, right? So again, it has many other many other criteria, but let's have this fixed. Okay, let's say the locality is fixed, the area is fixed, that the village or the town or the city is fixed where they're trying to find the house. So if you consider there are only two external variables, that is money and dependent property size and money, then in that case what we will have is we will have a linear equation between these two, right? So their linear regression will perfectly fit in. Yes, Giri, so that's what I told. So property size, so that's how it is. So next point will be, so bigger garden area means there will be smaller house area. So we are I mean, what we are doing here, we could have taken a multivariate solution here, but we are going for a small part. So we are breaking it into chunks. Okay, so when we are searching for bigger garden area, what does that mean? That means the house area will be smaller, right? So in a property, if a house is there, let's say we want to buy 1,000 square feet of 2,000 square feet of property. In that garden area we want of 900 square feet, so the house area will be shrunk to 1,100, right? So that's how. So here also a linear equation exists between them. Why? Because if you make the garden area large, the house area will come down, right? So house area and garden area size will also have a linear kind of equation. This can be solved using linear regression. So this kind of problems can be solved using linear regression, because this is not categorical. The data will be continuous. So the value, the size values or the price values, when you plot it, it will be linearly dependent between them, and as it is a continuous value, so linear line will fit it. There might be errors, there might be estimation errors and all, that's fine, but it will fit a linear model, so we can predict those kind of things using linear regression. So what we can say from this, like, if the guy who is asking you for buying a house, if he spends X amount of money, he can buy y amount of y area of a house, okay, y property area he can buy. So this one you can comment from linear regression. But let's say the guy wants to ask you, so the property will have a good neighborhood, will the location be noiseless suburb or a busy bustling city? So how the properties, what is the location of the property, that kind of preferences someone wants to ask you, then you will be in a soup. So see this problem statement, will the property have a good neighborhood or not? What the values it will have, it will have a categorical value 0 1, right? So again, if you plot here, if you plot those 0 1 things here, like I saw, described in the plot before, it will be skewed in 2 points. So if I draw a linear line, it will feel radically, right? You can't predict it. So if I go back to my plot, let's say we are trying to deal categorical problems using a linear regression model. So I will draw it again. Okay, so let's say these are a few values. Okay, these are zeros, these are one. So I have a data set where this neighborhood is also given, and neighborhood is given as like good neighborhood or bad neighborhood. So this is good, this is bad, this is bad. Now let's say I draw this line. Okay, so now let's say some property is bad. So but what it will do, let's say we want to know if the property has this kind of a value, then what is it? So it will predict the values in here, the y value will predict in here. So will be this one will be your value. So what can you comment on this? So the value coming will be around 0.3 or something. So there will be a lot of error, but it should have been coming as 0. It will get worse till you once you move to the top of the line. So it depends on the line that you draw actually. So come on, why it is not going? Yeah, so let's say some point here for x here, the value will be coming up here, right? So this will again go to a good property, but there it should have been a bad property. So this kind of problems won't be, you won't be able to solve using linear regression models. Okay, this kind of problems you won't be able to solve using linear regression models. So in this case you need that funky s-shaped curve, that sigmoid function curve that we shown here. Okay, so that's the whole idea. So this kind of a classification problem linear regression won't be able to answer. So you would need to apply logistic regression models to this, and this will help you in answering classification problems. So this is the never ending loop that it will go on. Okay, so will the property have a good neighborhood? Will it rain tomorrow or not? Is the mail spam or not? This kind of small questions, this kind of small classification questions, it can answer. Okay, so let's go ahead with this PPT. Okay, so see, machine learning, supervised, unsupervised. Supervised is again divided into two broader categories: regression, classification. Regression we already covered, linear regression. Today we are going to cover logistic regression. That's another classification problem. There are many others. We will come to those one by one, but these are some major chunks. Okay, so a statistical classification model, as you already know, this machine learning, heart of machine learning is stats. Next is deal with categorical dependent variables. Explain this. Could be binary or dichotomous. So that means it should be having two values, not more than two. It could be multinomial. Yes, obviously it can have only one feature of x. It can have multiple features x, right? So yesterday we saw how it does for univariate and multivariate machine learning linear regression models, right? Same thing applies for logistic regression models also. So x can be only one feature or x can be a set of features. So that's where that way it can be either multinomial or it can be univariate. Okay, it can take both continuous and discrete input data. Yes, because this kind of a s-shaped curve can also fit continuous data also, but again in that case it will have a lot of errors, right? So continuous variable, if you plot using a s-shaped curve, it will be giving you some model, but the error will too high to explain. Okay, so that's why we don't really specify it. So we only consider of this categorical data. Okay, for continuous variable also you can plot this, but it won't be helpful because it will be having some problems, right? Because it won't be able to take care of continuous variables. Okay, so that's why we have linear regression models. Yes, sure. So for multinomial, it is like, let's say we are trying to find what should we find? Spam classifier. Let's go ahead with the example that we have. Okay, so for spam classifier, if we think there is only one feature to be, that is count of spam words. right? If we think this is our only feature, so what do we mean by spam words? It will be misspelled words, right? It should have bought like this. It should have sell, buy, money, transfer, bank details. This kind of words are very commonly noticed in spam classifier, right? So if we want to build a spam classifier using only count of spam words thing, right? Only count of spam words thing, then it will be univariate. Now, if you have noticed spam emails, it has one more feature also. Like for spam emails, the sender address will be fishy. The sender address will be fishy. What do we mean by fishy? The domain name will have some absurd kind of a values. It might not be a permanent domain, right? So if we take that also in account for building a spam classifier, it becomes multinomial. Why multinomial? Because okay, let's so why multinomial? Because we know we denote feature vector by x, right? So if x contains only one value of x1, then this is univariate, okay? Because the number of independent variables in here is only one independent, right? So whatever has to change will change with the value of x1 only. But if x contains more than one, that is x1, x2, xn, so it might happen that among these n features, all n features are useful. It can happen, or it can happen some, let's say 10 features are useful, okay? Others might be junks, but it has 10 features, so 10 independent variables, right? So as we have 10 independent variables, what it does, it will have like 10 layers of x versus, so it will have a 10 independent variables. So the y value that we are going to predict will have multiple features in it, right? Will have multiple features in it. So we need to fit in more than one feature vector in our machine learning equation. So if I go back to this equation, like we see here, this is the equation for linear regression, right? So if we have something like this, 1 plus a to the power minus, I will come to the derivative, I mean machine learning form later. Like this, if we have, then it becomes a multivariate problem. This is a univariate problem, okay? So that is how it depends, because here it output of the model will depend on more than one independent variables. So that's why this is called multinomial, okay? So that's what the idea is. That's what is about multinomial and univariate things. So here also we can predict, here also we can have this kind of we can use clustering algorithm to predict the data, okay? We can use this kind of algorithm to predict the data, okay? So for clustering, what happens, as a point came in, I will show you. For clustering, divide data in unique sets, right? So that is what is called clustering. So the sets can be 0 1 also, the set can be cat, dog, fish also, right? So the both type of problems can be solved using clustering, but for classification it won't fit this purpose, right? That is the whole base of our statistics. So for clustering we will have a different set of algorithms there. If you see, there no kind of a machine learning model will be there. There will be a generic set of steps that we need to follow. Stats will be there, but it will be in the minimalistic part, okay? So that's how it works. Okay, let's go ahead. So this is a tool for applied statistics for discrete data analysis. You already discussed. Gives outcome in terms of probability, right? That's what it does, right? So what the model will do, the model will give you a probabilistic output. Like let's say for this email to be spam, the chances are 70%. We will convert that to 1. We will see this. So this is again based on probabilistic models only, okay? So this logistic regression will be, the probability will play a big role here, because see, one thing you need to understand, when we are going for logistic regression problems, yes, this the equation that I have shown, this will be the curve equation that we have. That's true, that's not a problem. But the thing is, when you are predicting the output, so what this value will predict, this 1 by 1 plus a to the power minus x, it will never predict 0 or 1. Perfect 0 1 1 it would never predict, right? Because it is an asymptotic function. So at an infinite values, you won't be giving to the function. Then the function will stack. The function will be looped in for forever, right? So it will output some values from 0 to 1. So that will be the probability of that problem. Let's say the email probability of probability of email being spam, right? So this kind of outputs it will give. So when it gives greater than equals 0.5, we can consider this to be 1. Less than 0.5, we can consider it to be 0. That's how the maths tells us. So this is again this kind of things will predict the probability of the event being happening. So probability theory also will play a big role here. Okay, so that's how this works.
What you can do with machine learning. In today's session, you will see what type of question you can ask your machine with classification algorithm, anomaly detection algorithm, clustering algorithm, and regression algorithm. I hope the agenda is clear to you guys. So without delaying any further, let's start with what type of question you can ask your machine. Well, you can get answers of these questions like what types of house lies in this segment, or what is the market value of this house, or is this mail a spam or not spam, or is there any fraud in this transaction. So all of these kind of question comes up under the category of machine learning. So let's move on ahead and see some of the machine learning algorithm and what type of algorithm can deal with these kind of question. So on first we have classification algorithm. So using classification algorithm, you can predict a category using the data. For example, is this person a male or female, or is this mail a spam or non-spam? So these type of question, it comes under classification algorithm. Or is it going to rain tomorrow or not? So all these type of question comes under classification algorithm. Next is anomaly detection algorithm. It is generally used to identify unusual data points. For example, is there any fraud in this transaction, or is someone trying to hack our network? So these kind of question comes under anomaly detection algorithm. Next is the clustering algorithm. Well, clustering algorithm groups the data based on some condition, like which type of house lies in this segment, or what type of customer generally buys this product, recommendation engine, right? So these type of question comes under clustering algorithm. Next is a regression algorithm. Well, this is used to group data based on some condition, like what is the market value of this house, or is it going to rain tomorrow? So these were some of the various machine learning algorithms. Next, we have machine learning for you. You have few links which you can just go out and see some cool machine learning projects you can use. Perform a hands-on on machine learning. We'll be loading a dataset, understand its structure using statistical summary, and finally create 6 different machine learning model and pick the best of it. Okay? Well, there's a little piece of advice for you guys. If you really want to learn machine learning with Python, so I'd suggest you to complete an end-to-end project. At least it'll force you to install and start your Python interpreter, right? It'll even give you a bird's eye view of how to step through a small project. And once you complete one of the project, you will get a confidence, and maybe you can go on and start with your own small projects. Okay, so as a beginner, when you are applying machine learning to your own dataset, you are working on a project. So a machine learning project may not be a linear. It may have a number of steps, like define the problem, prepare the data, evaluate the algorithm, improve the result, and present the results. So the best way to really come up to terms with a new platform or tool is to work through a machine learning project end to end and cover the key step, namely loading the data, summarizing it, evaluating algorithm, and making some predictions. So once you complete it, you will have a template of your own that you can use on dataset after dataset. So you can fill in the gaps such as further data preparation and improving results task later once you have more confidence. Okay, so let's move ahead. Things you will learn after this session. So once we are done with this session, you will know how to load the dataset, how you can summarize it, how to visualize your dataset, how to evaluate some algorithm, and finally you will learn how to make some predictions. Okay, so let's move ahead. So we'll be performing the demo on iris flower dataset. Well, the project which we are going to perform is generally known as the hello world of machine learning. So it's the best project to start with because it's so well understood. Okay, and why it's so well understood? Because so all the attributes in this dataset is numeric. So all you have to do is figure out how to load and handle the data. So it's a classification problem, thereby allowing you to practice with perhaps an easier type of supervised learning. Okay. It also supports a multi-class classification problem that may require some specialized handling. So this iris dataset consists of 4 different attributes: sepal length, sepal width, petal length and petal width. And it consists of 150 rows, meaning it is very small and it can easily fit into the memory. All the numeric attributes are in the same unit and the same scale. Okay, so this dataset doesn't require any special scaling or transformation to get started. Okay, so let's get started to your Hello World machine learning project in Python. So this would be a step-by-step tutorial. So let's get started with your Hello World machine learning project in Python. Okay, so this is my Jupyter notebook. So the very first thing that I'll be doing up here is importing all the required libraries. So I'm importing pandas, and from pandas I'm importing scatter matrix. Next I'll be importing matplotlib as PLT. Then we are importing model selection from sklearn, classification report from sklearn.metrics, confusion matrix from sklearn.matrix, accuracy score again from sklearn. And these are various machine learning models.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Okay, KNN classifier, linear discriminant analysis, Gaussian naive Bayes and support vector machine. Okay, so we are importing all these models from our scikit-learn library. Okay, so let's execute it. Our next step is to load the dataset. So the very first parameter that I'm passing up here is the URL of my dataset. Okay, or the path of my dataset basically. So this is my dataset, just to show you. So this link consists of my dataset. Okay, next I'm defining an array as names. This consists of the name of the attribute, sepal length, sepal width, petal width and class. Okay, and next I'll be defining a variable as dataset, and next I'm defining a variable dataset. So dataset equal pandas.readcsv URL comma names equal names. So what it is basically doing, it is fetching the data from here, from this link, URL from this URL, and it is giving the name of the attribute as all these: sepal length, sepal width, petal width and class. Okay, so this will basically load your dataset. Fine, let's execute it. So our dataset is loaded. Now let's summarize the dataset. Now let's check how many rows and columns do our dataset have. So let's execute this and check the shape of our dataset. So our dataset consists of 5 different columns and 150 rows. Okay. Next, if you want to check the sample dataset, then you have a head function over here. So this will give you first 20 result of your dataset. Okay, 0 to 90. Fine. Next is the dataset.describe function. So this will give you the various description from your dataset, like count, mean, standard deviation, minimum, percentile, 25 percentile, 50 percentile, 75 percentile, and max. So count is basically the total count of sepal length, sepal width, petal length and petal width. Okay, similarly mean of all, similarly standard deviation and so on. Okay, next, what if I want to check how many different classes are there or how many values contains in each class? So we'll group by the class and we'll find the size of each class. Okay, let's execute it. So we got the output up here as iris setosa 50, iris versicolor 50, iris virginica also 50. So this means that we have 3 different classes: iris setosa, versicolor and virginica. All 3 of them consist of 50 values. Okay, fine. So next is data visualization. So now that we have some basic idea about our data, let's create some visualization out of it. So we are going to look at 2 different types of plot. The first would be a univariate plot, that is to understand about each attribute, and next would be the multivariate plot to understand the relationship between the attributes. Okay, so first let's plot a univariate plot, that is plot of each individual variable. Okay, so this is the univariate box and whiskers plot. So let's consider just sepal length. So the bottom part of here, this represents the minimum value and this is the maximum value. Okay, and this green bar over here, it represents the mean value. So if you see the mean of sepal length, it's around 5.84. It's also representing the same. So it's 5.84. Okay, these circles above and below the minimum point are nothing but the outliers. Okay, yeah, one more thing, the minimum and the maximum value, right? So minimum is 4.3 for sepal length and maximum is 7.9. Okay, so the minimum value you got up here is 4.3. Okay, so this is my 4.3 minimum value, and here we have the maximum value as 7.9. Okay, and these are the outliers, these circles. Similarly for sepal width, my minimum value was sepal width was 2.0 and maximum 4.4. So minimum from here is 2.0, this value, it's an outlier, and the maximum value is 4.4, this value 4.4, it's also an outlier. And the mean value of sepal width is 3.05. So we got mean somewhere around here. Okay, So in order to understand our data in a better way, we created a univariate box and whiskers plot. Okay, this gives us a much clearer idea about the distribution of the input attributes. Okay, well, if you want, you can even create a histogram of each input variable to get an idea of the distribution. Okay, so let's execute it. So there's my histogram. So in sepal length and sepal width, I can find the Gaussian distribution up here. Okay, so this is a useful to note as we can use algorithms that can exploit this assumption. Okay, next we have is the multivariate plot. Well, multivariate plot is used to check the interaction between the variables. Okay, so let's just execute it and see what's the output. So here's a scatter plot of all pairs of attribute. So this can be helpful to spot structured relationship between input variables. Okay, so as you can see, we have diagonal grouping of some pair of attributes. So this suggests a high correlation and a predictable relationship. Okay, so from here you can say that sepal length is more dependent on sepal width as compared to petal length and petal width. Similarly, same thing over here, right? So petal length is more dependent on sepal width as compared to sepal length and petal width. Okay, and the petal width, it's more dependent on sepal length as compared to sepal width and petal length. Okay, so these are the things that we can conclude after visualizing our data. Okay, now it's time to create some model and estimate their accuracy on unseen data. Okay, so here we'll follow step-by-step procedure. Okay, first we'll separate out a validation dataset, that is divide our dataset into train and test part. Then we'll use a 10-fold cross-validation technique that will randomly distribute our data into 10 different data sets. Okay, so that we can perform training and testing on each part. Then we can finally combine the result of all of them to get a better accuracy. Okay, then we are going to build 5 to 6 different models to predict species from flower measurement. Okay, and then finally we'll select our best model. So our first step is creating a validation dataset, that is dividing our dataset into train and test. So here what we are doing, dividing our dataset into train and test. Fine. Array equal dataset dot values. So it consists of all the values inside your dataset. Here you're defining x equal array starting. So here you're taking a portion of the array. Okay, and you're placing it in x. So what is that? So your row up here is nothing. So it will start from the very first row and the column 0 to 4. So it will take up to fourth column. So 4 column from the first row, that is x is storing all the name of the attribute. Fine. Similarly, we are defining a variable y. So y will consist of the fourth column. Next, I'm defining a variable y, array of starting from first row and fifth column. Okay, as 0, 1, 2, 3, 4. So here number 4 represents my fifth column. Okay, next I'm defining a validation size as 0.20. So here validation size means it will split my data as 80% in one part and 20% in other. Okay, so next we are defining a seed value. So this seed value is used to initialize the randomization. Saving or setting it to same number each time guarantees that every time you execute the algorithm, it will come up with the same result. Okay, next we are defining scoring as accuracy. And here we are defining x train, x validation, y train and y validation. So here we are defining x train, x validation, y train and y validation. So x train would be my training data from this part and x validation is the testing data from same. Okay, so according to my above code, my 80% of the data will lie in the training part and the rest 20% would be treated as a validation data or the test data. As I have already mentioned, the validation size is 0.20 or 20%. So this means that 20% of my data is test data. Fine. Similarly, we'll define y train and y validation. That is 80% of the training data from this array and rest 20% of the testing data from same array. Okay, so here we are basically splitting our data set. Okay, on the base of x, y, test size equal validation size that we have already specified as 0.20 and my random state equals c and my random state is c. So every time I execute it, the algorithm will come up with the same result. Fine. So now that we have created a split among our dataset and we have divided our dataset into train and test, so our next step would be to build our model. Okay, so this is how we are building our model. Okay, so from the scikit-learn library, we are calling logistic regression, we are calling linear discriminant analysis, KNN, decision tree, Gaussian naive and SVM or support vector machine. Okay, here what we are doing, we are creating 10 folds. Okay, so 10 folds, let me just go step by step. So here we are defining a variable as k-fold. So k-fold equal model underscore selection. K-fold, how many split we want to perform is 10 split, and random state again, see, that is 7. So every time it will perform the same random split. Okay, so this is how my data would be splitted into 10 different parts. Okay, now once the data is split into 10 parts, then we'll define a variable as cv underscore results. Okay, so cv underscore results equal model selection dot cross validation score. Inside that we are passing our model, what model we are choosing. We are passing the X train data, the Y train data, CV equal K fold, whatever the value of K fold is there, and then finally scoring, which we have initialized up here as accuracy. Okay, then what we are doing, we are appending our result. So our CV result would be appended to results, that is to this list. So next we have is result dot append CV underscore result. So this list would be updated with the CV underscore result value, and here we are appending the name, and finally we are printing our desired result. So one by one this will go in a loop. Okay, so every time this loop execute, you will get the accuracy of one of the model. Okay, so here right now our model consists of all these values. Okay, as we are appending it, that is, we are adding all these values one by one to our model. It consists of logistic regression, decision tree, Gaussian naive Bayes, and support vector machine. All of them are in our model. Okay, and finally it is printing the message. Let's check the output. So we got the output as this. So here the accuracy of a logistic regression is 0.96, that of linear discriminant analysis is 0.97, KNN 0.98, decision tree 0.96, naive Bayes 0.97, support vector machine as 0.99. So from this we can say that support vector machine is having the highest accuracy. Okay, so now our next step would be to compare the algorithm and select the best model. So just by looking at this output, we can say that support vector machine is having the highest accuracy. But let's compare all these algorithms and see which one fit the best. So for that, I'll be plotting a box and whiskers plot for the accuracy versus the name of the algorithm. Okay, so there's my algorithm comparison. Here I have the name of my algorithm and this is the accuracy for them. The green point which you can see up here is nothing but the mean values or this value. Okay, for linear regression I had 0.96, for linear discriminant analysis I had 0.97, and so on. So from this graph, what I can say is KNN, naive Bayes, and support vector machine, these are having the highest accuracy. Okay, as there is no minimum and maximum value, only they are having a maximum value and few outliers, these outliers. Okay, so in case if you are removing these outliers, like this one, these two, and this, so by removing them, KNN will give you the 100% accuracy result. By removing these two outliers, naive Bayes would give you the highest accuracy result or 100% accurate result. So even in case of SVM, if you remove this outlier, you will get a model with 100% accuracy. Okay. Now next is making the prediction. Well, just accuracy shouldn't be your metric to decide that this is your best model. Okay. So for selecting a model, you have several other features which you should decide apart from accuracy. Okay, so your accuracy will not always be the metric to select the best model from. Okay, so let's move ahead and see how to make the prediction. So we have already calculated the accuracy, right? So now from this graph we know that support vector machine is giving the highest accurate result even with the outlier. If this outlier is removed, then it's the best one. Okay, now let's make some prediction on it. Okay, so let's execute this. So here we are printing the accuracy score, we are printing the confusion matrix, and the classification report for Y validation and prediction, that is testing and predicted value. So here we are printing the accuracy score for the tested value and the predicted value. We are printing a confusion matrix for the tested value and the predicted value, and finally a classification report, same for the tested value and predicted value. So if you check the score for tested value and predicted value, like accuracy score while using SVM or support vector machine is 0.93. So there's my confusion matrix up here. And finally, we have a precision, recall, F1 measure, and support data for all these three classes: Iris setosa, Iris versicolor, and Iris virginica. So let me just explain you what is precision, what is recall, what is F1 score, and support. So this precision, it tells how accurate or precise is your model. That is, out of those predicted positive, how many of them are actual positive. So this is precision. Okay. Next is recall. It calculates how many of the actual positives our model has captured through labeling it as positive. Okay. Next is F1 score. It is used when you want to seek a balance between precision and recall because of a large number of actual negative values. Okay. And finally, we have support, which is the number of sample of the true response that lies in that particular class. Okay. So while predicting with SVM, we had 7 true responses in case of Iris setosa. 12 in case of iris versicolor, and 11 in case of iris virginica. Okay. Similarly, I made prediction using SVM model. If you make prediction using KNN, you'll get a different result up here. In this case, we got the accuracy as 0.9, and the precision score, recall score, FN score, and support score all are different. Okay. So here in case of KNN algorithm, you can see that we have the accuracy as 0.9 or 90%. The confusion matrix provides an indication of the 3 errors that we made. Finally, the classification report provides a breakdown of the class by precision, recall, FN score, and support. Okay. So we use Python to create few machine learning model and select the best model out of them. So our best fit model is SVM, as it is giving the highest accuracy and high values of precision and recall. Okay.
So in this session, we'll take a look at what machine learning is and how you can use scikit-learn, which is one of the most popular libraries in Python for machine learning models, to use scikit-learn package to build models that could classify the data that we send to it. So now let's take a look at what is classification, because that is the kind of model that we'll be building. I'd like to help you understand what classification is. For those of you who are unaware, classification is a machine learning technique that comes under the supervised learning technique. In supervised learning technique, you can build regression models as well as classification models, and we'll be taking a look at classification. I'll also explain what regression is. So let's take a look at what is classification. So in machine learning, classification is simply an activity that consists of putting things into the categories based on the similarities or common criteria. If I give you a lot of people who have applied for the loan, who have applied, if you're working in a banking industry, you need to help understand them what are the kinds of transactions that could lead to fraudulent transactions, and to do that you can take in some data about the transaction, the date, the time, the username, the user's credit score, so on and so forth, and using that you can figure out whether or not this transaction is fraudulent or not. So that is the classification problem, when you already have some categories defined and you want to place the incoming data into one of the categories. So there are a fixed set of outputs that your input can map into. So for instance, our digit recognition is a classic example of classification, in which what we do is we take in an image, we analyze it, and we figure out whether or not it contains which number does it contain from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any one of those. So there are 10 possible classes that our input could go into, and that's what we do in classification. So that's what classification is. Another problem could be regression. Regression is basically when you're trying to predict a continuous value. So think of it this way: when you're trying to predict a continuous value would be, you're trying to predict the temperature, you're trying to predict the housing price based on the features that you have, you're trying to predict the stock market price. These are continuous values because it could be a number in fraction, it could be a whole number, it could be a lot of things. There's no particular categories that you can put this into. So that's regression, and we're learning classification here. So that's the difference between those. So let's take a look at common classification problems. The first is character recognition. So if I give you if you've used anything like Google Lens, you probably know what character recognition is, in which it takes a look at an image and figures out what are the things that are written in that image. So it could be that it figures out what's written on a board, it could be it figure out what's written on a piece of paper, so on and so forth. That's character recognition. Then comes face detection. So if you are unaware of what face detection is, if you ever used a mobile phone with a camera, you put someone's face in that camera and it creates a bounding box around it to help it focus on the person's face, and that's what face detection is. Face detection and face recognition are two different things. Face recognition is understanding who that person is. So in face recognition, what we do is, good example of it is that is the feature that Facebook has deployed, in which you upload an image and it understands whose face is in these images and then gives you the person's name around the bounding box and tags them automatically. So that's face recognition. This is face detection. Then comes fraud detection. So if you work in the banking industry, fraud detection is something that is used. Fraud detection is something in which machine learning is used quite a lot. It takes a look at a lot of transaction, users' credit scores, so on and so forth, and understands what are the different transactions that could be considered fraudulent. Finally, we have intrusion detection. This is used in cybersecurity. What they do is they take a look at a lot of logs that it has and takes a look at the activity that was performed by particular IP addresses or a range of IP addresses in those logs, and understands what are the IP addresses that have tried to intrude in our system. And if it looks like a person, if it's classified as a person who's trying to intrude in our system, we blacklist their IP addresses, we report them to the authorities. That's the kind of thing that we do. Yeah, so someone has asked, how do we use machine learning in this aspect? Are we using Jupyter in the aforementioned uses of machine learning? So Jupyter Notebook is a software that we'll be using, but machine learning statements don't really care about how you're creating those. Jupyter Notebook is really useful because it allows us to bundle up code with explanations and the output of the code all in one place. So that's why we use that. But if you were to use plain Python scripts, that would work fine as well. All right, so now we'll move on to the next section, in which we'll take a look at some popular classification algorithms. First one is logistic regression. So in logistic regression, we learn from the data, and with that we use a log loss function, and we try and make a prediction about the probability of some particular data point being in one of the following categories that we have. So for instance, in our digit recognition example, what we do is we have 10 different categories, and what logistic regression would do is it would take a look at all the data points that we have given it and figures out a probability that each data point belongs to one of the following categories. So for instance, if I give it an image that contains 7, it will pick a probability of, let's say, around 0.05 that it's 1, 0.4 it's 2, 0.3 it's 3, and it goes along so much. And finally, when we go to 7, it has given the probability of 0.9, which is the highest, which means that logistic regression algorithms give us a bunch of probabilities, and the one with the highest probability is the one that we should choose. So that's the basics of it, and that's how it makes the prediction. Okay, so now let's take a look at the other one, which is decision tree. In decision tree, it's very easy to conceptualize. What it does is that it takes a look at the data that we have, figures out columns and values in those columns, and tries to split the data on that. So if I give you, let's say I give you the temperature. I want to figure out whether or not tomorrow it's going to rain or not. So it's going to be classified as either rainy or sunny. In that scenario, we give it the data, it takes a look at the data and figures out what are the different what are the different columns that we have, or the features that we have, and using those features, how can we split the data so that we can make the decisions better. So for instance, if it takes a look at the temperature previous days, and then figures out whether, okay, so in the previous days the temperature was 37 degrees. So on 37 degrees, whether if it's higher than 37 degrees, then it takes a look at other features, and if it's lower than 37 degrees, it takes a look at some other features. And doing that, after looking at all the features and coming up with these rules, it figures out, okay, the final answer that I can give you is yes, it's going to rain, or yes, it's going to be sunny. So then we go to random forest, and the random forest uses multiple decision trees to increase the accuracy of the decision. And after getting the results from all the decision trees, the result that has the highest frequency in the decisions that it has gotten from the decision tree is the one that's chosen. So if we get 5 decision trees, and all out of 5 of those, 3 of them predict that the number inside an image is 7, and others predict the number inside an image is 1, 7 is the output that's given to us. And then comes naive Bayes, or naive Bayes, however you pronounce it. It's the kind of algorithm that is used by using a probabilistic model. Inside naive Bayes, what we do is we take a look at the probability of something being mapping to a particular class. It comes up with probabilistic heuristics, and then tries to figure out how to use those probabilistic measures to use it. Now, in case you didn't understand a lot of these algorithms, it's fine. These algorithms do take a lot of time to digest, to understand, to implement. And as you can see that it could take you a lot of time to understand these algorithms, as well as to write these algorithms. It could be very difficult for you. So keeping that in mind, we use scikit-learn because it contains all these algorithms pre-written for you. So you could just take the data, use these algorithms that have already been built for you, and then figure out what's the accuracy and how well it predicts your data. So now we finally come to scikit-learn. So what is scikit-learn? Scikit-learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model. But writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use scikit-learn. Scikit-learn allows us to allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using scikit-learn and no other library? So if you are not using any other library other than scikit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than scikit-learn. So for all the tasks involving machine learning and everything, can you use scikit-learn only? So the answer that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the all right. Majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using scikit-learn and no other library. The correct answer is yes, you can. The people who have answered no, I'm assuming that you guys were thinking that because we have to use NumPy or Pandas or other libraries like that, we could probably not be able to build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, split it, and then use it inside the library of scikit-learn. But only using scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and people these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for scikit-learn or sklearn, and you can get the library code yourself. If you find some problem of want to help scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually these are the 5 generic steps that are used. The first thing is we import the libraries. So if you're using sklearn, numpy, pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written, knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations, such as NumPy, and testing the accuracy that we'll be using scikit-learn for. All right, and then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its X and Y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First, we split that. And then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is how the model has learned and what is the accuracy that it's giving us. Then comes training the model, which is the task of the scikit-learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate. What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently. So you need to train your model again, and if it sees some data that it hasn't already seen, it will give poor results. Someone has asked some more detail on splitting the data set and why and how. So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the scikit-learn library, feeding in the data, which is the X and Y variables that we have splitted for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right, hopefully you can see the question. question. Yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option. Testing set is the second option. All right. In the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands-on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly, we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from sklearn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab actually. So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, importing that, you would need pandas library and need to know the file and the example. Okay. So now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data. And it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting. Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers is because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters in classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are, the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, and using those, we'll be predicting these targets 0, 1, or 2, which map to setosa, vesicular, or vaginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data.data, the data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now, if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in sklearn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first line, first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the predictions. And after the predictions are made, we take a look at the accuracy, and accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small. And now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Is computer vision in area of ML? Yes, it is.
So what is NumPy? Well, a NumPy is a most widely used Python library for linear algebra. It is used for performing mathematical and logical operations on multi-dimensional array. NumPy consists of various set of functions that can be used while performing your mathematical and logical operations. So this was about what exactly it is. Now the question arises, how to create a NumPy array? Well, we have shown some basic example up here, how to create a NumPy array. So we have created 1D array up here and 2D array. Let me show you this example in my Jupyter notebook. This would make things more easier for you to understand. So this is my Jupyter notebook. So the very first thing that I'll do up here is define my one-dimensional array. So how to define a 1D array? So for that, the very first thing that I have to do is import my NumPy library. So I'll be importing NumPy as np. Why I'm using np up here? So it's just because whenever I want to call some function of NumPy, I don't want to use NumPy every time. So apart from it, what I can do, I can just replace the word NumPy by np. So once you have imported NumPy as np, let's define an array as a equal np dot array. So here instead of writing numpy dot array, I can just go ahead and write np dot array. That's it. Okay. And inside the array we'll pass list of arrays. Okay, like 1, 2, 3. Okay, and print a. So this is how my 1D array looks like. Now let me show you how you can create a 2D array. So let's create a two-dimensional array. Again, let's import numpy as np. Let's define an array as v equal np dot array. Inside array, what do we pass? List of function, right? So let's pass 1, 2, 3, comma 4, 5, 6 and print b. I'm telling you this will generate an error. Just think why. It gave you an error of data type not understood, right? So why do you think you are getting up this error? Any guesses, anyone? Think. Remember what I said up here. What do you pass an array? List of array, right? So where is array up here? It's a list, but we have to pass a list of array, right? So you'll enclose everything in opening and closing square brackets. So this would resolve your error, okay? So this is how you got the final output as 1, 2, 3, 4, 5, 6. So this is how you create your two-dimensional array using NumPy. Okay. How to initialize a NumPy array. Okay. So let's start. Well, there are several methods of initializing a NumPy array. Let's discuss them one by one. So first we have is initialize an array of x cross y dimension with all the values as 0. So let's check back in the Jupyter notebook. So what we need to do is initialize all the elements of x cross y array to 0. Okay, let's see how to do it. So here let's import the NumPy. Import NumPy as np. Now here I'll be using a function zeros. Well, this function is predefined in NumPy. Well, this is used to initialize all the elements of an array to 0. Okay, so np.zeros, zeros. Inside this, it takes a list of list. So inside this, what I'll pass up here is the size of my array. Let's take the size of the array as 3 cross 4. Okay, that's it. You don't need to do anything else. Mention the size as 3 cross 4. Let's execute it. So here you got the output as 3 cross 4 matrix, 3 cross 4 matrix with all the elements initialized to 0. Okay. Now let's move ahead and see our next example. Our next example says up here is arranging the numbers between x and y with an interval of z. So let's see how. So here what we have to do, arrange the numbers between x and y with an interval of z. Okay. So let's see how we're gonna do it. Again, import NumPy as np, and the function we'll be using up here is arrange, ARANGE. Okay. Inside that we'll pass 3 parameters. First, the starting point, next the ending point, and next the interval. Suppose I want the interval of 2, so I'll write 2 up here. Okay, so here arrange the number between x and y with the interval of z. So here x is 1, y is 10 and z is 2. Fine. So let's execute it. So you got the output as 13579. So what is the output? So the output is all the numbers between 1 to 10 with an interval of 2. Okay. Now let's just change these number and see what difference does it make. We want to print all the even numbers between 10 and 20. So let's see how we can do it. So here we are printing even numbers between 10 and 20. Okay. Just to tell you, you don't need to import numpy every time you are doing it. Okay. I'll just show up here. If you're not importing numpy, it won't throw an error because Python is executing every statement line by line, right? So here numpy is already executed, so I can use np up here. I'll just write np a range inside this. It should start from 10, right? And it should go till 20. And the difference should be 2 as we are considering the even numbers, right? So if you see the output, you'll get all the numbers between 10 and 20, but the number 20 would not be included up here. So it's like 10 till less than 20. Okay. So you got the output as 10, 12, 14, 16 and 18. Okay. Fine. Now let's get back to our PPT. So next we have is arranging z number between x and y. So now our x and y values are fixed, but what we have to do up here is arrange z numbers in between them. Okay. So here what we are going to do, arrange z numbers between x and y. Okay, let's see how to do it. So for arranging z numbers up here, we have a function as line space. So you can call np.linespace. It's not line, okay, it's lin. Don't make this mistake. Fine. And after that, what you'll do, you'll specify the first number and the ending number, that is the value of x and y, and how many numbers you want between them. Suppose I want 10 numbers between 5 and 10. So let's see what is the output. So I got the output as array of 10 numbers between 5 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Let's take one more example of line space up here. Now again, let's print some even numbers, like even numbers between 0 to 10. Okay, so here I can write np.linespace. Inside this, the number should start from 0, it should go till 10, and how many numbers I want in between? It's 0, 2, 4, 6, 8 and 10, right? So how many numbers? 6. Okay, so let's execute it. So we got the output up here as 0, 2, 4, 6, 8 and 10. Clear? So this was about the line space function and how you can arrange z numbers between two fixed values of x and y. Okay, let's get back to our PPT. So we have already discussed these examples. Let's move ahead. Next example we have up here is filling same number in an array of dimension x cross y. So it's like I want an array in which all the elements are initialized with the same number. Let's see how we can do it. So what I want to do, filling same number in an array of dimension x cross y. Let's see. So again, I won't be importing numpy up here. I'll just write np dot. So for filling the same number, we have a predefined function as full. It takes two parameters. First, the dimension of the array, and next, the element you want to fill in. So suppose my dimension of the array is 2 cross 3. Okay, and what value I want to fill in? Let's say I want to fill all the values with 6. So let's execute it. As you can see, we got the output as 2 cross 3 array with all the values initialized to 6. Okay, let's move ahead. Next we have is filling random numbers in an array of dimension x cross y. So now what if I want to initialize my array with some random numbers? So how can I do that? Well, for that you have a random function in NumPy. Let's see how you can do it. Here we are filling some random number array of dimension x cross y. Okay, so let's see how we can do it. Okay, no point of importing numpy. So the numpy function I'll be using up here is random. I'll just write np dot random, again dot random values in an array of dimension, suppose 2 cross 3. So it will create me a 2 cross 3 array with all the random values in it. Let's see the output. So as you can see, we have a 2 cross 3 dimensional array with all the different random values. Correct? Let's move ahead. So this was all about how you can initialize a NumPy array. Okay, NumPy array inspection, and we'll see how we can inspect various aspects of a NumPy array. Okay, so let's start it. So the very first thing we got up here is ndarray.shape. Well, this shape function is used to return a tuple consisting of array dimension. It can also be used to resize the array. Let's check the shape of our array. So what we have to do up here is inspecting the array. So in this, basically what we are doing is checking the size of the array. So let's define our array up here, like a equal np dot array. Let's define our array as 2 3 4 comma 4 4 6. Is it correct, or am I missing something? Remember these square brackets at the beginning, right? So you have to add these square brackets if you want to avoid the errors, because you have to pass a array up here. Now I have defined my array. So now what I want to do, I want to check the size of my array. So I'll just write print a dot shape, execute it. So you got the output up here as 2 comma 3. So it means it's an array of dimension 2 cross 3. Okay, so what if I just change my array? Okay, so let's just define an array like s equal np dot array. Let's define an array of different dimension like 1 2 3 4, another 2 3 4 6. Let's define one more, 6 7 8 and 9. So what do you think would be the dimension of this array? Guess the output. Any answer, anyone? We have 3 parameters up here. Let's just compare these two values. So here we had 2 set of arrays, right? And 3 elements in each array. So while printing the shape, we got the output as 2 comma 3, right? 2 comma 1 2 3. So what do you think here the output will be? Well, here we have 1 2 3 4 elements in each array. And how many arrays we have? 1 2 3. So what do you think the output will be? 3 4, right? So we'll get the output as 3 4. Just add these square bracket in the end. Okay, execute it. At a dot shape, we have to print s dot shape, right? So you got the output as 3 comma 4, correct? Now what if I want to resize my array? So what you're going to do up here is resize the array, right? Okay, let's see how can we do that. For that, let's just copy this array up here. Okay, well, even if you don't specify it, that won't be an issue, but don't worry, I'll discuss it later. So for now, let's define the same array. And as we know, the shape of this array was this 2 cross 3, right? Now what if I want the shape to be changed as 3 cross 2? So what I'll do up here is I'll just write a dot shape, and I want to change it to 3 cross 2. Okay, now let's just print the value of a. Let's execute it. Okay, so we got the value as 2 3 4 4 4 6. 2 3 4 4 4 6. Okay, so it just resized the array and changed the dimension. Okay, let's see one more example. let's change the dimension, like for here let's write 2 4 4 6. Okay, now how many elements do we have? 1 2 3 4 5 6 7 8 elements we have. So now I want an array of dimension 8 cross 1. So since 8 elements are only there, so 8 cross 1. So now I'll get the output as 2 3 4 4 2 4 4 6. Okay, but yeah, you cannot just write random numbers up here. It's like if you'll write 8 comma 2, you might get an error in this case as no elements are there. So you got an error of cannot reshape array of size 8 into shape of 8 comma 2. Since the number of elements that you have is just 8, so maximum what you can have is 8 cross 1. Okay, so similarly you can also get for 4 cross 2. It will be correct. Okay, so the trick up here is, let me tell you the trick. Hashtag trick. The multiplication of these two numbers must be equal to the total number of elements. Okay, so x multiplied by y should be equal to total number of elements in the array. Okay, so 4 cross 2, 2 cross 4, or what else? That's it, right? The factors of 8 are 2, 4, 8, 1. We tried with all. Okay, let's just change it to 8 comma 1. So that's the output. Got it? So this is how we are resizing our array. Fine. Next, what if I want to check the dimension of my array? How will I do that? So just now I checked the shape of my array. Now what if I want to print the dimension of my array? So how will I do that? So for that we have a ndim function. Alright, let's see how we are going to do it. So what task we have is return the dimension of the array. Okay, let's see how we'll proceed. So let's define an array as a equal np dot a range 24. So here what it did, it created me an array from 0 to 23. Okay, so now what I want to do, I want to check the dimension of this particular array. I'll just write print a dot ndim. So ndim is the function which will return me the dimension of this particular array. So what do you think the dimension of this array is? Any guess? It's 1, right? So the dimension of this particular array was 1. Now since that we have defined a single dimensional array, let's just reshape it. So here we are reshaping our array. So for reshaping, let's define another variable as b equal a dot reshape in the dimension of 2, 4 and 3. So here as a part of dimension, you can use any number whose product is 24. So for that one trick is there. Like what you can do is first calculate the factors of 24. What are those? 1, 2, 3, 4, 6, 12 and 24 itself, right? So here what all value it can take? So here you can select only number from 1, 2, 3, 4, 6, 12 and 24. So it's like if you're selecting 1, the another would be 1. If 2, then 2 cross 3 it's 6, 6 cross 4 it's 24, right? So here we took as 2, 4, 3, or you can even take 2, 3, 4, anything. If you're taking 6, then 6 multiplied by 2 is 12, and again multiplied by 2 is 24. So you can even reshape this array to a dimension of 6 cross 2 cross 2. Okay, let me just print the dimension of B and show you the output. So what is the dimension of B array? Let's see. Ndim, execute it. So here we got the output as 3. This is from the previous thing only, just remove it. So here the dimension of B is 3-dimensional array, right? If you change it to like what? Let's change it to 12 comma 2. This will work, right? And the dimension of this array would be 2, right? It's a 2-dimensional array. Okay, got it? So basically in reshape up here, what we are specifying is the value of x, y and z coordinate. Okay, since we are not specifying any z coordinate, so it's a 2-dimensional variable, and the value of x is 12 and the value of y is 2. So we need a 12 cross 2 matrix up here. Let's even print B. Let's see what we get. So you'll get the output something like this. So 12 in a column and 2 in a row. Okay, so now you know how to find out the dimension of any array and how you can reshape any array to your need, right? Let's move ahead. Now, what if I just want to return the number of elements in an array? How will I do that? So, find the number of elements in an array. Let's see. We have already defined an array A up here, right? Here's array. Here's array. A equal np dot a range 24. So our array A consists of 24 numbers that we already know, right? Now, how do we find the number of elements in an array? So up here we have already defined an array as A equal np dot a range 24. Okay, so here we already know that number of elements in our array is 24 since we are only defining it, right? So what if you get a scenario in which you don't know how many elements are present in the array? So for that we'll be using size function up here, right? Let me just verify how size function work. So currently you know how many elements are there in A, right? It's 24, you have only defined it. So in order to find out the number of elements in an array, all you need to do is use a function size. So name of the array A dot size. That's it. Execute it. So we got the output as 24 and it's verified. So even you have initialized the array with 24 elements, right? And this function has verified this. What if I just change it? Let me just show you. Let's change it to 25. Let's remove this. Okay, let's print our size. Well, the output up here would be, any guess? 25 obviously, right? Okay, so this is how you count the number of elements in your array. Let me just take one more example. Let's define an array as A equal 1, 2, 3, 4, okay, comma 3, 4, 5, 6, comma 2, 3, 7, 9. Okay, so this is my new array. Let's name it as D. Okay, now let's print the size of D. How many elements are present in D? D dot size. So let's see what's the output. So we have to define a tuple up here. Okay, tuple object has no attribute size. Let's take one more example up here. So here let's define our array as D equal np dot array. Inside this, let's define few arrays like 1, 2, 3, 4, 5, 6 and 6, 7, 8. Okay, now let's just print D dot size. So this will return the number of elements present in D and the output is 9, 3, 3, 3. Okay, well, what if I just add one more element up here like 8, 9? So what should be the output? Should be, so once we added 9 up here, we got the output as 3. Well, I know you are wondering that we'd be getting the output as 10, right? So here we don't have an equal number of elements in the array, right? So in this case, if you print D dot size, what it will return? It will just, so in this case, if you print D dot size, what it will return? So it will just return how many number of rows are there in your array. Okay, so how this size is working, it's multiplying the number of rows to the column. Okay, so if I remove 9 from here, so what we have is 3 cross 3, 3 rows and 3 columns, right? So 3 cross 3 is 9. So that's how it's calculating the value 9 up here. If you change the value of 4 here, again 4, and again add some value as, let's say 9. Okay, so in this case, what value you will get is 4 cross 3. 4 cross 3 is 12. So total number of elements in that array is 12. Okay, so this is how you count the number of elements in an array. Fine. Now let's just get back to our PPT and see what's left. We discussed this. Yeah, we already discussed how you can change the dimension of an array or resize it. Then another example, this also we discussed. Next, counting the number of elements in an array. We just did it. I'm assuming all these things are clear to you, right? In case you have any doubt, feel free to reach out to us and we'll make sure that the doubt is clear to you within 24 hours. Okay? So next we have is, we want to find the data type of the array. So let's see how to do it. So here we have is find the data type of the array, right? So let's take an example up here. So let's define our array as a equal np dot arrange 24 numbers, and each of data type. For that I'll write d type. So what's the data type? Let's say all are of float. Okay, let's check print a dot d type. So it's a float, right? Now what if I just remove it? What if I just write np.arange 24 and print the data type for that? So here we'll get int 32 values. So in this case, if you print the values of a, you are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, right? And just if you change the data type using d type equal float, so all you'll be getting is 0 point something, 1 point something. So you got a float value up here, okay? And even the data type which we are printing up here changed from int 32 to float 64, correct? Okay. So this was all about NumPy array inspection, NumPy array mathematics. We'll see what are the various mathematical functions that we can perform using NumPy. Okay, so let's see. So first we have is addition using NumPy. So for performing some addition, we have a sum function up here. Let's see how does it work. NumPy array mathematics, and in this we are learning about addition. Okay, import NumPy as np. You can write any name apart from np. If you write na, that is also fine. We are just following the convention and writing np up here. Okay, so now what if I want to find the sum of two numbers? So what I'll do, I'll call this sum function. So I can call np.sum. np.sum, inside that sum of two numbers. What are those two numbers? 10 and 20. It will just give me the result as 30. As simple as that. You can even use a variable, like using a variable. So let's define a comma b equal 10 comma 20 and np.sum. I want a sum of a plus b using a variable, that is sum of a plus b. Okay, so np.sum a comma b, execute it. What error did we got? Access 20 out of bounds for array of dimension 0. So always remember, whenever you are writing some parameter inside the sum, make sure that you are placing them inside the square brackets. Okay, as the sum function only takes the array of values. Okay, so now if I execute it, the error would be resolved. Okay, so we got the value as 30. Now what if I want to find the sum of a particular axis? Like I have a 2 cross 2 matrix, and inside that I want to find the sum of just my first axis or just my first column. Let's see how we can do it. So here let's define np.sum. Inside that let's pass some array like 1 comma 2 and another array like 5 comma 6. Okay, so now what if I want to print the sum of 5 plus 1 and 6 plus 2? So in that case I'll just mention like axis equal 0. Okay, so you'll get the output as 6 comma 8. 5 plus 1 6 and 6 plus 2 8. Now what if I want to print the value of 1 plus 2 and 5 plus 6? So in that case np.sum array of 1 comma 2, same number, nothing need to be changed, just the axis value would change. Okay, 5 comma 6. Now specify the axis value as 1. This is the only change that you have to do. So here you'll get the output as 3 and 6 plus 5 11. So you got the output as 3 comma 11, correct? Now what if I don't specify the axis up here? So what values do you think I'll get? What if I remove this? Let's see. So I got the value as 14. How? So it summed up 1 plus 2 plus 5 plus 6. So it gave me the entire sum of all the elements of the array. That is 1 plus 2 plus 5 plus 6. That is 14. Okay. Similarly, like sum, we have other important function up here like subtract, divide, multiply, exponent, square root, sine function, cos function, log function, and many more. Let's see some of them. Now let's copy up this title, numpy array addition. Here what we are performing, let's change it to subtraction. Now to perform subtraction, we have a method so we have to call the function subtract. Let's see an example like np dot subtract. What do you want to subtract? Like any value of like 10 comma 20. So we'll get the output as minus 10. 10 minus 20. So you got the value as minus 10. Okay. Similarly, what if I want to find the multiplication of two number? I'll just write np dot multiply 2 comma 3. Let's take two number multiplication of two number. So we'll get the output as 6. Let me just add one more heading up here. All other numpy mathematics function. So inside this we saw for multiply. Now let's check out for division. So for dividing two numbers we have function as divide. So np dot divide. Divide what? Let's divide 10 by 5. Here we are dividing two numbers. Okay, let's execute it. So we got the result as 2.0. Okay, so here all the operation that we perform with sum can also be performed with subtract, multiply, divide, or anything. Okay, it's like here we use a variable. So here we are summing up two array with axis 0. Here we are summing up axis 1. So all those function can even be done with np.subtract, np.multiply, or np.divide. Let me just show you with one example. Let's just copy it and let's paste it up here. So instead of sum, let's change it to divide and execute it. Invalid number of arguments. Now let me just show you how you can divide two arrays. So let's define two array up here, like a equal np.array. It consists of 2, 4 and 6. Okay, and other array b equal np.array. Inside this I'll pass 1, 2, 3. Now let's divide array A with array B. So np.divide array A with array B. Let's see what result do we get. So we got the divided result of two different arrays. Fine. Similar operation we can perform with multiplication. So you got the value as 2, 8 and 6 3s are 80. Okay. So we also have other function as exponent, square root, sine, cos and log. So let's see them one by one. So all you have to do is change the function. So we have exponent function for calculating the exponents. So we have exp function for calculating the exponents, sqrt function for calculating the square root, sine function for finding out the sine value of an array, similarly cos function for finding out the cos value of the array, and similarly log function to find out the log value of the array. Let's see them one by one. Again, so there's our array, we have already defined it. So let's use all these functions one by one. Print np.exponent of a. Okay, execute it. So this is the exponent of a, that is e to the power a. Okay, e to the power 2 is 7.38, e to the power 4 is 54.5, e to the power 6 is 403.42. Okay, let's just copy this function and let's find the square root of all the elements of a. So sqrt. So this is our square root. Let's add one more thing. This will make things more clear. Square root, and here it was exponent. Fine, copy this. Now we'll calculate the sine. Sine is np dot sine value of a. Again we have to check for cos. So cos is np dot cos, and finally log. So we have log as np dot log. Okay, execute it. So we got all the values of here. Exponent is this, square root is this, sine of 246 is this, cos of 246, log of 246. Okay, so these are some of the mathematical function that you can perform using NumPy. So let's move ahead. Let's go back to our PPT. So we already discussed this part. and we also learned about all these different types of other functions that you can perform, and we also discussed about the error that you might get. So let's move ahead. So next we have is the array comparison. So in this we have element wise comparison and array wise comparison. Let's see them one by one. So here we have is array comparison. Okay, so let's define 2 or 3 arrays. Okay, so a equal like 1 2 4. Let's define b equal to 4 6, and let's define one more, c equal again 1 2 and 4, same as a. Okay, so now let's use numpy to perform a element wise comparison of these arrays. So for this I'll write np dot equal, let's write a comma b. So it will compare 1 with 2, 2 with 4 and 4 with 6. So if these two elements are equal, it will return true. In other case, false. So for now, what output do you think we'll get? Well, for now, all the output would be false, right? As 1 is not equal to 2, 2 is not equal to 4 and 4 is not equal to 6. But what if you change this b to c? So in this case, you'll get all the true values. Just for understanding, just change this 6 to 4. Now let's compare a with b. So in this case we have last as true, so these two are false and one is true, so 2 false and 1 true value. So 2 false and 1 true, correct? So this was about the element wise comparison. Okay, now next we'll see. Let's perform a array wise comparison. Okay, let's just copy them. Okay, now in this I want to compare the entire array. If all the elements of array A equal to all the elements of array B, then only in that case we'll get the output as true. In all the other case we'll get the output as false. Let me just show you with this example. So np dot array underscore equal. So this is the function that we are going to use for comparing two arrays. So like this, compare A and B. Even if one of the element is different, we'll get the output as false. So here we got the output as false. See, executed false. So here what we have, A 1 to 4 and B 1 for 4. So we had two elements equal in A and B, right? Just 2 and 4 were different. And even then we are getting false. What if I just change the value to C? So in this case, you'll get the output as true, correct? So this was about array-wise comparison. So now that we have learned how to compare two arrays, both element-wise and array-wise. So let's move ahead and see what we have next. So we are done with this example. Next we have is the aggregate function. So under this, we'll see how to perform various statistical calculations on the array. Okay, let me show you with an example. Aggregate function. So here let's again copy paste the value of a, b and c. So in aggregate function, what all things we can do? We can perform a array wise sum, or we can find the minimum value of an array, or the mean of an array, the median or correlation coefficient of an array, or even the standard deviation of the array. Alright, let's print all of them one by one. So here I want to print my sum. So print np dot sum of array A. So it will give me the sum, right? 4 plus 2 plus 1, that is 9. Wait, just to clarify it, sum is this. Then let's print the minimum value from the array. So our minimum value is np dot min of A. Now let's print the mean value. So mean is np dot mean of A. It's as simple as that, right? Print median is np dot median of A. Then print correlation coefficient is np dot correlation coefficient of A. And finally the standard deviation. Standard deviation is what? It's np dot std of a. Okay, so let's execute it. So we got the value as sum 7, minimum value is 1, 1 to 4, correct? Mean is 2.33, that is 4 plus 2 plus 1, that is 7 by 3, 2.33. Median is 2.0. Correlation coefficient, that is 1, and standard deviation is 1.24. Okay, so this was about the aggregate function. Let's come back. So next we have is NumPy broadcasting. So let's see what exactly is. For example, we have two array with different dimension, right? But make sure the number of rows or number of columns are same. Okay, so in this case what we have is same number of element in each array. Okay, so it's like when you add first array to the second array, what it does, it simply adds it. Like, so here you can see we got as 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2. But here again, 10 plus 0 is 10, 10 plus 1 is 11, 10 plus 2 is 12. So similarly, what it did, it broadcasted this value and add all these values to different rows of this array. Okay, so same value is being added to this row, this row, this row, and this row. Okay, so this is the concept of broadcasting, as this particular array is broadcasted and summed with all the element of this particular array. Let me just show you with an example. This is concept of broadcasting. Okay, let's import NumPy as np. Let's define an array as np.array. Inside that, let's place few values, 0, 0, 0, then 1, 2, 3, then 4, 5, 6. Let's take one more. Let's take it as 5, 6, 7. Okay, now let's define another array b equal np.array. So in this, let's specify a number like 0, 1, and 2. So this is the number which will be added to 0, 0, 0, 1, 2, 3, 4, 5, 6, and 5, 6, 7. And this is the concept of broadcasting. Okay, let me just show you. Print first array. First array is what? A, right? Change the line. Then print the value of second array. And then print the value of first array plus second array. That is A plus B. Okay, execute it. So here we got the output as first array is this, second array is this, and first array plus second array, you can see that 0, 1, 2 is added to all these numbers. Fine. So this was the concept of broadcasting. Array manipulation in Python. So as a part of array manipulation, so we have concatenating two arrays together, stack array row wise vertically, stack array column wise horizontally, and combining column wise stacked array. Let's take an example in Jupyter Notebook and learn them one by one. So here we're going to start about array manipulation Python. Okay, so first of all, let's define two arrays. Let's take a equal np.array. Inside this, let's say 1, 2, 3. Okay, so this is my array A, and b equal np.array 4, 5, and 6. Okay, so first of all, we'll see how we can concatenate these two arrays. So first is concatenation of two arrays. So for this, we have a function concatenate under NumPy. So we'll just call it np.concatenate. We'll just write A and B. That's it. So here you got the output as 1, 2, 3, 4, 5, 6 in all the element in a single array. So therefore what it did, it concatenated both the array A and B into one. Okay, so next we have is stack array row wise, that is vertically. So stack array row wise vertically. Okay, so again for this we have another function in NumPy as vstack. So it just take two parameters, the name of two arrays, A and B, execute it. So as you can see, my two arrays are stacked one above other vertically. Here one more thing I have to say, like if you want to stack array row wise but in a horizontal fashion, so it's again same as your concatenate function, but here we have another function as hstack, and even this takes two parameter A and B, and it's quite similar to the concatenate function. It'll give you the same result. Okay, so this was about hstack. So till now we discussed about concatenating or stacking row wise, right? Now what if I have to combine column wise? So let's see here, combining column wise. So for this I have a numpy function column underscore stack. So let's call it np dot column underscore stack. Inside this, let's pass our arrays A and B, executed. So here you can see that my array A and B are stacked in a columnar fashion. Okay, so this was about combining column wise stacked array. Okay, so let's get back to our PPT and see what is the next topic. So next topic in array manipulation in Python we have is splitting array. That is, what if we want to perform some horizontal split or vertical split in the array? Let's see how to do it.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
So for this, let's define an array. Let's take x equal np dot range 16 numbers and reshape this 1D array in the dimension of 4 cross 4. Okay, let's print x and see our array. So this is our 4 cross 4 array consisting of numbers between 0 to 16. Now what if I want to split my array horizontally from here, this point, such that my first array contains 0, 1, 4, 5, 8, 9, 12, 13, and my next array contains 2, 3, 6, 7, 10, 11 and 14, 15. Let's see how to do it. Well, for this we have another function as hsplit. Let me just show you. Print np dot hsplit. Inside this you have to pass your array and define from which position you want to split. I want to split it from second, like there's my 0th index, first index, my second index. Okay, so I want to perform a split from this point. Okay, so let's see the output. Let me make things more clear for you. Let's add a new line up here, horizontal split. After performing the split, so here you can see that I have two arrays. First array is this, consisting of 0, 1, 4, 5, 8, 9 and 12, 13, and my next splitted array consists of the rest half, that is 2, 3, 6, 7, 10, 11 and 14, 15. Okay, I can even perform some customized split over here. Let me show you some example, like print np dot hsplit start from x and until np dot array 3, 6. So let's see what's the output, but before this let's add some new line. Let's check the output. So here we got two arrays, right? First one is this 0, 1, 2, 4, 5, 6, 7, 8, 9, 12, 13, 14, and the next one is the last column. Okay, so here let's split it from this point such that 0, 1, 2, 4, 5, 6, 8, 9, 10 all are these in, so all of them are in one array, and rest of them, that is 3, 7, 11, 15 is in different array. Okay, so let's do it. Np dot horizontal split and just write x comma np dot array. So here you will get the output as this. Okay, now from this example, what if I want these two columns together and this entire column has a separate array? So I want 3 arrays in total, so I just have to make a little change in it. Just write 2 comma 3, that's it. So it's like np dot hsplit x comma np dot array second and third column. So here I got the output as this. This is my first array, this is my second array, and this is my third array. Okay, so guys, this was all about splitting arrays and array manipulation in Python, indexing and slicing in Python, and we'll see how to select certain elements from the array. So let's start with what exactly is indexing and slicing. Well, indexing just refers to a position. For example, if you are storing some numbers or a string in an array, so each cell of an array has some index number associated to it. For example, the image shown on your screen represents an array in which each cell has a different character. So we have Monty Python stored in an array. So here index number of m is 0, O1 and so on till n is 11. So this is the index number when you are going from top to down, okay? And suppose if you directly want to extract the last character from the string and you don't know what is the length of the string. So in that case, you can use the negative index number. It starts from -1 at the end and goes till -12 at the beginning. Let me just show you an example and make things more clear to you. So this is our Jupyter notebook. So let's define an array a equal Monty Python. So each character is stored in a different cell. Okay. So now what if I want to extract Monty from here? So how will I do that? A of Monty, that M starts from cell number 0 and it will end till MONTY 0, 1, 2, 3, 4 and 5. So before the colon we write the part which is included. So M is included. So after the colon, that is cell with index number 5 is not included. So just before 5. So it's like 0 to 4. Let's see the output. So here we got the output as MONTY. Now what if I want to extract, let's say, these characters? Start from 0, 1, 2, right? Start from 2, ends at 3, 4, 5, 6, 7, 8 and 9. So I'll just write 0, 2. Start from 2 and end before 9. So this was my requirement and I got the output as NTY-PYT. So this was a very basic example of indexing and slicing in Python. Let's move ahead to learn more about it. So let's learn how to slice a 3x3 dimensional array with the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 stored in them. Okay, so let's learn how to extract or slice the array. So what if I want to extract the selected element? So here my selection is in first row, right? That is 0th index. So I can directly extract with a of 0. So if I write a of 0, this includes all the element from the first row. That is 1, 2, 3. But when I write :1, it means you don't have to include 1. That is whatever part comes after colon, we have to exclude that part. That is, we have to take number just before that. That is, if :1 is there, so we'll take till 0. And this will extract the first row from the array. The first one, it extracts all the elements from the first row. And next one, it extracts the first row from the entire array. Next, what if I want to select these elements? So here my selection is in the first row, right? That is 0th index. So if I write a of :1, now how to extract this selected element? Well, in this, I know that my selection lies in the first row, right? That is 0th index. Now I'll write a :1. So what it will do, it will extract the entire first row or extract till row equals 0. Only this row will be extracted. Next, I don't want to include the part of 0, 0. So I want my selection to start from column 1. Okay, so I'll write 1: up here. So after writing 1: what it did, from the 0th row, it then selected the column index starting from 1 till last. And therefore we got a selected value. Let me show you this example in my Jupyter notebook. Let's define an array. Let's say a equal np.array. Inside this 1, 2, 3, 4, 5, 6 and 7, 8, 9. Okay, so let's extract the first array from here. Let's extract first array. So we saw a of 0. A of 0 gives us all the element from the first row. Next, if I write a of :1, so this will extract the first array. Fine. Next, what if I want to extract 2, 3 from here? Okay, first let me just show you the entire array. So there's our array. Now I want to extract 2, 3 from here. So how I'll write a, first select the entire row. So 2, 3 lies in first row, right? So I have to select the entire row. Then it should end at 2, 3. Then my 2, 3 starts from column number 1. So I'll write 1 and 1 till last. Okay, execute it. So you'll get the output as 2, 3. Go back. Now if this is our requirement, so how to extract the selected element? So in this, my selection lies in first 2 rows, right? That is 0 and 1 index. So here, if I write a of :2, so this will extract both the row 0 and the row 1, okay? But now I want my column number to start from 1. So I'll just write :2 and start from 1 till end. Okay, let me show you this as an example. So there I wanted to extract 2, 3 and 5, 6, right? So let's see how can I do that. So a of 2, 3 and 5, 6. These numbers or the selection lies in first 2 row. So starting from 0 before 2, that is till 1. So select all the rows from 0 to 1. Then in the column part, the column starts from 1, right? 0, 1, 2. So it will start from here, right? So it should start from 1 and it can end till last. So let's execute it. So in this case, we'll get the output as 2, 3 and 5, 6. 2, 3, 5, 6. Clear? Let's move ahead. Again, same example. This one you can work it out on your own. Can you say what's the answer for this? Okay, let me give the solution of this. So a of 1 colon comma. So what does it mean? Start from row number 1. So there's our row number 1 till end. So include everything from here. Okay. So we have a of 1 colon comma. Okay. So what does it mean? So it means extracting starts from row number 1 till end. So this is my row number 1 till end. So this will include all of these values 4, 5, 6, 7, 8, 9. Okay. And it should continue till 1 colon, which means after extracting all the elements from row number 1 till the end, that is row 1 and row 2, when all these elements are included, from these elements I want to start from colon number 1, that is from here till the end. So the output what I'll be getting is 5, 6, 8, 9. Let me just show you. So I want to extract 5, 6, 8, 9, right? So a of here 5, 6, 8, 9. So these lies in first and second row, right? So row it should start from 1 and till last. Okay. And my column 5, 6, 8, 9. Let's start from first column, right? 0, 1, 2. Even the column should start from first and till last. So here I'll be getting the output as 5, 6, 8, 9. So here are a few more examples that you can try. Now a question might arise in your mind, like what is so special about NumPy arrays? So why can't we use simple Python list for these scientific computation? So let's move ahead and see what are the benefit of using NumPy array over the list. So NumPy array consumes less memory when compared to a list. It is also faster and more convenient as compared to a list. Okay. Let me just take few examples in my Jupyter notebook and show you how exactly it consumes less memory, how it is faster than a list, and how it is more convenient than it. Okay, so let's just get back to our Jupyter notebook. Advantages of NumPy over a list. So first, let's compare NumPy and list on the base of their memory size. NumPy versus list parameter is memory size. So for this, let's import NumPy as np and again import sys library. Now let's define a list. So let's say there's our list L equal range less 1000 numbers in it. Okay. Let's print the size of it. So print sys dot get size of any integer between 1 to 1000. For example, I can take 1 over here. Size of any integer multiplied by how many total integers are over there? 1000, right? So either you can write 1000 or you can write length of L. Okay. Now I need to compare it with NumPy array. So let's define a NumPy array. So let's say our NumPy array A equals np dot arrange 1000 numbers. Okay. Again print a dot size multiplied by, you can directly write 1000 over here or you can use a dot item size. Okay, let's execute it. Let's modify our code a bit. Here size of a list and here size of an array. So we got the output as 28,000 as the size of the list and size of the array is 4,000. Okay, so from here I can say that storing a NumPy array occupies less memory when compared to a list. Okay, so now that we have compared their memory size, now let's compare NumPy and list on the basis of their speed. So NumPy versus list on the base of their speed. For this we have to import another package, import time. We have already imported NumPy as np up there. Now let's create a function. Here I'm defining function as using list. Let's define our starting time t1 equal time dot time. Okay, now let's define a list x as x equal range of 1000 numbers, and let's define another list y as range of 1000 numbers. Let's say let's make them 10,000. Okay, This way we can check the speed of their processing in a better way. Okay, now let's add all the element of each list. So z equal x of I plus y of I for I ranges in length of x or length of y or maybe 1000. Okay, length of x or y anything, or you can just write 1000 up here. Okay, so this is my z, and from this function what I want, return time dot time minus t1. Now here this t1 was the initial time, right? And now this time would be the process time, that is time after executing this statement, right? So if we subtract this time minus the initial time, we'll get the total time taken to process this particular line. Now let's define another function. So define using numpy. Same, define the starting time. Wait, let me just add some comments up here. Starting or the initial time is also the starting of the initial time. Next, let's define a numpy array. Now x equal np dot arrange 10,000 numbers. Okay, and b equal np dot 10,000 numbers. Now for the processing part, what I want to do, I want to take the sum of both a and b. Z equal just a plus b. It's as simple as that. And this is how it is more convenient than a list. More convenient than a list. Okay. Now again, what I want from here, return time dot time, that is time after things are processed, that is this particular statement is processed, minus the initial time, that is t1. Okay, now let's call these two function and store their output in two variables. Let's say list time equal using underscore list, and numpy time equal using numpy. Okay, and then finally let's print them. Print list underscore time comma numpy underscore time. And one more thing you can add up here is like in this example, numpy is string value of list time divided by numpy underscore time, that is the time taken to execute the numpy array, this many times faster than a list. Okay, fine, let's execute it. The name using underscore list capital. So for this example, we got the processing time for list is 0.00199, while for numpy we got 0.00099. So in this example, numpy is 1.99 times or almost 2x time faster than a list. Okay, so this is how a numpy is faster than a list, and here I showed you how it is more convenient than a list. So I hope these things are clear to you. Coming back to our PPT, let's see what we have ahead. So we have already done this example, numpy versus list memory size. We also compare on the base of their speed, and here I showed you how it is more convenient than a list.
What is SciPy? Well, SciPy is a free and open source Python library which is used for scientific and technical computing. Okay, it contains module for optimization, linear algebra, integration, interpolation, special functions, Fourier transformation, signal and image processing, and other scientific computations which are most common in science and engineering. This library is built upon NumPy to make the scientific calculation more efficient. But before we actually move ahead, there's few special characteristics of SciPy that you should be familiar with. So let's move ahead and discuss about some of the characteristics of SciPy. So first of all, it contains toolboxes dedicated to common issues in scientific computing. Secondly, SciPy offers different submodules for different applications. Third is, it operates very efficiently on NumPy. We can say NumPy and SciPy works hand in hand. Okay. So fourth is, it adds significant power to the interactive Python session by providing the user with high-level commands and classes for manipulating and visualizing the data. Finally, SciPy routines are tested and optimized. Therefore, SciPy should be used whenever possible. Non-programmer scientists face difficulties while performing scientific calculations in large real world data. So this issue can be resolved very efficiently with the help of short and simple codes offered by SciPy. So this was about some of the characteristics of SciPy. So till now we know what exactly is a SciPy and what are its various characteristics, right? So let's just move ahead and see what are the various sub-packages or sub-module that this library has to offer, okay? So these are the various sub-packages which are a part of SciPy. So first of all, we have something called scipy.clusters, which comes in handy while dealing with vector quantization or k-means clustering. Second, we have is scipy.stats, which is generally used for statistics. Then comes scipy.optimize, which is used for minimizing or maximizing objective functions. Another very important sub-package is scipy.integrate. This is useful while dealing with different integration routines. Then we have scipy.linalg, which is generally used to perform linear algebra routines. And finally, we have scipy.fftpack, which is used for fast Fourier transform. Okay, so these are the various sub-packages which are available under SciPy. scipy.cluster. So in this session, we'll see why do we use scipy.cluster, what exactly is clustering, and how do we find clusters. Okay, so I hope the agenda is clear to you guys. So let's move ahead and see why do we use scipy.cluster. Well, this sub-package is very useful when we have to divide the dataset into cluster based on some attributes. So in the k-means function, we have to pass the data and the number of clusters that we need to divide them in as the parameter. Now a question might have popped into your head, right? Like what exactly is this clustering? So let's discuss that first. So let's say we have a dataset that looks something like this, and you want to group them into two clusters, the green and the blue cluster. So from here you can say that clustering is the process of grouping similar items into one single group. For example, you can say that we have selected two clusters over here, right? So all the data points in green cluster are completely different from all the data points in the blue cluster, okay? But all the points within the green cluster are quite similar to each other, and same is the case with the blue cluster, okay? So summarizing it, you can say that clustering is a process in which the data points are clustered into groups. The data points within one cluster are quite similar to each other. But when you compare it to the data point in different cluster, it's completely different. There is no similarity between them. Okay. So now the question arises, how to calculate this, or how can we create this cluster? Okay. So let's see how to create this cluster. So how do we find cluster? So first of all, we randomly pick two different cluster centers. Okay. Then as a step 2, what we'll do, we'll assign our dataset into two clusters based on minimum distance to the cluster centers. Fine. Then we'll calculate the mean distance of each member in the cluster. Then as a step 4, what we'll do, we'll shift the cluster center towards the mean, and we'll consider that two mean values are the new cluster centers. Okay. Then again we'll repeat step 2 and step 3 until no member changes the group. Okay. So I hope you got an idea of clustering from this. So let us discuss with the help of an example to make it even more clear. So let's say we have a data set in which we have coordinates as x, y, distance k1, distance k2, minimum, and cluster. So these are our attributes over there. Distance k1 is the distance between the point and the centroid of cluster 1, and distance k2 is the distance between the point and the centroid of cluster 2. So let's say we have a data set 1, 1, 2, 2, 4, 4, 5, 5 and 6, 6, and we need to divide them into two different clusters. So first of all, we'll randomly pick two cluster center or centroids. Let's say k1 equal 3, 3 and k2 equal 5.1 and 5.1. Okay. Then what we'll do, we'll calculate the distance from each point to k1 and k2. And based on the minimum distance, we'll assign them the clusters. Okay. So for example, the distance from 1, 1 to k1 is 8. But that to k2, it's 33.62. So clearly here minimum distance is 8. So our first point goes to cluster 1. From the point with coordinate 2, 2, so the distance from k1 is 2. But to k2 is 19.22. So this also belongs to cluster k1. And similarly, we'll find the distance for rest of the point, and based on minimum distance, we'll put them into the different cluster. Okay. So now after assigning the cluster, it looks something like this. So cluster 1 has the point with coordinates 1, 1, 2, 2 and 4, 4. And cluster 2 have the point with coordinates 5, 5 and 6, 6. So our next task would be to find the mean of all the member in a cluster. Okay. So the coordinate of mean of cluster 1 is 2.33, 2.33, and the coordinate of mean of cluster 2 is 5.5 and 5.5. Okay, so now consider the coordinate 2.33, 2.33 and 5.5, 5.5 as new k1 and k2. Okay, again find the distance of each point from k1 and k2. Then based on minimum distance, put them in clusters. Okay, now repeat these steps until no member changes the cluster. So in this example, we had very less number of data. So the whole calculation with repeating steps doesn't look that annoying, right? But what happens if the data set is large, right? That would be too hectic task for you to calculate it manually. So now to reduce this computational complexity, we have scipy.cluster. Okay. Now let me show you how you can use it in Python. So to perform clustering operation, we'd be needing some data. So here I have imported some car dataset using pandas. Okay. So my dataset consists of 11 columns and 32 rows. And all these 32 rows consist of different numerical data. Okay. Here in this slide, I have just shown first 13 rows of the dataset. So as you can see here, my dataset consists of MPG, cylinder, displacement, horsepower, DRAT, weight, QSEC, VS, AM, gear, carburetor, right? So now we'll be using this dataset to create the cluster. Okay. So import pandas as PD, data equal pd.readexcel, inside that the name of the file. So this is how you can import the data. Okay. So now to perform clustering operation, we first need to import k-means and vq from the scipy.clustering subpackage. Then we'll pass our data and the number of cluster that we need in k-means function. In our case, we need 3 clusters, right? So this k-means function will return the array of 3 centroid. Okay. So after we get the centroids, we'll pass our data and the centroids into the vector quantization function, which returns an array of cluster index values for each record. So let's see the output. So as you can see from the array of cluster index, our dataset is divided into 3 different clusters. It was simple, wasn't it? But there's a common pre-processing step for machine learning algorithm called the data whitening. We need to perform data whitening when we use features that represents different characteristics and are on very different scales. So which we are going to see in our dataset. Okay. So we'll now see if there is any change in the cluster after we perform whitening. Well, again, to perform data whitening, we'll be importing whiten from scipy.cluster.vq. Then after importing the data, we'll pass the dataset into the whiten function. Then repeat the same steps to find the centroids and the array of index. Now comparing to the array of cluster index, you can see that many of them has been changed, right? In this and in this. Okay. So this is why we need to perform data whitening before passing the data into the k-means clustering function. So this was all about scipy.cluster. Okay, scipy.stats. So in this session, you will understand why do we use scipy.stats and how we can use it. Okay, so without delaying any further, let's start with why do we use scipy.stats. Well, scipy.stats consists of all different types of statistical functions in it. Okay, it also contains a large number of probability distribution. To see or to know more about what functions or the package this library has to offer, you can just use info and inside that mention stats, and this will display you the list of all the different functions available under it. Okay, for now, let's just move ahead and let me just take an example and show you how does it exactly work. So let's say the nutritionist measured the sugar content in grams for 13 drinks at a coffee shop. So this is how his data looks like. Okay. Now the drink had a mean of 21.5 gram and a standard deviation of 8 gram, and the distribution was roughly symmetric. Okay. So for that we are creating a visualization out of it. So first of all we are importing the numpy library and we are storing all these data in the numpy array. Okay, so copy equal np.array and then inside that we are passing all these values of sugar. Okay, next what we are doing, we are printing the mean and standard deviation of it. So as you can see, we got a mean of 21.5 and a standard deviation was 8.06. Okay, then what we did, we created a plot out of it. So for creating a plot, I used a matplotlib over here. Okay, And on the x-axis we have range of 13 number, that is 0 till 13, and on the y-axis we have different values of sugar in the coffee. Okay, so this is how our plot looks like. So the distribution in this plot is roughly symmetric. Now let's say a grand mocha cappuccino at the coffee shop contains 14 gram of sugar. So calculate the standardized score or z-score for the grande mocha cappuccino. So how will we do that? So for calculating the z-score, so you have to import stats. So from SciPy I'm importing stats, then print stats.z-score coffee. Okay, so here we got the list of different z-scores for different values. Okay, so the z-score of a 14 gram sugar coffee is minus of 0.93, right? So but what does this mean? So any guess, anyone? What do you think it means? This drink has 0.9 gram of sugar less than the mean of the 13 drinks? Or it's B, this drink is 0.9 standard deviation below the mean of the 13 drinks? Or it's C, that is about 90% of drinks have a lower sugar content than this drink? Or it's D, that about 90% of drinks have a higher sugar content than this drink? So what do you think the answer should be? The answer is D. That is, the value of z-score as 0.9 means about 90% of drinks have a higher sugar content than this drink. So this was about how you can use scipy.stats to calculate z-score for your data. Now let's take another example over here. So this data set consists of frequency of people going to gym and frequency of smokers. So in this example, we are trying to find out whether frequency of going to gym is related to frequency of smoking for our data or not. Okay, so how will we do that? So for doing this, we have another function offered by this sub package, that is chi-square. So this chi-square test is used to determine whether the output variable is dependent or independent of the input variable. Also remember that a chi-square test is designed to analyze the categorical data. So we'll be finding out the p-value with the help of the function offered by this sub-package. But how to define whether one variable is related to other or not based on its p-value? So there should be one cutoff, right? So by convention, the cutoff point for a p-value is 0.05. So if p-value is less than 0.05, we can say that they are related. But if it's greater than 0.05, they are not related. Okay, so let's go ahead and find out. So we imported the NumPy library, created the data, then we imported the stat from SciPy. Okay, so we passed our data into the chi2 contingency function. So this function gives us the value of chi2, p-value, degree of freedom and expected frequency. But here we need only p-value. So let's just print the p-value for that. Okay, so as you can see, we got a p-value of 0.482, which is greater than 0.05. So based on our records, we can conclude that there is no dependency between frequency of smoking and frequency of going to gym for our observed data. SciPy.signal. So in this session, you'll learn about why do we use SciPy.signal and how do we use it. Okay. So without delaying any further, let's see why do we use it. Well, the SciPy.signal is used for typical signal processing. You can process your one-dimensional or periodic signals in that. Let's say you need to resample a signal with n data points to x data point. So in that case, you'll be using SciPy.signal. So what SciPy.signal is basically doing, it is resampling the data point using FFT, that is fast Fourier transformation. Okay. So now that you know why do we use SciPy.signal, let's move ahead and see how do we use it. So here we are performing the resampling. So the very first library that I have imported up here is matplotlib.pyplot for creating our visualization, numpy for creating our dataset, and finally signal from SciPy. So here we are creating a signal with 200 data points, right? So np.linespace -10 to 10 and 200. So here we have 200 data points between -10 to 10. Okay. Next we are defining the sine graph. So y equal np.sine of t. So what it is basically doing up here, it is creating a sine graph with this data point. Okay. Next we are resampling it and we are specifying the number of required sample. So here for resampling we are using signal.resample. Inside that we are passing y, 100 sample. Okay. So number of required sample over here is 100. And then we are plotting t, y, that is these two, So our first sine graph is plotted, and then we are plotting t of double colon 2, which means what? We are printing all the values from the t with a gap of 2. So next what we are printing? On the x-axis we have t double colon 2. What does it mean? It means that we want all the values from the t, that is this, with the equal gap of 2. Fine. Next on the y-axis we have is the x underscore resample, that is this value, our resample value. And this O represents the dot, okay, these dots over here. And then finally, after doing the plt dot show, we get this thing. Okay, so this was about how you can use scipy dot signal to resample your data. Okay, scipy dot optimize. So in this session, you will learn about why do we use scipy dot optimize and how do we use it. So why do we use scipy dot optimize? Well, scipy dot optimize provides algorithm for function minimization. Either it can be a scalar or multidimensional. You can also use it for curve fitting or root finding. So let us discuss how can we do that with the help of an example. So here I am importing matplotlib library and numpy library. I am using numpy library to create my dataset and matplotlib to plot this particular graph. Okay. So here I have generated one function f of x where x varies from 0 to 1 evenly with a step size of 0.1. Okay. So when you plot this function, it looks something like this. Okay. So as you can see, we have a global minimum of this function at this particular point. So now our task is to find the value of x at which we get the minimum. So you must be thinking that you can find the minimum by plotting all the values of x in that function, right? But that increases our computational complexity. So this is where optimization function comes in handy. So you can directly use optimize.minimize and inside you can pass your function over there. Then with the help of result.x we'll find the x at then with the help of result.x we can easily find the value of x at which the function is minimum. So as you can see, we got the output as 0.69. So this means that at x equals 0.699 we get a minimum out of our function. scipy.integrate. Well, this is another very important sub package in scipy. So in this session we'll learn about why do we use scipy.integrate and how do we use it. Okay, so without delaying any further, let's start with why do we use scipy.integrate. Well, this library is used to perform integration. I'm sure you guys are familiar with what exactly is integration, right? When analytical integration becomes difficult, numerical integration comes handy. So this sub-package offers number of routines for performing numerical integration. Okay, so here we have something called quad for single integration, DBL quad for double integration, TPL quad for triple integration, and N quad for n-fold multiple integration. Let's see how these things work. Now let's move ahead and let me just show you an example. So if function of x equal x square where y equal f of x, then find the value of integration of a to b y of dx where a equals 0 and b equal 1. So there's my problem statement. So mathematically y equal x to the power n, right? So here the value of n is 2. Okay, so integration of a to b x to the power n dx equals a to the power n plus 1 divided by n plus 1 minus b to the power n plus 1 divided by n plus 1, right? So here n equal 2 and a equals 0 and b equal 1. So once we put all these values to our equation, we get something like this. Integration with the limit of 0 to 1 x square dx equal 1 to the power of 2 plus 1 upon 2 plus 1 minus 0. Okay, which equals to 0.33. Let's take an example. Let's say I have a function f of x equal x square where y equal f of x, then find the value of integration of y dx with the limit of a to b where a equals 0 and b equal 1. So mathematically y equal x to the power n equal x square, right? So if you see the formula, integration with the limit of a to b x to the power n dx equal b to the power n plus 1 upon n plus 1 minus a to the power n plus 1 upon n plus 1. So here if you compare these values, you can say that the value of n equals 2, right? So if you put all these values over here, the value of a, b and n to this equation will get something like this. So integration of 0 to 1 x squared dx equal the value of b was 1, right? So 1 to the power of 2 plus 1 upon 2 plus 1, that is 1 by 3, minus value of a is 0 itself, so it will be 0. So 1 by 3 equals to 0.333. Okay, so this we calculated it mathematically. So now let us see how scipy.integrate function work and make things easy for us. So here the very first thing that I'll do is import the integrate library from the scipy. Then I'll define a function integrad which returns the value of x square. Okay, then what we'll do, then we'll apply the intg.quad, and inside that we'll pass the function integrad and the value of a and b, that is 0 and 1. Okay, so this function returns answer as well as the error value, but we are just concerned with the integrated answer. Okay, so here we got the answer as 0.333. So similarly, for double integration you will be using dbl quad, and for triple integration you will be using tpl quad. Okay, so this was all about the integrate function of the scipy. Scipy fast Fourier transformation pack. Okay, so in this session you'll learn about why do we use scipy.fft pack and how do we use it. Okay, so I hope the agenda is clear to you guys. So without delaying any further, let's start our session with why do we use scipy.fft pack. Okay, well, this subpackage is used to compute fast Fourier transformations. Fast Fourier transform is an efficient implementation of the discrete Fourier transform. Okay, it also provides function as scipy.fftpack.fft. It is used to compute fast Fourier transform. FFT-fric, that is used to generate the sampling frequencies of the digital signal. And finally, IFFT, that is used to compute the inverse Fourier transformation from frequency space to signal space. So now let's move ahead and see what fast Fourier transformation package has to offer. So let's check its behavior in the frequency domain. So in order to work with our fast Fourier transformation subpackage, the very first thing that we are going to do is generate one digital signal which has some noise in it. Okay, so we can easily do that using NumPy library. Okay, so let's see what we have done here. So here the very first thing that I am doing up is importing my NumPy library. I am defining a time step as 0.02 as I need to have equal number of spaces over here, right? You can directly put this value over here. So using np.arrange, what it will do, so your initial point is 0 and ending is 20. So np.arrange will give you all the points between 0 and 20 with an equal interval of 0.02. Okay, and all these values will be stored inside time vector. Okay, so we have also defined a period as 5. Okay, so next thing what we are going to do is define a sine wave. So signal equal np.sine of 2 pi by 5 times of time vector. Okay, and this part is what? This is our noise, that is 0.5 times of np.random.random time underscore vector dot size. Okay, we are adding any random value just to create noise. Okay, finally we are defining a figure size for it and we are plotting it. So on our x-axis we have time vector and in our y-axis we have signal, that is this. Okay, and finally we are doing plot.show to create this particular visualization. So now that our signal is ready with its noise, so we can apply some fast Fourier transformation on it. So let's move ahead. So here we are applying the fast Fourier transformation. Now that the signal is a real function, so its Fourier transformation will be symmetric. So here the very first thing I'm doing is importing FFT pack from scipy. Okay, so inside FFT pack we have FFT frequency. The FFT frequency function is used to estimate the sampling frequencies. Okay, and we have FFT over here. So this FFT is what? This FFT function will generate the fast Fourier transformation of the signal. Okay, and finally we need to check the peak. Finally, the peak signal can be found with the help of frequency inside that power dot maximum argument. Okay, so after applying the fast Fourier transformation, our signal looks something like this. Fine. Next, we are applying IFFT to get the noiseless signal. So now that we have already applied the FFT, so our next task would be to apply IFFT to get a noiseless signal. So here the very first step is to filter out sample frequencies that are greater than 0 with numpy.where condition. So position under mask equal numpy.where. So wherever the sample frequency is greater than 0, all the values would be stored in position underscore mask. Then apply the filter of sample frequency and store the positive sample frequency on freq. So I have a variable as freq equals sample underscore freq, and inside that I'm passing position underscore mask, this value. Okay. So if you want to get the peak signal frequency over here, you can just print power of pos underscore mask dot argument max. Okay. Then what we are doing, then our next task is to find the peak frequency. Here we are focusing on positive frequency. So peak frequency equal frequency of power, inside that power mask dot arg max. Okay. So the maximum peak frequency value would be stored in peak underscore freq. So now our next task would be to get an array copy of the signal where we have already applied FFT. So high frequency FFT equal sig underscore FFT dot copy. Then what we are doing, we are assigning the ones greater than frequency as 0 in order to remove the noise. So high underscore frequency underscore FFT, inside that absolute, we are checking the absolute value of the sample frequency. If it is greater than peak frequency, then assign it 0. So if you want to check it, you can just print the high frequency FFT. Okay. Next task would be to apply the inverse FFT on a high frequency FFT. So this will be the filtered signal. So filtered signal equal FFT pack.ifft, and inside that we are passing high frequency FFT. Okay. And finally we are plotting it. Here we are defining the figure size, then plt.plot time underscore vector signal label. So label what we have is original signal. So here we are differentiating the original signal with a filtered signal by changing its line width. So we are defining a line width as 3 and its label as filtered signal. Then we are finally adding some X label, Y label and a legend to our graph. Okay, and finally we are showing it. So this would be the output of our code. This yellow signal, what you can see up here, is nothing but our filtered or noiseless signal. So here we have applied IFFT to get the noiseless signal. Okay, so I hope this thing is clear to you guys. So this was all about FFT pack.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
What exactly is Panda? Well, Panda is an open source, simple and powerful Python library which is mainly used for data manipulation and data analysis. Okay, now you might be wondering, where does this name Panda come from? So what do you think? Is the name of an animal? Is it? Wrong. The name panda is derived from the word panel data. Okay. Now what is panel data? Well, this is our panel data. It's a multi-dimensional data involving measurements over time. Okay. So it consists of various attributes with different attribute value. Okay. So this is how the name panda came from the word panel data. Okay. Now the question arises, who created pandas? Well, Panda was created by an American software developer and a businessman named Wes McKinney in the year 2015. Okay, so this is the guy who created pandas. Now let's move ahead and see some of the features of Panda. So on number 1 we have is series object and data frame. Well, this is the primary and one of the most important features of Panda. It allows it to deal with one-dimensional and two-dimensional label data in the form of series object and data frame. Don't worry, we'll discuss about them in detail later in our session. Okay. Next on number 2 we have is handling of missing data. Well, whenever you have a missing data, Panda represents it as NaN. Okay, so this is how Panda easily handles the missing data. Well, no matter where your data is a floating point data or it's a non-floating point data, Panda handles the missing data very easily by representing the missing data as NaN. Okay, next feature is data alignment. Well, this says that the object can be explicitly aligned to a set of labels, or the user can simply ignore the label and let series, data frames, etc. automatically align the data for you in computations. Okay. Next point we have is group by functionality. Well, this is a very powerful and flexible function provided by pandas. It is used to perform split, apply and combine operations on data for both aggregating and transforming the data. Okay. Next on number 5 we have is slicing, indexing and subsetting. Well, using pandas, you can perform intelligent label-based slicing, fancy indexing and subsetting large data set. So we'll see in this module how we can perform all these functions using pandas. Okay. Let's see some more features of Panda. Next we have is merging and joining. Well, using Panda, you can perform both merging and joining operations on your data set. Okay. Next is reshaping. Well, you can easily reshape your data and pivot your data points using Pandas. Okay. Next is hierarchical labeling of axes. Well, this hierarchical labeling of axes allows you to have multiple labels per tick, and this can be done using Pandas. Next is robust input-output tool. Well, Panda is a robust input-output tool for loading data from flat files including CSV and delimited files. From flat files like CSV or Excel files, databases, and saving or loading data from the ultra-fast HDF5 format. Okay. And finally, the last feature that we have is time series specific functionality. Well, this time series specific functionality include date range generation, frequency conversion, moving window statistics, moving window linear regression, date shifting, lagging, etc. So all these types of function can be performed in time series using Panda. Okay, so these were some of the features of Panda. Now let's move ahead and compare Panda with NumPy. So you might be thinking there are so many functions and features that make Pandas and NumPy quite similar. But what exactly is the reason that we are preferring Panda while dealing with some of the data then? Let's discuss that with the help of a comparison between Panda and NumPy. So the first point that we have is Panda works better with NumPy while dealing with data which has more than 500,000 rows. Okay, and when you are using NumPy, so it performs better for 50,000 rows or less. Okay, so in working with large real world data, you would need Panda for computation. Okay. Next we have is Panda series object is more flexible as you can use it to define your own label index to index and access elements of an array. On the other hand, element and NumPy arrays are accessed by their default integer position. Correct? So this is how Panda is different from NumPy. So now that you know how Panda differ from NumPy, next we'll see how we can import pandas in Python. So for that we have a command import pandas as PD. That's it. Okay. Next is what kind of data does suit pandas the most? So we have tabular data, time series data, and arbitrary matrix data. All of these kind of data you can feed it to the pandas. So now that we have learned the history, features, and how to import Panda, let us dive deep and see what kind of data suits pandas the most. So it deals with tabular data with heterogeneously typed columns as an SQL table or Excel spreadsheet. You can also work with ordered and unordered time series data. And it also helps you to work on arbitrary matrix data with rows and column labels. Okay. So guys, this was all for the introduction to pandas. Pandas series object. So in this session, we'll learn about what are the different types of dataset in pandas, what is a series object, how to create a series object, how to check the type, and how to change the index name of a series object. I hope the agenda is clear to you guys. So without delaying any further, let's see what are the different types of dataset in pandas. So we have one-dimensional and multi-dimensional data. So you can work on one-dimensional, two-dimensional, or any multi-dimensional dataset in pandas. If you are working on a one-dimensional dataset, it's known as a series object. If you are working on a two-dimensional, the Panda will create a data frame for it. If you are working on more than two-dimensional data, Panda would create a panel data for it. Okay. Now you might be wondering what are these terminologies, right? So let's have a look at them one by one. So for this session, we'll be mainly focusing on series object. So what exactly is the series object? Well, a series object in Panda is a one-labeled array which is capable of holding any data type like integers, strings, floating point number, Python object, etc. Okay, it can contain data of similar or any mixed data type. You can also say that a series in Panda is quite similar to a list or an array in Python, but yet it's more powerful. It represents a series of both numeric and non-numeric values as a column of data containing any type of mixed data. So you must remember the fact that a series can contain any type of data even if it's of a mixed data type. Okay. Now let's see how we can create a series object in pandas. So here in this example, we have a list of numeric data stored in data. Okay. And now we want to create a series object out of it. So for this, Panda has a function series with capital S. So here we are calling that function using pd.series of data. Okay. And storing it in a variable or a series object name series1. If you print it, you'll notice that in the output you have one-dimensional array labeled as 0, 1, 2 and 3. Let's make it more clear using my Jupyter notebook. First topic is series object in pandas. So the very first thing that I'll be doing up here is importing my pandas library. So import pandas as PD. Next, I need to define the list of the data. So let's say data equal 1, 2, 3 and 4. Fine. Now I want to create a series object out of this one-dimensional data. So how will I do that? For that, let's define a series object name. Let's say it's series 1. So series 1 equal PD dot series. Make sure you are using capital S, not small. Series, and inside that pass data. Okay. Now if you print your series 1, you will see that you have one-dimensional array of 1, 2, 3 and 4 which are labeled as 0, 1, 2, 3. Okay. So this was about series object in Panda. So let's move ahead. Next is how to check the type. Now what if I want to check if it is a series object or not? So you can do it simply by typing the command type, and inside that pass the name of the object. So here we have passed series 1 as the name of the object. Let's check it in our Jupyter notebook, what it has to say. So in order to check the type, all you have to do is mention type, and inside this write the name of the series object, which is here series 1. So if you execute it, you'll get the output as pandas.core.series.series. So definitely it's a series object. Okay. Now coming back to our PPT. Next topic is how to change the index name. Now what if I want to change the index name from 0, 1, 2, 3 to ABCD? So how will I do it? So let's see. So for that, all you have to do is add a new parameter index over there and define the index inside it. That's it. Let's see how. So what we are doing up here, changing the index of a series object. Okay. So I don't want to write the entire code. So let's just copy this thing. And all you need to do is specify index parameter over here. So index equal inside this, let's say first is A, next is B, next is C, and the last one D. Okay. And now if you execute series 1, you'll see that the index name is changed. So here we had index name as 0, 1, 2, 3, which here changed to ABCD or customize index name. Okay. So I hope this thing is clear to you. Well, next is create different series object data type. Well, pandas is not just about the list. You can use different arrays, you can use dictionary over there, or you can use any scalar or any constant value to create a series object out of it. Okay. I hope the concept of series object is clear to you. Pandas data frame. So in this session, you will learn about what exactly is a data frame, what are the various features of a data frame, and finally, how to create a data frame. So without delaying any further, let's start with what is data frame. Well, as I told you earlier, in pandas, two-dimensional data is found in the form of data frames. So now the question arises, what exactly is a data frame? Well, a data frame is a two-dimensional label data with columns which can contain data of different types. Correct? Let me show you an example. So here in this example, you can see we have a two-dimensional data with the column label on the x-axis and the index on the y-axis. Correct? So this is an example of a data frame. So now that you know what exactly is a data frame, let's move ahead and see what are the different features of a data frame. So a data frame contains column of different type. We can even change the size of a data frame as it is mutable. You can even have data access labeled, and you can also perform various arithmetic operations on rows and columns. So these are the various features of a data frame. So now that you know what exactly is a data frame, let's see how to create one. So you can create a data frame using this command pd.dataframe, and inside that mention the data. Okay. Let me just open my Jupyter notebook and show you how exactly it is created. So this is my Jupyter notebook and this is where we left in our previous session. So today we'll learn how to create a data frame. Okay. Let me just change it to Markdown. So again, in order to create a data frame, the very first thing that you will be doing is importing the Panda library. So import pandas. Let's say I want to import pandas as PD. I don't want to use the name pandas again and again. Okay.
So now that I have imported my library, let me just define some data. So let's say data equal 1, 2, 3, 4, 5. Okay, and now I want to create a data frame. So let's say df equal pd dot data frame, and inside that what I need to pass is the data. In this, make sure that your D and F is capitalized. Okay, and let's print the data frame. Let's see what is the output. Okay, so here we got the output of data frame. So as you can see, on our x-axis we got the label as 0, and on the y-axis we got the index as 0, 1, 2, 3 and 4. Okay, so there's a simple example of a data frame. So this data frame was created using list. So let me just add this, creating a data frame using a list. Okay, so next what I'll do, I'll show you an example of creating a data frame using a dictionary. Okay, so let's define our dictionary. So let's say my dictionary equals, inside this I'll write fruits, and my fruits consist of array of different fruits like apples, banana and mango. So let's add one more key value to it. So let's say I'm adding count. So count equal, I have 10 apples, 20 bananas and let's say 15 mangoes. So here I have defined my dictionary. Now I need to create a data frame out of it. So let's say data frame equal panda pd dot data frame dnf capital, and inside this I'll pass my dictionary, and let's print it out. So as you can see here, we got a data frame with the labels as fruits and count, and the index over here as 0, 1 and 2. Okay, so this is how we create a data frame using a dictionary. So now that you know how to create a data frame using a list and a dictionary, now let me show you how you can create a series. Well, the series is the same which we learned in our previous session. It's a one-dimensional labeled array which is capable of holding data of any type. You can have any integer, string, float or any kind of value in it. Okay, let me show you how you can do it. So here what we are doing, so here we are creating a data frame using a series. Okay, so let's define our series. Let's say series equal pd dot series. Inside this, let's say I have 6 comma 12, and also let me specify the index. So let's say index equal a comma b. So there's my one-dimensional array with its defined index. Okay, now I want to create a data frame out of a series. So how will I do it? So let's see. So df equal pd dot data frame with dnf capital, and inside this I'll pass the series. Okay, now let's just print it. So as you can see here, we got this output. So here our one-dimensional series got converted to two-dimensional data frame with index as a and b. Okay, so now that you know how to create a data frame using a series, next we'll see how we can create a data frame out of a NumPy array. Okay, so let's see how. So here, creating data frame using a NumPy array. Okay, so here the very first thing that I'll do is import my NumPy library. So import NumPy as np. Since I have already imported pandas up there, so I don't need to import it again. So after importing the libraries, next what I'll do, I'll define my NumPy array. So let's say my NumPy array equals np.array, and inside this let's have some salary value like 50,000, 60,000. Let's say these are the salary of employee whose names are, let's say, John and James. Okay, so now that I have defined my NumPy array, let me just create a data frame out of it. So data frame df equal pd dot data frame. So let's add a name of the employees over here. So name, and this will fetch data from NumPy array with cell first cell. Okay, and next let's define salary. So salary will fetch data from NumPy array zeroth index, right? So my data frame is created. Now let's just print it, execute it. Data type not understood. Okay, so I've missed this opening and closing square bracket over here. That's why I'm getting this error. Let's execute it. Okay, it's resolved. So here you have just created a data frame out of a numpy array with column name as name, salary, and here's the index numbers 0 and 1. Okay, merge, join, and concatenate operations that can be done on the data frame. So today you will see how you can perform merge operation on two different data frames using pandas, how you can perform join operation between them, and how you can perform concatenation between them. Okay, so I hope the agenda is clear to you guys. So without delaying any further, let me just switch back to my Jupyter notebook and let me show you how you can perform these operations. So here's my Jupyter notebook, the way we left it in our last session. So today what we are going to do, today we are going to see how to perform a merge operation between two data frame. Okay, so for this, the very first thing that I need to do is create my data frames. So first of all, let's import the libraries. So import pandas as PD. I'll be needing this library only. And now let me just define two data frames. Now once I've imported the library, so next thing I'll do is define few lists over here. So let's say player equal player 1, player 2, and player 3. Okay, next let's define a list of points. So point equal, let's say 8, 9, 6. Okay, let's also add a list of title to it. So title equal game 1, game 2, and game 3. So now that I have defined three lists over here, I need to create a data frame out of it. So let's say my first data frame equal pd dot data frame, and inside this let's create a dictionary. Let's add a label, let's say player, and this player contains all the values from my list of player. Okay, comma points, and this points consist of all the values from the point list, and the title which consists of all the values from the title list. So I have created my data frame over here. So let's just print it. So this is my data frame which I just created. So one of the data frame is ready. Now let's define another data frame. For this we'll be needing different list. So let's say here player equal player 1, player 5, and player 6. Let's define another list as par. So par equal punch, kick, and elbow. Fine. Next I'll define a list of title. So here title equal player is from the game 1. Next is this one from the, let's say, game 5, and this one from game 6. Okay, here all our lists are ready. Now let's create a data frame for it. So here df2, that is second data frame, equal pd dot data frame. So inside this let's define our dictionary. Say column name is player, which consists of the values from player list. Next is par, so my next column is which consists of the values from par list, and the next is title, again which consists of the values from title list. So there's my second data frame. Let me just print it. So here my second data frame is also ready. So this one is my first data frame and this one is my second data frame. So now that our data frame is ready, so the very first thing I'll be performing on it is inner merge. So what exactly is this inner merge? Well, the result of this inner merge would be that it will return you the row which is common in both the data frame on the basis of any key value. So let's have a look at our data frames. Any common value over here, like any common column you can say. So we have player and title in both our data frame, right? So we can perform the inner merge using any of these two columns, either player or title. Let me show you how. So let's say I want to merge my data frame 1 with data frame 2. So I'll write data frame 1 dot merge with what? Data frame 2. Okay, and on the basis of what, you have to specify your key value over here. So on, let's say I want on the base of title. Okay, and how I want to merge them. So how equals inner. So this will give you the inner join. So we got this result over here. So here player underscore x represents that this attribute is from data frame 1 and player underscore y represents that this attribute is from the data frame 2. Okay. So why did we got just one value over here? Let's explore it. So on the base of title, so we are merging on the base of title. So what are the common values in it? As inner merge give you the common set of values in both the data frame on the base of what attribute you are choosing. So as we have chosen title over here, so common attribute is game 1. So only game 1 is common, right? So whatever values are associated with game 1, you got that. Okay. If I change the value of title to player, let's see what's the difference. So here I got the value of player 1 as player 1 was only common in both the data frame, right? So here player did not get split into player underscore x or player underscore y. So instead of that, title got splitted up to title underscore x and title underscore y. Okay. So here title underscore x is game 1 and title underscore y is also game 1. So this is how we perform an inner join on two data frame. So just to tell you, by default, if you merge two data frame, it will perform an inner join. Okay, see. So this was all about inner merge. Now let's move ahead and see how you can perform left merge. So even performing left merge is quite similar to the one which you performed in inner merge. Just have to write data frame 1 dot merge data frame 2 on player, and instead of this inner you have to mention left. That's it. So in case of left merge, both of the table would be merged together, but in this case all the values from table 1 would be there. So our table 1 has, or the data frame 1 had player 1, player 2 and player 3, right? So all these values are over here, and apart from it, what else you will get? You will get all the values from second data frame, and here you will get all the common values from your second data frame. So here my player 1 was in both the data frame, right? So it merged both the table and it showed me these values over here, punch and game 1, right? But for player 2 and player 3, they were not in the second data frame, right? So that's why Panda was not able to identify what value should it give in power and title. So that is why it mentioned NaN over here. Okay, so this is how you perform a left merge. Now next, let's see how to do a right merge. So again, you don't have to do anything, just change left to right. So left becomes right. So you got this value. So why I'm getting this value? So similar to left merge, now it's performing right merge. So all the values from your right table would be here. Okay, so player 1, 5, 6. I'm getting all the values from my right table or right data frame or second data frame, right? So 1, 5, 6 are over here. 1, 5, 6, punch, kick, elbow, and game 1, game 5 and game 6. And apart from it, what are the common values from the left data frame, right? So from our first data frame, we got this value as player 1 was common in both of them, correct? And apart from it, we didn't had any value for player 5 or player 6. That is why we got NaN, NaN, NaN and NaN values over here. So this was about the right merge. Now next is how to perform an outer merge. Let's see. Outer merge. So here all you have to do is change this to outer. Execute it. So in this case you will get all the values, and wherever the value is not common you will get NaN over there. Okay. So this was about the outer merge. So guys, this was all about the merge. Now next, let's move ahead and learn about the join operation using Panda. There's a slight difference between the merge and join in case of Panda. Let me tell you what. In case of merge, the two data frames were getting merged on the base of their attribute name or the column name, right? So it's a must that both the data frame must contain at least one common attribute name, right? But this is not the case in join. It's a bit different. In case of join, the two data frames are joined on the basis of their index value. Join is generally used when two tables have completely different attributes, and this is the reason why you have to specify the set index while performing join. Okay, so here you can say that it's must to have a common index between the data frames. Okay, so let's move ahead and let me just show you how you can perform join operation. So here how to perform join operation in pandas. So similarly, the very first thing that we need to do is define our data frame. So let's just copy the one which we already created. So here I need to make some changes in it. What change? Here I have to add index value for it. So let's say index equal L1, L2 and L3, as this is my left data frame. Okay. And let's define our fourth data frame. And in this, let's change the name of the attribute. So here let's make players and titles. And also let's change the index number. So let's say we have L2, L3 and L4. Okay. So our data frames are ready. Here I'll be performing the join function. So first let's perform inner join on it. Well, the concept of inner join and inner merge, everything is same. Okay. Just the difference is how it is used. In case of join, the two data frames are joined on the base of their index name. In case of merge, two data frames are merged on the base of their attribute name. It's the only difference. Okay. And it's same with inner join, left join, right join, outer join, everything. Now let's see how to perform a inner join. So I want to join my data frame 3 with data frame 4. Okay, we have to change it. Let's name it 4. So I need to join data frame 3 with data frame 4. So df3.join inside this data frame 4. And how I want to join? So how equal, I want to perform inner join between them. That's it. Execute it. Okay, we are getting error of columns overlap. Okay, I guess we missed one value over here. Okay, now both our tables are also different. Okay, now let's perform inner join on it. So while performing inner join, you can see that it has joined both the tables on the base of their common index name, right? So L2 and L3 are common part over here. So that's why we got these values. So this player is from the left data frame and this player is from the right data frame. Fine. So this was about the inner join. Now let's change it to left join. So left join, let's copy it and just change inner to left. That's it. So here you can see that we are getting some null values over here. So why we are getting null values over here? So it's the same reason what happened in case of merge. So in case of left join, it is merging both the data frame with all the datas from the left data frame and all the common datas from the right data frame, right? And wherever the data in right data frame does not matches that to the left one, so there we are getting a null value. Okay. Similarly, right join, how? Right. In this we are getting all the values from our right data frame and all the common values from the left data frame. Fine. Next is outer join. Just write outer over here. So what it did, it just merged both the data frames. Wherever it was not able to find the common values, it assigned null values to it. Okay. So this was all about join. Now next we'll see how to perform concatenation using pandas. So here we'll write how to concatenate two data frames in panda. So we already have defined data frame 3 and data frame 4, right? 3 and 4. So let's just concatenate them. So for concatenating data frame 3 with data frame 4, all we need to do is pd.concat and inside it mention what all data frame you want to concatenate. So here data frame 3 with data frame 4. That's it. Execute it. So you got this value over here. Okay. So it is basically concatenating both the data frames. Okay. How to import and analyze your data set. So in this session, you'll learn about how to import a data set using pandas and how to analyze various attributes of the data. So I hope the agenda is clear to you guys. So without delaying any further, let's start and see how we can import a data set using pandas.
So for importing the dataset, the very first thing that you'll be doing is importing the pandas library. So I'm importing pandas as PD. So next we are going to read the dataset and store it in a data frame. So I'm defining a data frame named cars, and inside this I'm passing the path of my CSV file, which is empty cars2.csv. At this point you can specify the path to your CSV file. Okay, and finally we are printing it. Let's see the output. So this is my entire data. So let's move ahead and see what are the various analysis we are going to perform on it. So first is type cars. So this type car is used to check the type or check the data type of the car. So it's a data frame, right? So as a part of output, we got pandas.co.frame.data frame. Okay, so the type of cars is, it's a data frame. Next is cars.head. Well, this is used to view only the first 5 records of your data frame, which in our case is this. Okay. Next is, if you want to view first 10 records from your dataset, you can pass the attribute over here as 10. And so as an output, you'll get first 10 dataset from the data frame. Okay. Next is, what if you want to view last 5 records, then you can use the parameter dataframe.tail, which in our case is cars.tail. Okay. So this will give you the last 5 record of your data frame. Okay. Similarly, if you want last 10 records from your dataset, you can specify a value over here. So dataframe.tail, inside this I pass 10. So this is giving me last 10 records from my dataset of cars. Okay. Next is cars.shape. Now if you want to view the total number of rows and columns in your data frame, for that you have dataframe.shape. So cars.shape gave me the output as 32 and 13, which means I have 32 rows and 13 columns in our dataset. Now if I want to concise the summary of the column of my data frame, for that I have dataframe.info. And inside info, I'm passing null underscore counts equal true. So what it is exactly giving me, it is giving how many non-null values are up here. So as you can see in QSEC, we have 29 null values. So from here you can say that we have 3 null values in our column QSEC. Okay. This is the data type of each column. The first serial number is of integer data type, next is object, MPG is object, cylinder is integer, and so on. So in total we have 4 columns which consist of floating data type, 7 columns which consist of integer data, and 2 columns which consist of data of object data type. Okay, and the total memory usage is 3.3 plus KB. Fine, let's move ahead. Now if I want to calculate the mean of my data frame, I can just write dataframe.mean, which in our case is cars.mean. So as a part of output, it gave me the mean of each column. Okay. Next, if I want to calculate the median, similarly dataframe.median, cars.median, it gave me the median of each individual column. Okay. Next is standard deviation. Well, for standard deviation, we have dataframe.std. So if you see the output over here, you are getting the standard deviation of each column. Fine. Next, similarly, you can calculate the maximum value of each attribute by using dataframe.max. So we have cars.max, for which we are getting maximum of each attribute. So in serial number, we have 35 unnamed maximum value. This MPG, it's 33.9 and so on. Okay. Similarly, you can calculate the minimum value for each attributes using dataframe.min, and you'll get minimum value for all these different attributes. Fine. Next is dataframe.count. So if you want to count the total number of non-null record in each column, then you can use dataframe.count. So which in our case is cars.count. So here as output, we are getting how many non-null values are in each column. So here in QSEC, you can see that we have 29, which suggests that we have only 29 non-null records and there are 3 null values in it. Okay. Next is the dataframe.describe function. Well, it is used to print the descriptive statistic summary. If you don't want to calculate each of the feature individually, you can just write dataframe.describe, and this will give you the output of count, mean, standard deviation, minimum, maximum, 25 percentile, 50 percentile, and 75 percentile values of all the different columns. Okay, so these were the various attributes you can use it for analyzing your dataset. Okay, cleaning the dataset. So in this session, you learn about what is meant by data cleaning and what are the various methods that you can use to clean your data. So I hope the agenda is clear to you guys. So without delaying any further, let's see what exactly is data cleaning. So data cleaning or data cleansing is a process of detecting, correcting, or removing corrupt or inaccurate records from a dataset, table, or any database. It also refers to identifying complete, incorrect, inaccurate, or irrelevant parts of our data and then replacing it or modifying it. This is what a data cleaning is. So let's see how we can clean our data. So the first thing that we can do to clean our data is we can rename the column. Okay, so in our data set, we had a column as unnamed, right? So instead of using the column name as unnamed, we can replace it by name of the model, which represents the exact name of the column, as the column contained different model of the car, right? So here what we are doing, we are renaming the column unnamed to model. So as you can see here, as an output, we got model up here. Okay. So this is the very first thing that you can do while cleaning your data. You can rename the attributes. Next is, what if you have some null values in your data? So for treating null values, what you can do, you can fill the null values with the mean of the column. And this is how we do it. So cards.qsec. So as we have analyzed in our previous session that qsec had 29 non-null records, right? So which it meant that it had 3 null values in it. So we replaced all those null values with the mean of the qsec column. So what we did, we took the mean of the entire 29 and whatever value we got for the mean, we replaced all the null values with that particular value. Okay. So replacing the missing data with the mean value will help analyzing the data in a better way. Okay. So this is how we can replace the null values with the mean of the column. Next is drop the unwanted column. So here we can drop all those unwanted columns which do not add any value in analyzing the data. For example, we had serial number previously, right? But the serial number was not adding any value to our analysis part. So for the further processing of the data, we can avoid or we can drop the column of serial number. Okay. So how we can drop any column? So for dropping any column, what we have to do is data frame.drop, and inside that we have to mention the name of our column, just like this. Cars equal cars.drop, and inside this columns equal, we are mentioning the name of the column as serial number, and it got dropped. So as you can see here in the output, we don't have the column as we used to have it previously. So here a serial number column is dropped. Well, next is finding correlation matrix. Well, this correlation matrix will help you to find how a variable is correlated to other variable. So if the value of correlation is high, so that means the two variables are highly correlated to each other. That is, changing one variable by a factor of x changes other variable by a factor of y. Okay. So here as an output, we got a correlation matrix, right? So from here you can see that cylinder to cylinder, it's highly correlated. That is one, obviously. Cylinder to displacement, it is 0.9. So it means that cylinder equals 0.9 times of displacement. So it's like if you increase cylinder by 1 unit, your displacement would increase by 0.9 unit. Okay. So similarly for DRAT, you can see that cylinder equal minus of 0.69 times of DRAT, which means if cylinder increases by 1 unit, it means the value of DRAT would decrease by 0.69 units. Okay. So if while finding a correlation matrix, you get a very small value of the correlation, for example, let's consider this. So here correlation between carburetor and DRAT is minus of 0.09. So it means they are very weakly related to each other. So it's like if the carburetor is increased by 1 unit, so it means that if the carburetor is increased by 1 unit, then DRAT would decrease by 0.9 unit, which is almost very less, right? So by finding correlation matrix, you can define the correlation between the variable, and from here you can decide which attribute to choose and what not to choose while working on the problem. Okay, fine. Let's move ahead. Next is changing the data type. Well, initially MPG was of data type string, right? Well, MPG had some float or numerical values into it, right? But with the string, we cannot manipulate it or we cannot perform any calculation on the string data, right? So MPG has to be converted to float in order to perform some data manipulation on it. So here we are converting MPG from string to float. So how we can do that? So it's dataframe.mpg equal dataframe.mpg as type, and inside that we are mentioning the data type which we want to convert to, and here in this case is float. Well, now if you want to see the change, you have to see cars.info null underscore counts equal true. So from here you can see that my MPG has been changed to floating data type, right? And even for the qsec attribute, we have replaced all the null values from its mean, right? So here it's giving me 32 null values. That is, now it is not having any null values in it. Okay, let's move ahead. So again, we are finding the correlation. This time, the MPG part is included as it has become of a floating type. Remember, while calculating the correlation between two attributes, both the attributes should be numerical in nature. No correlation can be found between attributes of string data type. Okay. If you compare it with our previous correlation, you can see that there was no MPG value, right? As initially the data type of MPG was string, right? Now, since we have changed the data type of MPG to float over here, so next, while finding the correlation, we are getting MPG value, okay? Now Python is treating it as a numerical attribute and it is using it to find the correlation, okay? So this was all about how you can clean your data set, okay?
The next couple of hours, I think we're going to talk a little about how to ace a data science interview. In general, the data science interviews are slightly different from other interviews. They're essentially, um, I mean, if I may say, they're slightly trickier than regular interviews. Not that they're very different, to be honest. There are a couple of rounds are slightly different. The questions are slightly different. The approach to the interview is slightly different. So I think it's worth talking about what are the nuances of a data science interview and how would you typically um, attend an interview and prepare yourself for that particular interview. With that, let's get started with the first one.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Types of data science roles. Yeah. So there are three major types of, or there are three types of data science roles, if I may say. Like or four. Let's three. The reason I mention it three is because two of these are more or less similar, and I'll talk about those. So the first is um, the kind of work that you're going to do in a data science company depends on what the company does in the first place. As a data scientist, you could be a part of a consulting team or a services team, let's say. Yeah, consulting your services is essentially there is a company that does technical consulting, or technology consulting, or let's say strategy consulting to another company, and you are a data scientist who is helping your client to solve a particular problem, right? Let's say your typical services companies in India, or let's say abroad, any of your typical services companies, your IT giants, like let's say your TCS, Infosys, and so on, Accenture, CTS, Cognizant, they're all IT consulting services. While you have strategy consulting services, like let's say strategy consulting companies like your Bain, uh, like your Bain, McKinsey, Deloitte, and so on. So there are other companies that do strategy consulting for clients as well. So you could be a part of any of these companies. Like for example, you could be a part of a TCS, or let's say my role for that matter at Microsoft. I'm a part of the services division of Microsoft. So you are essentially a part of a technology team, or you're essentially a part of this particular company that provides technology services, and you would be solving the problems of another client of yours. Now, the work that you do here would require you to have certain skill set, and we'll drill down on what kind of skill set is required for a data scientist in a consulting company, as opposed to the skill set that is required for other roles. Before that, we'll just walk through the four types of roles. The second role is specifically around your um, a captive or in-house data science teams. Like for example, let's say you're a telecom company yourself, and you would want to hire a data science team, and you're going to be a part of the telecom company itself, and the data science team, let's say, helps solve problems for this particular data science team. Data science team helps solve problems of that particular company itself. Let's take the example of AT&T or Verizon or any of these telecom giants in the US. or let's say any company for that matter. Take the example of Amazon, take the example of Facebook, or any of these companies. You're an in-house data science team, you're a captive data science team. There are no fixed responsibilities you have. You would essentially be helping different divisions in your organization to solve problems. So you would more or less be acting like a center of excellence within your organization. So various teams reach out to you and say, look, we have this particular problem, can you solve it for us? Look, we have an issue with, let's say, the kind of feedback that we're receiving from customers, can you help us mine this particular piece of text? So that's the second kind of problem, a second kind of roles that you would generally be a part of. The third is product development companies. Product dev is your typical company, typical teams where, let's say, for example, companies like Amazon or Microsoft, or let's say Google for that matter, they build small products. Let's say Google is building Google Maps. You are a data scientist that belongs to the Google Maps team, which means that um, you which essentially means that you are as somebody who's a part of the maps team alone. Your work is curtailed to the maps division only, the Google Maps division only, and then your work is very, very specific to that particular team. So all the problems that you would be solving will be specific to that particular product, and you're responsible for deploying that particular piece of work that you do, and monitor it, and fine tune it, and so on and so forth. So the life cycle is very much like any um, product. You know, and the life cycle is more or less like your like your typical um, uh, the life cycle of a product. Is the role of a data scientist is, kind of aligns with the life cycle of a particular product in the case of product development teams. Um, Last but not the least, I think the most important thing is research teams, and these are essentially the stalwarts in any domain, right? These are research teams. All your major IT companies, all your major digital companies would have a research team. And the responsibility of these research teams, of course, is that they are ultra technical, they're super strong, they work on bleeding edge, cutting edge technologies. They are in and they work at their own pace, right? So that's essentially what the research teams essentially are all about. Now, let's talk about each of these in more depths. Let's talk about the first one, and we'll try to draw some differences between one role to another role. Let's take the example of the data science consulting teams. Consulting or services teams are expected to have, of course, across these four teams, the primary skill set is machine learning, and machine learning data science will remain to be the primary skill set. That's the core to which everybody hangs on to. But each of these roles differentiates itself from the type of work that you're going to do and the ancillary skill set that you will have to build around it. So, for example, for a data science consulting team, one of the most important skill sets that they need to have is communication skills. Every data science consultant should be very, very well conversant. They should have the ability to converse with the customer, b empathize with your client, because you should be able to understand the problem of your customer and then translate that problem into a data science problem, translate a business problem into a data science problem. I'll give you an example. So the role of a data science consultant essentially is that the data scientist, the business, have a conversation with the customer, and let's say with the customer of yours could be, let's say, a diamond mining company in let's say somewhere in Africa. The reason why I quote that is because that's one of the problems that I'm currently solving. So let's say you are talking to a diamond mining customer in Africa. They have no idea about what data science is. So you just cannot go there and start talking about regression and classification and machine learning and so on, because they honestly don't care, right, how you solve the problem. So your responsibility is listen to them, and their problem could be, well, you know what, one of the biggest problems that we have in our businesses is that our heavy equipment in our mine tends to break down very often.
So one of the challenges for our business is if we can reduce those downtimes or reduce the number of failures that occur to our components, then we should be able to improve the efficiency of our plant. This is their business problem. The business problem, quote unquote, is that there are a lot of downtimes, a lot of failures that are happening to a particular equipment in a plant in somewhere in Africa, and they've reached out to let's say you, who's a machine learning expert, who is, let's say, a consulting company, and they would want you to solve that problem. Now, there are numerous ways of solving this particular problem. One of the approaches of solving this particular problem is, okay, as a data scientist, if you were there, or let's say as a technology consultant, if you are there, you are expected to ask a few questions. What kind of data is being captured? Okay, we see that sensor data of the equipment is being captured. Great. Do you also capture the failures of the equipment? Let's say they say, yes, we capture the failures of the equipment as well. So using the sensor data and the failures information, we may be able to build a classification algorithm which would essentially help us predict, based on the sensor readings, it would help us predict, will there be a downtime or not? Will there be a component failure, yes or a no? Uh, so we essentially solving a classification problem here. So this transition of a business problem into a data science problem is what a data science consultant is supposed to do. That's exactly where his or her role is super critical, right? So that's the first and the most important thing, as opposed to, let's say, a captive data science team, or a data science team which is inside inside a particular organization, solving problems for that particular organization alone. The thing about that person is that, let's say you are a part of a telecom company or an insurance company, and let's say you are a part of, let's say, an election campaign for, let's say, one of the presidential candidates. You are as a data scientist, you are expected to understand your domain in and out very well. In the earlier case, you don't really have to be a master of the field, right? Master of the domain. You don't have to be a master of the mining domain. And if you know the mining industry, that's great. But if you are, let's say, a data scientist who's sitting inside that mining company, or he's sitting inside a particular who is working for a mining company and is hired for that particular mining company, then you are expected to be a master of the mining industry. You have to essentially learn the industry very, very well, understand the intricacies very well, and then based on that particular based on that particular value of that particular understanding of yours, you're expected to solve data science problems. So because now you're an insider, understanding the business issues and understanding the problems that people face in the field is much easier. So hence the responsibility of a data scientist in a captive data science team is slightly different from that of a consultant data science. Both of them solve data science problems, of course, but while a consultant data science is essentially looking at solving data science problems as a point solution, as a captive data science team, you are expected to solve data science problems in a much more holistic manner, because you are in that organization, you are aligning yourself to the aims and objectives of that particular organization. So you do slightly more than what a data science consultant does. Data science consultant, on the other hand, gets the opportunity to work on different kinds of problems, different clients, different problems, small engagements. So the variety is much larger, but the data science consultant doesn't have the ability to stick to a problem and work for a longer duration on that particular problem, as opposed to a data scientist in a captive data science team or an in-house data science team, who will have much larger time and much larger amounts of time in his hand to solve a particular problem. But the problem is, you might not have a lot of variety in the work that you do. So that's the captive data science team. Both are great. Both are amazing. One where you have fast-paced, lot of work, different kinds of work. Second, where you get to see a problem getting solved end to end. Right from ideation all the way until until actually deploying it and monitoring it and seeing how well it works and things like that. So yeah, so those are the first two roles. Let me tell you this: product research teams will come to product development in a minute. Research teams are essentially out of our league. If I mean, I think I'll go to the extent of saying that. The reason I say that is because getting into research teams requires us to have a lot of academic background. So if you're someone who's doing a PhD in AI, then probably you're someone who can walk into the field of walk into a research team. And the reason I say that is not because you're supposed to have a degree to get that particular role. No, that's not why I say that. The reason I say that is because you should have the ability to sit and work on one problem for a few years to get to the solution. So it requires a patience. It requires some method to the madness. Research, it is very research oriented, very slow paced work, but you will be working on cutting edge stuff that probably nobody is currently working on. So it requires a lot of skill set in terms of a lot of depth in the skill set. But you might not see you might not be able to churn out solutions as fast as, let's say, how the data science consulting teams or, let's say, in-house data science teams do as much. So the work could be far more slow paced in a research team, and the requirements are much larger. The third and a slightly interesting role is being a part of the product development teams. Let's say, for example, I'll tell you the kind of work that you will be encountering. Let's say, I don't know if you're familiar with this particular feature, and I'm going to show it to you right now. So in PowerPoint, right? So if you click on design, and if you click on right side design ideas, if you see this, it automatically pops up various designs that I could possibly set up for this particular various layouts that I could use to present this particular content. Right? How do they do this? And who's doing this? For all you know, who do you think is actually solving this particular problem? Right? In general, the kind of people who solve this particular problem are data scientists. Of course, this is a data science problem because I will have to automatically identify which layout to match to the content that I see here. So it's definitely a data scientist. Also, to the extent of what images should I put, right? What images should we put here? Product development and data science and things like that. So if you see, you generally have relevant images also that come up here. So this is definitely data science work, right? For sure. But who's doing this? So this is essentially done by a data scientist who is a part of the Microsoft PowerPoint team. So there are a lot of data scientists that are available outside. One of the data scientists who's working on this particular feature could be a data scientist who's aligned to the PowerPoint team at Microsoft. Similarly, you would also have a lot of other products. We're using, let's say, this particular tool called GoToWebinar, and there could be a lot of AI implementations that is happening in the background. Like, for example, there could be a team which is working specifically on monitoring the logs of this particular tool. Who would be doing it? It could be someone who is a part of it could be someone who's a part of the GoToWebinar, let's say, product team, who's going to sit down and evaluate, analyze, and things like that. So Pradeep says it is more of design and programming rather than data science. Well, not really. There is definitely data science, because you, of course, will have to build the solution that could map this particular slide to a new design. So there is definitely a lot of data science that is associated with it. But the thing is, you are aligned to a particular feature. You're trying to hone that feature. You're trying to make that feature more smarter by the day. You're essentially trying to ensure that a particular product is built really very well, and I'm embedding intelligence into one particular product. That's what that is what you're working towards. Say for example, a lot of us, let's say, are using Zoom over Zoom or Teams to communicate. So suddenly you see this background thing that's coming up, right? So you could automatically change the background of where you're sitting when you're casting your video. You could change the background. So who's doing that work? Automatically removing the background. It's essentially a part of a computer vision exercise. It's called as background deletion. Or background differencing. So you can automatically identify the background, and you can blur the background, or you can add some background to your video and things like that. All of that can be done. Who would be doing it? It is essentially again done by a data scientist who is a part of, let's say, Zoom's team. What is the best part about being in a product team? You can see the features that you build go out very well. I mean, you could definitely experience the product that you build. So you are building AI product, quote unquote, right? But what's the drawback of it? One of the drawbacks, I wouldn't say a drawback. The thing is, your work can get a little mundane. Your work can get a little repetitive beyond a certain point, because you're solving the same thing continuously. You're trying to improve the same product continuously. So a lot of things that I get to hear from a few people is that the work there could get a little repetitive. So yeah, those are the different types of those are the different kinds of roles that are available. Sumil Ahmed, data science consulting services role would be more of a business analyst. I have a particular slide where I talk about different roles, and so there are different terminologies and different roles. I will get to that when we talk about it, but no, these are not the same. If you're a data scientist, you're a data scientist. The term data scientist, data analyst, and business analyst are not one and the same. So let's not confuse them to each other. So when you're in data science consulting or data science services, you're still a data scientist. You still do data science work. The term business analyst is a very loosely used term across the industry, and we'll talk more about that particular term when we get there. But no, you're still doing data science work here. Cool. Okay, so I hope we all understand the different varieties of roles that are available. Okay, so let's talk a little about the various interview stages that are there, right? As far as the interview stages are concerned, I think in general there are three major, or rather, when I say there are three stages, I don't mean you will have 3 rounds. 3 stages are 3 types of rounds. Think of it that way. 3 phases of your interview. The first phase is, of course, you're going to have a 0th phase, which is your resume filtering. Your resume will get filtered even before you called for an interview or anything, right? So the 0th phase is where your resume filtering happens, and simple way of filtering a resume is dependent on the skill sets that I mentioned early on. You're expected to have Python experience. You're expected to have Python or R experience. You're expected to know SQL. You're expected to know have some knowledge on big data, and you're expected to have some knowledge on deep learning frameworks, like let's say your TensorFlow or what's the other one, PyTorch or Keras or any of these. So if you've been able to tick boxes of the 4, that means you have at least qualified from a tool stack standpoint. You have qualified. So at least those are a few areas which help us filter out a particular which help us filter out a particular piece of information, of a particular piece of profile. And many profiles help me filter down the profiles based on those skill sets. That's the first one. Secondly, most of the data science roles are often done by referrals. So find people who are working in a particular organization, and because it's very hard to evaluate a data scientist simply by looking at the paper. So if you know someone personally, it's much easier. So try to find someone who's working in a particular organization. They can vouch for you. and they can bring you along. So that's the other thing. So once, let's say, your profile is shortlisted, and shortlisting of a profile would not just depend on putting a random tool stack in your profile, but also on the work that you've done. So to evaluate what kind of work that you've done, you would have a hands-on session, right? A hands-on session essentially is a session that is generally conducted to ensure that you are, or you have those skills that you claim that you have, right? For example, if you claim that you're very good with Python, then you better prove it. So platforms like Codility, Hacker Earth, and there are many tools, right, that are available, code base and things like that. So there are so many tools that are available, so many online platforms that are available that help us conduct online that give you online challenges, and you're expected to solve those problems, right? These problems can be of two types again, right? These challenges could be generally of two types. These hands-on sessions could be of two types. So one is, let's say, an on-site challenge. That means you're given, let's say, 3 to 8 hours, and you're expected to sit down there and solve the problem then and there, right in front of them. That's one way of solving it. The other is a take-home, or a particular what do you call it, or a particular project that is given to you for, let's say, a week or a few days, and then you're expected to solve that particular assignment, and then you're expected to come back and display or showcase your results. Yeah, am I audible now, Ajay? Yeah. Okay. So both these tools are quite important. I mean, both these approaches are quite useful in displaying your Python skills. For example, I'll tell you one of the interviews that I recently attended, and one of the things that they had set up was, it was an interview that essentially lasted for 8 rounds, and of course it was for a senior role, so for a senior data scientist role. There are generally two kinds of, as I said, the two types of assignments that are generally given. One is a take-home, and the other is an on-site challenge. I was given a take-home assignment in this particular interview that I recently attended. I was given, so that particular assignment lasted for 2 hours. Even in this particular assignment, I was given, and this is a general framework of how interviews are conducted. So we were generally given either a data science problem, which basically means is a data set is given to you, a problem statement is given, just like Kaggle, right? If you remember Kaggle, if you're familiar with Kaggle as a framework, just like Kaggle, you're given a data set, you're given a piece of data, and a problem statement. You're expected to go ahead and build a model and showcase your results in your and you're expected to showcase your results in, let's say, um, a Jupyter notebook, or you're expected to present these results in that particular Jupyter notebook, right? That's one kind of a test. So this test could last around, let's say, 2 hours to 8 hours, depending upon, again, problem to problem. A certain assignments, for example, in one of the very early experiences of mine, I was given an assignment which expected me to, let's say, go ahead and code a decision tree algorithm from ground up. That means I was not allowed to use any code whatsoever, any library whatsoever. I was expected to write a decision tree algorithm in pure code, in pure Python code, and yeah, I mean, I was given 1 week time, and I was expected to go ahead and solve this and come back. So there are different kinds of problem statements that are generally given. At times, these hands-on sessions could also go to the extent of giving you a coding challenge. Like, for example, you're given a small algorithm, and you're expected to write that algorithm, right? Let's say top coder, or let's say code chef. These are tools that generally test you on your algorithmic and data structure skills. These tests could also go in that direction. So expect a hands-on session. That's generally the name of the game these days. Most companies have a hands-on session these days. Without a hands-on session, irrespective of the experience you have, people are not hiring without a hands-on session. For it will definitely apply to freshers. Yes, freshers. The one thing that people expect from freshers is coding skills. So if you are, and one of the reasons why people hire freshers is because you are good with your is because you're good with your coding skills. So definitely a hands-on session is conducted for freshers, not only for experienced people, even for freshers hands-on sessions are conducted. So get ready for it. Get ready to experience that. That's the first thing. um, it is a very good place to showcase your skills, right? So go the extra mile, do whatever you can to do whatever, I mean, make sure that you display as much variety as possible in your skill set to solve your solve problems during this particular thing. Also at times expect SQL based questions as well, right? SQL based questions, meaning you will be given a virtual platform where you're expected to write some SQL from some SQL queries. They'll give you some two tables, and you're expected to solve that particular problem using those SQL queries. Write some SQL queries to either, let's say, merge data or do things like that. Join data or perform some kind of transformations on top of data and things like that. Right. So that's as far as the hands-on session is concerned, hands-on round is concerned, and this is evaluated. Remember, this is not evaluated by the HR. This is evaluated by a data scientist. So a data scientist is going to sit there and he's going to look at these results and he's going to come back and tell you if you're selected or not based on this particular hands-on session. So understand that. Try to give your best in your hands-on session because this is a make or a break. If you don't clear the hands-on session, then there's no way you're going through. So make sure you write comments very well. You have to add as many comments as you can, and give enough explanation about why you've done a particular step. Don't just randomly put code in the Jupyter notebook. Make sure you add enough comments or enough doc strings that you leave within the functions that you write and things like that. Okay, that's as far as the hands-on session is concerned. Once you clear the hands-on session, right? If you've cleared the hands-on session, then pat yourself on the back. That means you've done a good job, right? So, but before you even enjoy you clearing the hands-on session, you will have a lineup of technical interviews. Now, the technical interviews could be done generally. Now, in my organization, we have two to three technical interviews. Depends from company to company again. So, for example, Amazon would have 3 to 4 technical rounds of interviews. Microsoft has 2 to 3 different interviews. So we have 2 to 3 technical interviews depending upon the candidate again. So the first interview could be a simpler round where one of the team members or senior team members could be interviewing you. And it is going to be a data scientist who will interview. So they're going to be hardcore technical questions, and I'll talk about how and what kind of questions are going to be asked to you in the next section. When I talk about the questions, I'll ask you about them there. I'll tell you about the kind of questions that you're likely to be asked as we move forward. The next round is also generally by a technical person. It could be a data science team manager. I was interviewed by data science team managers from various different locations. So I was interviewing for a particular location. I had different data science managers coming in from different locations to interview me. I was, let's say you also, let's say you clear these rounds as well, then the next round is generally by the org lead, the head of that particular organization, vice president. The interviews that are generally conducted by the product owners, or let's say principals, partners, or delivery heads, or vice presidents, they are very business oriented, right? These are not technical rounds. These are non-technical rounds, but based on data science, where they are going to test you on they're going to test you on your business acumen. How well do you understand businesses? How well can you translate a business problem into a data science problem? Again, these rounds will depend on the role that you're applying for. So let's say, for example, you're applying for a consulting role, then you would be interviewed by, let's say, a partner or a principal, or let's say a practice lead for that matter. If you're interviewing for, let's say, a product division, product company, then you would be interviewed by a technical manager and, let's say, a product sponsor or a product owner, because they want to make sure that you have enough capability to solve that particular problem. Again, the depth of interviews may depend from one company to another company, but essentially get ready for at least 4 to 5 rounds of interviews on an average. I'm talking about on average in a fairly reputed industry, MNC, gear up for 4 to 5 different rounds of interviews. At this particular point, what we are seeing is, of course, more or less all the companies do have a ban on hiring given the COVID situation. But in general, what we generally see is we prefer conducting these sessions face to face as much as we can. If not possible, of course, we do some preliminary rounds in telephonic, and then so R1 can be conducted. The first technical round may be conducted as a telephonic round, but eventually the person is called upon because you'd want to have a face-to-face interview. So face-to-face is generally preferred, at least for the later parts of interviews. Face-to-face interviews are generally preferred. So that's generally the layout of how your interviews would be conducted. Expect a hands-on session, expect a couple of, expect at least 2 or 3 technical rounds, and expect one hiring manager or a lead, a vertical head or a vertical lead delivery head sort of a person who will ask, who will be taking your interview. So yeah, I mean, for example, Amazon by default has around 8 rounds of interview, in respect to the role that you're attending. But in general, data science, yeah, you're looking at around 4 to 5 different rounds. I applied for a strategy consulting company a few years ago, and I had 8 rounds of interview there as well. So there was different people who were being called upon, different people who were asking me questions. But I think it's good in a way because it gets you the flavor of what they want from you and things like that. So yeah, that's essentially the layout of how your interview generally looks like. But I think the more important question is, what kind of questions do these guys ask, right? In a technical round, what kind of questions are generally being thrown at you, would be thrown at you? So in a technical round, the type of questions that are generally asked is, again, I could probably break this down into 3 different categories. I don't know, 3 seems to be the number of the day, but 3 broad categories. The first one, of course, is questions based on any previous experience that you have. See, as a data scientist, because all of you are fresh in the industry, it's unlikely that you would have, because all of you are moving into the industry for the first time. As a data scientist, as an interviewer, I would be searching for some common grounds to ask a question at you, right? If you simply come and put your past experience and tell me that I've done a course in data science and I like to move into the field of data science, it's unlikely you will get hired. I mean, it's unlikely that you will find people who will be interested in you. So you have to find some common grounds between yourself and the interviewer. And the way you could do that is by putting some kind of data science experience in place. What kind of experience do you put in? Let's say you've solved a Kaggle problem. That's also some kind of data science work experience. Of course, it's not quote unquote official work experience, but it is definitely some work that you've done in the field of data science. So it gives the opportunity for your interviewer to ask you questions on. That's the first thing. Secondly, if let's say you've done any project in your course, you've done a course, let's say you've done some capstone projects, so let's say you've done any kind of projects in your course, or you've done a side project, that could come in handy as well. So Kaggle projects, or let's say some capstone projects that you've done in your class, within your course, or let's say any kind of data science solutions that you, let's say, were a part of in your previous organization, but you of course were not actually doing the data science, but let's say you're a part of a data science team. And if you could quote some data science work that you could have possibly done in your previous organization in the data science team, then that could come in very handy, because that could prove very useful to in terms of at least establishing some common ground between yourself and the interviewer. You don't want to randomly put something. So let's say you solved a Kaggle problem, right? That gives some scope for the interviewer to ask questions on. Okay, so if they see that, okay, you solved a couple of Kaggle problems, mind you, people like Kaggle problems, right? Trust me. Most people prefer people having some kind of experience. It's not that you put randomly. Um, it's not that it, you'd want to have some experience before you actually attend an interview, and Kaggle problems, people do recognize that as valid experience. um, so let's say you solve a particular Kaggle problem. What kind of questions can you expect from those? You will be asked about what kind of steps did you perform, what kind of let's say, what was the problem statement about, why are you solving that particular problem, what is the business impact of solving that particular problem. And you will have questions about what kind of pre-processing did you do, what kind of model did you build, how did you evaluate your model, why did you only evaluate your model in that particular fashion, why could you not have used another kind of evaluation technique, and things like that. So there could be other questions, there could be a laundry list of questions that could be shot at you, but all of them could more or less be based on the work that you have previously done. So that's the first category of questions that you could be asked. The second category is pure play technical questions. Out of the blue, they might throw some question at you saying, how do you build a decision tree algorithm? Explain a decision tree algorithm ground up, right? Don't expect these questions to be completely vague. They will still be relevant to the work that you would have more or less done, but pure play technical questions, right? The third is scenario based questions, meaning the interviewer might give you a particular scenario or a case study, and he would then ask you to go ahead and give you design a data science solution or data science problem around this particular problem statement, and tell me how you will solve this particular problem. So you'll be given a scenario, and you're expected to sit down then and there, solve this particular problem, solution it right at that particular point in time. These would be real-time scenarios. Absolutely, yes. These could be real-time. It could be hypothetical as well. But in general, most of the questions that are generally asked are real-world scenarios. Yeah. Then that'll be tough to. Absolutely, yes. I mean, that's the whole point of an interview. The questions, it doesn't matter if you don't answer it. What we're looking for is, do you have the ability to um, at least approach the problem in that particular direction. We don't expect you to, as an interviewer, you're not expected to be spot on with a candidate, you're not expected to be spot on with your answer. You expect some guidance by the interviewer as well. They'll guide you through your solution, because even in a real world scenario, it is not one person who sits and designs a solution. It will be multiple people who will sit down and design a particular solution. So you are essentially starting the problem in a particular direction. You're expected to solve it, or rather design it in a certain way, and then we can talk about it. I'll give you an example. When in the next slide, I'll give you an example of what kind of problems are generally asked, what kind of case studies are generally asked. I can give you a couple of examples from the interviews that I've attended previously, or I've taken, with the kind of interviews that I have asked, the kind of case studies that I have asked in my previous interviews. I'll give you those as well. Yes. So these are the three types of questions that you could expect. One is questions based on your previous expertise or experience, case study based questions, and pure technical questions. Pure play technical questions that could be asked. Let's talk about what kind of questions do they ask, right? So here's some tricks of the trade. So I'm as an insider, I'm giving you some inside dope about what kind of questions are generally asked. Okay, as an interviewer, these are the questions that I generally ask. Always remember this one thing, that data science as a field is a vast field, is a large field. It's and all data scientists understand it, right? Data scientist as a field is so large that there are so many sub fields inside the subject of data science. Somebody becomes a computer vision analyst, or computer vision specialist, or computer vision scientist. Somebody becomes a natural language processing scientist. Somebody is a machine learning specialist who strictly works on machine learning. So they're different pieces of work that people specialize in as they move forward in their careers. So you are not expected to be a master of all. So hence, as a result, what happens is most of the data science interviews are based on the work that you have previously done. right? Most of the data science interviews are based on two things: the work that you have previously done and the kind of role that you're interviewing for. What that means is, because the field of data science is so large, if I were to ask you a question, it will be unfair if I ask you a question on something that you have not worked on previously. Because if you ask the interviewer a question that he has not worked on, he will not be able to answer himself, because the field is so new, the field is so evolving, uh, the field is rapidly changing in active research. Hence, that's one of the reasons why people prefer asking questions from your previous experience. The second is, and it's a general um, and it's a general sentiment. The first line that my first two lines that I've mentioned is a general sentiment of any interviewer. Trust me on it. I've interviewed so many candidates, and I have seen so many people interviewing candidates. I have attended interviews myself, so I understand that the first two lines are absolutely true. In most cases, in 90% of the cases, there are always that 10% of category uh, who who find some kind of happiness in interviewing someone and making their life difficult. So I'm not talking about those 5-10%. I'm talking about the generic crowd. For the second type of questions will be based on the role that you're interviewing for. So let's say you're interviewing for a strategy consulting company, or let's say you're interviewing for a technical consulting company, technology consulting company, like let's say Accenture. You're interviewing for Accenture. So your questions will be primary. The questions that you will be asked will be based on, okay, you will be working with a client. So how will you explain a linear regression model to a client, right? How will you explain the output of a logistic regression model to an end customer? Let's say you will be presenting to a vice president of a particular organization. You're working with a particular client. You'll be presenting your results to the vice president of a particular organization, to that particular client of yours. How will you explain? You've built a logistic regression model. How will you explain the coefficients of a logistic regression model to your end customer? Right. So the coefficients of a logistic regression model, how will you explain it to the end client? How will you explain the coefficients of a linear regression model? How will you explain a decision tree? If you were to explain, this was a question that was asked to me. If you were to explain a decision tree in layman terms to to someone who does not understand data science at all, how will you explain data science to a complete layman, to a complete layperson who doesn't know anything about data science? How will you explain it to him or her? Right? Because you will be talking data science to such people, because you're in a consulting company. You will be talking to people who don't understand data science. So you will be in situations where you will be asked to explain these complex algorithms in a very, very simple form to someone who doesn't understand data science.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Or how do you explain a confusion matrix to a complete layperson, right? So communication skills are super important, and these specific questions um, these specific questions will be asked to you whenever you're talking about questions based on roles. So two categories of questions. Of course, these are uh, different types of queries that could be asked. But I think all these queries will be filtered by your previous experience, and technical questions or non-technical questions based on the role. I think it's better I mention it that way. Technical questions based on the role you've applied for. So so that's how your questions can be primarily categorized into. So those 2 points that I mentioned over there are really, really important. So keep that in your mind. So don't worry if you don't know something. Say a no. You don't have to dump your profile with all the possible keywords in the world. You don't need to do that. I understand most of us do it for to make sure that our profile gets shortlisted. But I think you have to understand that um, it's not people interviewers do understand that it's not possible for one guy to have an experience on every possible thing on the planet. So it's okay if you do not know, if you have not worked on NLP, you have not worked on NLP. It's okay. If you've not worked on computer vision, you have not worked on computer vision. That's okay. But at least you know you should know the basics of natural language processing or text processing. You should know the basics of computer vision, basics of how a simple deep learning model works on images and things like that. So you should be able to explain the basics of it. So when you talk about your previous project, let's say you've done some project, or let's say you've done some previous work, what kind of questions can you expect? Let's take the example. Let's take an example. Let's say you have solved a particular classification algorithm to predict will a particular person churn out from a telecom company or not. A very, very classic problem that any telecom company would be ideally solving, right? Predicting churn, right? That's what we call it. So let's take this example. Okay, so when you predict churn prediction, when you predict churn, let's say you've done this as one of your previous problems, or let's say you've solved this as one of your one of your Kaggle problems, right? Kaggle also has a lot of such problems. So you can go back to Kaggle and then solve any of these problems. Let's say you're trying to predict churn. What is churn? Anyone who understands what churn is? Churn is basically the probability, or churn is that particular behavior of a customer when he or she quits a particular service provider and moves on to another service provider. So for example, you've quit AT&T and you move to Verizon, or you quit Jio and you move to Airtel. Such kind of an exercise is typically referred to as churn. It's not only in telecom, it is applicable to any competing platform, right? So for example, you are a customer of let's say a particular insurance provider. You quit that insurance provider and you're moving into another insurance provider. So that is churning of a customer. What you're trying to predict is, you're trying to predict based on the behavior of a particular customer, you're trying to predict will the customer churn out or not. A nice classification problem, right? So the questions that you can expect here are, first things first, why are you solving this problem? Why are you predicting churn? Why is predicting churn important for the business? Why is predicting churn important for the business? The reason why predicting churn is important for the business is because it helps me identify what are the possible, it helps me identify which customers are likely to quit. Hence, even before they actually quit, I can reach out to them and I can do some kind of intervention. I can provide some kind of intervention and stop them from quitting. So for example, if a person chooses to quit, let's say Jio and join Airtel, or quit AT&T and join Verizon, then I can, as AT&T, what I can do is I can intervene in between, and I can tell that, okay, sir, looks like you've decided to quit. Is it okay if we'd like to provide you an offer, and we'd like to retain you as a customer, and because you're one of our loyal customers, we'd like to give you an offer, and the offer is, let's say I give you a $20 discount over the next X number of months, or let's say I give you free free voicemail services for the next X number of months, or let's say I give you free 1 GB internet per day for the next X number of months. So I give him some offer, right, to retain him. So predicting churn is really important because it helps me. I predict which customers are likely to quit and stop them from leaving, or try to at least stop them from leaving. Right, intervene, provide some kind of intervention strategy. The second reason why I'd like to predict churn is because currently for a company like AT&T, the churn rate is at around 6%. 6% churn rate is very, very high, and one of the primary objectives of the organization is to increase the customer base, which means we have to make sure that the number of customers quitting should reduce. So how do we do that? By making sure we stop people from leaving, or predicting even before they could possibly leave, right? These are two possible reasons why I might want to predict churn. Okay, one, I know that it's a big business problem, high impact business problem. Second, I know that the reason why I'd want to predict churn is because it is a part of my business charter. It's that's how my business wants to operate. So okay, business explanation provided, and you can drill deep into it. I mean, if you know more about that particular problem, you can dig deeper into that particular problem. Great. Okay, you that's the reason why you'd want to predict churn. So the next question is, how did you go ahead and prepare your data, and what kind of data was available with you? Great. So I am in a telecom company, right? So let's say I'm in a part of the telecom company. This is telecom customer, let's say. The kind of data that we had brainstormed to identify what factors could influence churn are as follows. The first one is billing reasons. The most important reason why customers quit in telecom company is because of billing. High bills, greater chances of quitting generally, right? Sudden spike, billing information was available. I know previous history about the customer, uh, customer care information, meaning how many times has the person reached out to the customer care and things like that. Some kind of demography involves age, location, and things like that. So for example, people who are 60 years old, 55 years old, the likelihood that they would quit will be very, very low, right? Because by now they're like, oh, care. I mean, it doesn't matter. If I'm spending 500 rupees a month on my telecom, it's okay. They probably reach that particular stage where they don't worry too much. But a 20-year-old or a 16-year-old who is having a mobile phone, 500 rupees a month is very, very expensive for him or her, because they are not earning as yet. So the likelihood of somebody quitting is much higher in a lower age group than in a higher age group, obviously, right? So demography is really critical. In addition to this, we have also taken into account, let's say, the his current plan information, what kind of plan is available, some kind of competitor information, and things like that. So on and so forth. This is the kind of data that we've taken into account, right? So at this particular point, you could be asked questions saying, okay, don't you think um, the order information about or value added services that are being used by these customers are important in predicting churn? Meaning value added services are like, let's say, voicemail. Value added services could be, let's say, missed call alerts and things like that. So don't you think those are important in predicting churn? Or maybe they are. If somebody does not use a lot of value added services, they are not making the most out of the company, so they probably do not have enough loyalty towards that particular company, right? And hence they might want to quit, right? um, so you might also want to use information about what kind of tickets were raised in the customer care. Don't you think tickets information is important? So you could have questions like these: what kind of data was used? This is the kind of data that was used. Okay. The next question could be, how did you prepare your data? What was the data preparation that you had to do? Great. So the way we prepared our data is, we had to do some data pre-processing. For example, our demographic data had some missing values. We had some erratic data points, like for example, there were data points which had age which is greater than 100, 101, 120. So some outlier removal was done, some missing value imputation was done, some scaling was performed to a few features, some additional features, some feature engineering was performed. Feature engineering meaning some new features were extracted from my data and things like that. So that's how we prepared our data. Our data set had a few, eventually I created my data which had X and Y, where X had all my independent features and Y was my dependent features. Now the question could be, what was the size of the data, and why did you and how did you go about solving this particular problem? So currently your question is, okay, let's say at this particular point I had 1 million records. My X's were 1 million, and my size of my data set was 1 million, and my X and Y put together had a size of 1 million. I split this data into two parts, which was train and test. 60 and let's say 60% and 40%, or 70% and 30%. However, I used my train set to build my model and evaluated it on my test set. Great. At this point, you might have asked another question: why could have you also performed cross validation? Why did you not perform cross validation? Well, cross validation could have also been performed. Yeah, I mean, I probably missed out on that. Maybe we should have performed cross validation here. So at that moment, you might be asked questions about what is cross validation, right? How is cross validation different from train test split? What is the benefit of using cross validation, right? You'll be asked questions like that. You could also be asked questions on uh, you've performed outlier removal. Explain what an outlier is. What is an outlier, anyone? An outlier is a point that behaves erratically from the rest of the data points, right? So you would want to identify, okay, how do you identify outlier? How do you identify a particular outlier? Boxplot is not the only way of identifying outlier. Of course, Boxplot is one way of doing it. You could also do it via, let's say, you could simply use a simple terminology of your histogram. You can plot a histogram and you could also visualize on either side. Or let's say you can look at mean plus or minus 3 standard deviations from the mean. Mean plus or minus 3 standard deviations. Any point which is less than 3 standard deviations from the mean and greater than 3 standard deviations from the mean are considered as outliers. Mean plus or minus 3 sigma or z-score exactly. You could use z-score to identify it. So things like that. So these are different ways of evaluating a particular, removing outliers. How do you fill missing values? Why did you fill missing values? Should you fill missing values or not? I mean, if let's say your data set has 20% of missing data, what do you do? Or if your particular column has 30% missing values, what do you do? Do you fill missing values? Let's say there's a column and the 30% of the data is missing. What do you do? Fill it with mean. Okay. If 30% of the data is missing, would you still go ahead and fill it with mean? Think of it. Yes. Okay. Interesting. Okay. Yeah. So generally, when you have more than 30% of the data missing, I would do two. I would think of two things. One, do I have enough data points? One, do I have enough data points or enough records, enough observations in my data, enough rows in my data to remove those 30% of the rows? Right. So if I remove 30% data, let's say I have 1 million observations. If I remove 30%, it's okay. I still have 70,000 records, or let's say 700,000 records available with me. So I might, in that case, remove rows. Right? But if my data itself is very small, let's say just 20,000 observations, if I remove 30% of it, then I'm losing a significant chunk of my data. I'm losing around 6,000 records out of 20,000, which is a huge dent to my data size. So in that case, I might want to decide and say, okay, let me drop the column. Worst case, I might go ahead and fill missing values. Filling it with mean, median, mode. I might only do it in worst case scenario. I might not do it always, right? So that's probably the last approach that you'd want to follow to fill missing values, because filling missing values essentially means you are speculating on the data. That means you are filling with values that are actually not a part of the data. So you don't want to speculate too much about a given data set. So that's the reason you wouldn't want to fill too many missing values. The point that I'm trying to drive here is every statement you make, you will be double clicked at that. Meaning, if you say that I have filled missing values, you'll be asked, you could be asked what kind of imputation techniques do you know of, right? How do you why should you fill it with mean? Why not with median? When do you fill with mean? When do you fill with median? The questions like these will be asked. So when you build a train test, when you build a model, then the question could be, what kind of model did you build? Did you do even before did you directly jump to model building, or did you do any kind of data visualization? Did you do any kind of exploratory analysis? So you could be asked questions like these. Let's say if you say that, okay, yes, I've done the exploratory analysis. The questions could be, what kind of exploratory analysis have you done? Okay, the kind of exploratory analysis that I've done can be categorized into two parts. One is univariate and multivariate analysis. Univariate analysis is analyzing single variable at a particular time. Analyzing multivariate analysis and analyzing multiple variables at a given time. Meaning, histograms are univariate charts. Your correlation is a multivariate analysis. Your scatter plots are multivariate analysis, and so on and so forth. So you would want to mention that I've done univariate and multivariate charts. So the question could be, what findings did you see from your univariate and bivariate chart? From my bivariate charts, that I've understood that age and churn rate are negatively dependent on each other. That means higher the age, lower the chances of somebody churning. That's something which we have recognized. Secondly, what we've also identified is higher the age and bill amount seem to be negatively correlated with each other. That's another thing that we've identified as well. And what we've also identified is churn is heavily dependent on the location. That means certain specific areas, they seem to have a high churn rate as opposed to other localities. Okay, so you essentially mentioned the insights that you've generated from your exploratory analysis step. Once you've done your exploratory analysis, the next step is, okay, now you've done your exploratory analysis, so what have you done next? We went ahead and we performed model building. So when you build, what kind of model did you build? Let's say you mentioned that I have built a random forest model. The question straight away would be, why did you not try logistic regression? Why did you go for a random forest model? So you have to be careful when you mention these. Always clearly explain the experimentation that you have done, that you have performed. So you can simply say that, okay, first I've built a logistic regression model. My model was not doing great, hence I tried a random forest model. Immediately the next question would be, how do you know that your model is not performing well? Okay, to know that, so because this is a classification problem, I had to evaluate my model based on confusion matrix. Straight, the next question is, what is confusion matrix? Right? So almost every step you will be asked a question. So rehearse this story very well, right? If you're putting a particular problem statement within your analysis, within your profile, if you're saying that I've solved so and so particular problem previously, then make sure that you have a that you've done this analysis really very well. That means at every step you should be able to explain what you have done, right? At least to some level of clarity, you should be able to explain what kind of pre-processing have you done, what kind of exploratory analysis have you done, what kind of model building did you do, how did you evaluate your model, was precision important or was recall important, right? Between precision and recall, how do you differentiate between precision and recall? When is F1 score needed, right? See, for us interviewers, right, one of a simple litmus test to evaluate if a candidate is fit or not is based on your understanding around confusion matrix. If you understand confusion matrix well, then that's an indication that, okay, looks like you've been able to get a hang of things. If you haven't understood confusion matrix and if you're still claiming that you have learned data science, then I'm sorry, you probably not. Then that's a very clear indication that you could be sent back home. So if you're getting grilled on confusion matrix and if you are unable to answer questions in confusion matrix, my friends, trust me, go back and do good research on and spend some time on how confusion matrix works and understand how precision recall F1 scores are really work. Right? So that's a nice way of identifying. It's a nice hack that we interviewers apply whenever we want to identify if a candidate is really good or not, right? So we question quite a bit about evaluation of models. So how do you, if confusion matrix is for if you use precision and recall for classification problems, then what do you use for regression models? What metrics do you use for regression models? So the answers could be, what kind of approaches do you use for regression models? What kind of measures do you use for regression model? MAE, exactly. MAE, MSE, RMSE. Spot on. Perfect. MAPE, the different metrics that you can use over here. Yeah, spot on. So that's how your interview conversation is going to go on. Especially here at this particular point, I've just mentioned a few questions here. I think it's worth for you all to go back, have a look at the slide, and prepare your problem or your project, or prepare yourself for answering these questions around the projects that you've done previously. So if you are claiming that you've done your project well, then make sure that you have answers to at least 80% of the questions here that you see on the screen. Okay. Especially, what is the most important thing? I mean, all the sections are really important, but one of the things that people often fail to understand. So, for example, if it's a Kaggle problem, for a Kaggle problem, you might only know the business problem. You might not know the business impact, so to say. That means if you solve a Kaggle problem, the Kaggle on a Kaggle platform, the problem statement would simply be mentioned, but you might not know what would be the impact of solving this particular solution. That means you solved a churn prediction problem, but you wouldn't know what is the business impact of that particular problem, right? So that's one of the things that you have to keep in your mind. So it's okay if you don't know a lot about it, but at least what you should definitely be able to talk about is what else you have done as a part of your as a part of your solution. The other thing is, if this is an open source problem, I mean, it's a problem that you've done on Kaggle or something like that, then put it up on your GitHub profile online. Use your online GitHub profile and put content there. Put a notebook or put your code that you've done and put it up there for everybody to consume. Let everybody use it. I think it's a nice. I mean, you can put a GitHub profile in your resume as well. That way, you can draw a little more eyes. You can add more credibility to the work that you have done. So while some interview is being taking place, somebody might just go to your GitHub profile and actually view what you've done in your GitHub profile. It helps. Um, it helps identify how well have you solved, yeah, or how well have you written your code. Yeah, the most frequent kind of problems that are solved are supervised learning problems. um, Reinforcement learning sounds cool, but it's not an easy technique to use. So not a lot of problems that we solve in the modern day and at this particular point are belong to the reinforcement learning bucket. I would say 80% or rather 60%, 60 to 70% of the problems that we solve are primarily supervised learning problems. There could be a few that are, I mean, there are of course that 30%, 35% of the problems which are unsupervised learning. The rest 2 to 3% problems are your reinforcement learning problems. So I think if you were to, I think if you were to prepare yourself for a data science interview, it's worth spending your time on supervised and unsupervised learning than reinforcement learning. You spend majority of your time on supervised and unsupervised learning. Yeah. Apart from the hands-on round, all are basically from project we have done, more or less. Yeah. Apart from the hands-on round, most of the questions that you would be asked will be on the projects that you've done previously. Majority of the grilling will happen in that direction only. You could also be asked questions based on scenarios. That means you would be given a particular problem statement on the fly. You're expected to solve it. I mean, solve it in the sense you're expected to answer questions on it. But apart from that, case study or scenario-based questions, majority of the questions will be based on will be based on your project-based questions only. And I'll talk about scenario-based questions in a few minutes. Okay, how to explain a person who does not know data science concepts? Yes. Okay. So let's take the example of linear regression, right? And I'll give you an example of one model, and I'd like you to look at every other model in the same fashion. Let's take the example of linear regression. A linear regression model. Let's say you've built a model which has information like this, right? Which says sales is equal to a linear regression equation. Let's say your problem statement is a ballpoint pen manufacturing company would like to predict the sales of that particular company in a given region, right? Predict sales of a ballpoint pen manufacturing company in a particular region. So there are many regions, and I'd like to predict what the sales of that particular what the sales will be based on that particular region. So let's say you've collected your data and then you solve your problem, and your equation looks like this. So sales is equal to 40 plus. You found your linear regression equation like this. I hope you all understand how to create this particular equation. In Python you can use your linear regression model, or in R you could use the LM function. So there are different functions that will help us build this particular equation based on historical data. So you have 40 plus, let's say 10 times money spent on ads minus, let's say 5 times number of competitors in that particular region plus I don't know what else could, so plus 6 times number of stores where we sell our pens. So my sales at this particular point is dependent in this particular, using this particular equation. Now the question is, how do I explain this to someone who does not understand linear regression? It's very simple actually. So what we're saying is, for a unit increase in ad revenue, so if my ad revenue increases, or ad budget increases by $1, right? The money spent on ads increases by $1. My sales, would it be positively impacted or negatively impacted? The way I would interpret it is, because this is 10 and this is positive 10, it would be positively impacted. Hence, if my ad revenue, ad budget goes up by $1, then my sales would also go up by $10. 10 units, whatever, $10 or 10 units, whatever, positively dependent. So if my ads go up by $1, my sales goes up by $10. Why did I say 10? Because the 10 is mentioned here, correct? So you don't have to mention to the business about this particular equation. You don't have to talk about this equation. That's okay. I mean, if they want to look at, if they want to talk about the equation, or if they're interested in the equation, that's a different story. I think the way you'd want to tell it to someone who doesn't understand data science is, historically we have analyzed data related to money spent on ads, the number of competitors in a given region, and the number of stores in a given region, and we were able to mathematically model how the sales are associated, or how the sales are dependent on these three features. A few key insights are, first one, as the ads increase, or rather as the number of ads increase by, if the ads revenue or ads budget increases by $1, that means the money spent on ads, if it goes up by $1, then my sales go up by $10. If the number of stores increases by one unit, then my sales increases by $6, or 6 units, whatever those units are. And if the number of competitor increase, if one additional competitor is added in that particular group, then in that particular region, then our sales drops by 5 units. So this is essentially the kind of explanation that you'd like to give to someone who doesn't understand data science. You don't have to explain him that equation. You just have to explain how sales is related to ads, or how sales is related to competitors, and how sales is related to your number of stores. So that's how you explain it to someone who doesn't understand data science. So this is just an example of how you can explain it to data science. You can also do the same for, let's say, a decision tree algorithm, or let's say any other algorithm also, for that matter. Cool. So let's move on. Let's move on to the next part. So tricks of the trade. So this is what I was talking about. So there are numerous questions that you would be asked, specifically based on the work that you're doing. The next type of questions, right, that you could generally be asked, as I mentioned, is your case study based questions. The case study based questions could basically be like these. Case study questions could be like, the interviewer would give you a particular scenario and you're expected to solve this particular problem. I don't want you all to answer the question. I'm going to give you a scenario and just think about it. I'll give you all a few minutes, just think about it. And then I will give you one possible way of solving this problem. And then you can evaluate if that is a good approach or not. Because if everybody is going to dump in approaches, then we might not be able to progress in the class. So think about a possible way to solve this particular problem. So the question goes this way. So imagine you are let's say you are Facebook, right? Let's say you're working for Facebook and as a team lead. And in your team, you have a few openings. Okay, there are a few openings in your particular team, and you'd like to hire a few people, right? And because you're Facebook, one of the most popular companies outside, obviously you would receive a lot of applications, right? Let's say you've received 10,000 applications for the two roles that are open as data science. Let's say there's a data science roles only, just for the simplicity sake. So you have a team, and within your team you have two openings, and or let's say one opening for that matter, and you'd want to fill that particular role. You have received a lot of applications for that particular role. Now, the thing about this particular role is that you would want to make sure that this particular role, or the person who is going to be hired in that role, is similar to the ones that are already there in the team. Let's say your team already has 20 people. You would want to make sure that the new person who will get hired is very, very similar to the existing 20 people in your team. Okay. Question is, how do you identify? Of course, you cannot interview 10,000 people. I mean, if you interview 10,000 people, you're going to die. I mean, there's no way you want to do it. So you are expected to build an algorithm, because again, you're a data science team lead. You're expected to build an algorithm that can automatically identify the best person, or the most eligible people out of the 10,000, or the 5 most eligible people out of the 10,000 people, so that you can go ahead and interview them. Okay, that's the question. I'll repeat myself again. There are 10,000 people who have applied for a particular role in your company. You'd want to fill that particular role if and only in such a way that that person who's going to get hired out of the 10,000 is very similar to the ones who are there in your group already, who are available in your group of in your company already, in your team already, let's say. So the question is, how do you hire this person? There's no way you can interview, because if you're interviewing, then you'll have to interview 10,000 people. So if you're going to interview each of the 10,000, then you'll never be able to hire that person. So your responsibility is to devise an algorithm to automatically shrink the size of people you'd want to interview. I'd want to identify 5 most uh, frequent, 5 similar people. Imagine I have my data like this, right? Let's say there are a lot of data. So this is my team, and I have 20 people in this team, and I have opening for one person, right? One opening. I have one opening. For this particular team, I have a lot of information for about my existing team. So I have information about location, where they come from, skill set. I have information about their experience, right? Their likes, their dislikes, and things like that. Because the reason why I want to hire a similar person is because I want him to be a perfect fit in the team. I don't want this fellow to be an alien in the team. So that's the reason I want to make sure this fellow is a perfect cultural fit within the team. Okay, so I've captured all of this information: location of the person, the skill of the person, previous experience of that particular person, his likes, his dislikes, and so on and so forth. Similarly, for the 10,000 applicants that I have the same exact information with me, right? The same exact information I've captured. So location, skill set, experience, likes and dislikes, right? Location, skill, experience, likes and dislikes. The same information is available on both sides. Question is, how do you identify out of the 10K those 5 people who are going to be interviewed for this particular role? Think about it. Not in a hurry, unless you are, but I'll give you like a couple of minutes. Think about it. Think about how you're going to solve it. Yeah, and of course, this is the data science interview. So think of data science approaches to solve this problem. Right. So use data science techniques. Think of what kind of data science techniques can you use to solve this particular problem. Filter on experience required and skill sets. Yeah, I mean, I have 20 people within my team. So I want to find someone who's similar. I just don't want to filter someone on skill set and experience. I have likes, I have dislikes, I have location, I have, let's say, a lot of other information as well. It's not just on list on this. Since it's categorical data, we go for classification problems since we have historical data to compare. What is categorical data? Where is my target variable here? Think of, okay, here are a few questions. Where is my target variable? Do I have a target variable? Regression model. What is my target variable here? Why is years of experience a target variable? Okay, think about it. I mean, you're not in a hurry. Think about it. So firstly, think of, do I have a target variable? Is this a classification problem, or is this a supervised or unsupervised learning problem? If it is supervised, then is it classification or regression? Take all the liberty that you want and devise a possible solution. Grouping and narrowing down to the data set. Okay. Appropriate person. Let's answer this question. Okay. So firstly, and by the way, this was a question that was asked to me in one of my earlier interviews. Trust me. So this is a real world problem that was, or a real interview question, so to say. This was asked, actually a similar problem was asked in 2 interviews of me. A similar problem, not the exact problem, a similar problem. Okay, let's answer this question. The first question is, first things first, the most obvious question is this a supervised learning problem or an unsupervised learning problem? This is a unsupervised learning problem. The reason is, I do not have any historical information about who was previously interviewed and if they got hired or rejected. I only have historical information about who got hired, because I know that those 20 people are there in my team. I know information about who got hired. That's all. I have no information whatsoever about who previously got interviewed and and who have been rejected and who have been hired. Out of that, I only have partial information, which is I know the existing people in my team. So do I have a target variable here? Do I know what I'm chasing here? Unfortunately, no. I know that I want 2 people. I know that I want 5 people, let's say, but I don't have a target variable in my historical data that I can solve a problem for. I hope that everybody understands what that is. I hope everybody's clear with it. Right? I don't have a clear-cut target variable over here which says yes or no, hired, not hired. Do I have a historical data which says 10,000 applications or 20,000 applications historically? Out of the 20,000, 20 people got selected. The 99,980 people got rejected. Do I have a data set like that? In this problem statement, I don't. I just have 20 people who have been hired. I just have information about who have been hired. I have information about 10K applications which have come in for the remaining 5 people. So that's all that I have. Okay. So this is, unfortunately, this cannot be solved via a supervised learning problem. I can solve it via a supervised learning problem if I make an assumption. And the assumption is, I will assume that if I assume that there is a data set that is available historically, which tells me to hire these 20 people who are there in my team, how many have been hired and how many have been rejected? How many have been interviewed and how many have been rejected? If I have that information, if I assume that that information is there, then I can solve this as a classification problem. Does that make sense? I hope we all understand that. So let's make that assumption. Let's solve this problem in both ways. Why reject one approach? Let's go and solve this as both problems. Okay. So let's make the assumption. The first assumption is, just a second. The first assumption is that there is a data set that is available. A data set is available which basically has information about right? Let's say people who have been rejected. This is the list of interviewees. This is the list of people who have been interviewed and hired. I have a column which has this, right? Um, Basically, hired is these 20 people only, because these 20 people who are there. Hired means those are the 20 people that I have. If I have this kind of a data set, and if I have one column which says rejected or hired, I can build. So I have one column which says rejected or hired. Now tell me, is this a classification problem or a regression problem? If let's say this, and I can build a classification algorithm, I can take this new data that is available of 10K, run it through the classification model. Let's say I can use logistic regression model or decision tree classifier or random forest classifier or any of the classifiers. I can pass this new data set through it, and I can predict who is likely to be hired. Out of this, identify the people who are likely to be hired and interview those people. Make sense? Yeah, that's essentially one way of solving this problem. You can solve this as a supervised learning problem. That is if I assume that uh, a data set is available for me which looks like this, which gives me information about who has been hired and who have been rejected. On the other hand, we can also solve this problem in a slightly different way. We can solve this problem as an unsupervised learning problem. How do you solve it as an unsupervised learning problem? The way you can solve this as an unsupervised learning problem is if assuming that you do not have this data. Let's assume that you don't have this data available with you. All that you have is you have the information of these 20 people and you have the 10,000 people with you, 10,000 applications that you have, and both are similar data sets. So what you do is, for the 20 people data set, this is 20 people, 20 people data set, right? Keep this data as is, right? For the remaining whatever, remaining 10,000, right? For the remaining 10,000, for the 20K, you compute a mean observation, or let's forget about that for a second. Let's not worry too much about the mean. So I have the 2020 records data, which is my current data set. For the 10,000 data set, you perform clustering on this. When you perform clustering, you're going to create groups. You'll create small groups. Now identify which of these groups is closest to the existing data points by using a nearest neighbor model, compute distance. You can compute the nearest neighbor distance, the Euclidean distance, or whatever distance, and you can measure which of these groups is closest to my existing 20 data points. Out of these, select whichever one you're interested in. Let's say group 5 is the closest to these 20 data points. And if group 5 is closest to the 20 data point, then use group 5 and interview everybody in group 5. If group 1 is the closest, then use group 1 and interview people on group 1, and so on and so forth. So that's another way of solving the same problem in an unsupervised approach. This is supervised and this is unsupervised. Two different approaches to solving the same problem. Okay, these are the kind of questions that you would be asked. There would be a scenario thrown at you and you're expected to answer that particular scenario however you want. So this is what is referred to as designing a particular experiment, designing a particular solution, a data science solution. So you could be asked questions like these. I'll just repeat the unsupervised learning approach just for the benefit of everyone. So you have 20 people. So for the 20 people, I'll simplify it. So for the 20 people, you compute a mean observation. Can you can convert this whole thing into numeric data set? You compute mean experience, right? Mean skill set in Python, mean skill set in mean years of experience, or mean years of skill set in, let's say, Python or whatever. You compute a mean observation, an average observation of this particular data set, a centroid. Think of it as a centroid. You compute the centroid of your 20 data points. Similarly, perform clustering here on the right hand side. Out of these, when you perform k-means clustering, you're going to get, let's say you've identified k clusters. You will find k centroids. Out of the k centroids, find which of these k centroids is closest to the centroid on the left hand side. The closest centroid or the closest cluster is what you will use to perform further interview process, or you will take that up for the further interview, because the closest cluster is what is similar to that of your 20 existing data points. Yeah. That's another way of solving the same problem. Hope that answers your question, Manohar. Okay. Cool. Moving on. So these are the kind of problems that are generally asked in the case study section of your interview. While these are a few, so I'm going to take.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
The next is about and I think this is an important section as well. While the interviewer has all the right in the world to ask you questions, you also have good amount of questions that you'd want to ask your interviewer about. And I think the questions that you need to ask your interview are, especially on the data science side, are super critical. And I'm going to talk about that a little. The first is check about the team that you're getting into. Is it a new team or a matured team? Uh, is there enough people? So because all of you are new, so if you are getting hired into a data science team where you're expected to lead, the complete team, or you are the only one in the team, then it might be slightly tricky for you to navigate yourself through it. So just look for enough guidance. So if you have somebody to guide you through the whole process, so if it's a slightly larger team, then there's enough. Then you'll have enough time to prepare yourself before you launch, or you'll have enough time to ramp up before you actually get completely onboarded onto the you where or you'll have enough people who would have solved problems already, so they'll help you guide yourself through and navigate yourself through. Secondly, what it tells is if it's an existing team, then things are slightly more streamlined. You're not going to be given random work for data entry and things like that. So you'll be given proper data science work. A new team means you're basically like a hero for them. So everybody would give you all kinds of problems, and you're expected to solve every possible problem under the roof. Becomes slightly difficult. The third thing is, if it is an existing team, that means the manager already understands what data science is, which makes your life easier, because if the manager understands what data science is, if the lead understands what data science is, then they're not going to give you a weird problem statements where neither you have data, and they're not going to give you problems that they're not going to give you data sets and say build a model by end of the day. So they will understand the difficulties of a data scientist. So it is really important for you to know this, because in a lot of companies, a lot of data science managers are people who are not data scientists. They are people who are probably moved in from a non-technical background, or let's say people who are non-data science background into data science. And the reason that happens is because you got to fill roles, and the way you fill those roles in large organization is by moving people from within the organization. And at times you may have a manager who doesn't understand what data science is, and who's expecting you to um, solve data science problems. So there are scenarios where something like this could happen. So be aware, understand, know about the team, right? Know about what your manager has done. Do your due diligence in terms of if your manager knows enough data science or not, right? That's the first thing. Second thing is availability of data, meaning data is like oxygen for us. For a data scientist, if you don't give him data and ask him to build a model, what would you do? It's as simple as tying down two legs of a dancer and asking him to dance. I mean, you can dance with the hand, but you know how it will look like, right? So you cannot do this to a data scientist. You cannot not provide data to a data scientist and ask him to work on it. So one of the questions that you might want to ask and want to verify is, do you have access to the data? At times, the reason why this is important is because certain companies, what they do is they tell you that the data is confidential, especially banking and telecom companies. They tell you the data is really confidential and they cannot give you access to data. They'll give you some sample data and ask you to build models on it. And you know that when you build build models on sample data, models that you build may not be really great. So that could be quite challenging in itself. So availability of data could be at times slightly tricky. The third is if you're working in a consulting company, you might want to check if you will have the ability to talk to clients, actually have discussions with the clients, meaning that in a consulting company, there's a lot of loss of information, or transmission loss, as you can call it, because I don't know if you know of the game called Chinese Whisper, where a word is whispered in somebody's ear, and by the time it reaches the end of the classroom, the word completely changes its meaning. So what I mean to say is, especially when you're in the consulting environment, when you're in services environment, it is really important for a data scientist to be in the field and talk to the business stakeholders directly. It's not something that is, I mean, this opportunity is not something that is provided to freshers that often. I understand that. Freshers may not get the opportunity to directly talk to customers straight away, but being in an environment which directly operates with the customer is very, very useful. So you would want to be as close as possible to the environment, you'd want to be as close as possible to the business. You'd want to be as close as possible to um, um, not only the business, I mean, to the client themselves. If you are not given the opportunity, that's okay. At least if the team has the opportunity in general to interact with the client frequently, then that means there is a healthy conversation that is happening. That's something which is really important. So it's good to have that particular clarity for you. Third is check if your skills align. Check if the work aligns with your skills. That means, again, as I said, data scientists can have many subfields, right? Many subsections, meaning data scientists, data science in, let's say, a specific domain, data science in healthcare, data science in blah blah, and so on and so forth. So data scientists whose expertise is primarily into natural language processing, data scientists whose primary expertise is into image mining, data scientists whose primary expertise into statistics and things like that. So you have specifics at times, or at times work might demand a specific skill set from you. Like, for example, you're expected to work on only unstructured data. At times you might be expected to work on small volumes of data because you're probably working on clinical trials data and things like that. So see if your interest and if it aligns with the work, or if your skills align with the work or not. It is really important you check that, because there is a chance that people might misalign themselves to this, and you might not like the work that you do after you get into the org. But trust me, I would not suggest you to be so picky at the early stages of your career. At this point, I know half of you are like, by any data science job is good job at this time. Absolutely agreed with you. I think at this point, any data science job is a good job. But in general, I think it's important that you know what kind of a data science role you'd want to get into, rather than cursing yourself for getting into that particular role. Know your stuff before you jump into it. The most important thing again is around designations, right? So this was somebody was asking me this point earlier. You would often find different designations on job portals. You would find data analyst, business analyst, data engineer, data platform engineer, big data engineer, data architect, big data architect, and so on and so forth. All these roles have little or have very little or almost nothing to do with data science. A few, of course, do. For example, data analyst and business analyst and data consultant, data engineer. They are all people who specialize with, especially let's say data analyst. You can consider data analyst as someone who does two things. In certain companies, the name data analyst is generally used to people who do data entry, right? Who basically look at data and fill data entry. In certain companies, the word data analyst is also about someone who does some kind of dashboarding, who looks at dashboards and who performs some SQL querying and does some kind of data dashboarding and builds reports and things like that. So that person is also called as a data analyst at times. Data analyst as a terminology is generally also used to someone who performs some kind of very preliminary root cause analysis, meaning looking at logs and then trying to understand what is happening inside logs, automatically trying to monitor logs continuously and seeing what the error is and things like that. So the work that a data analyst generally does is like slightly more manual in nature. Business analyst, on the other hand, again, the term business analyst is also very similar. A lot of companies have the term business analyst. Business analyst, program manager, business analyst is also similar to data analyst. They also do similar stuff. They do some basic dashboarding, charts, presentations to customers about products and things like that. So that's what business analysts also do. Data engineers, data platform engineers, big data engineers, these are all people who are responsible for, or big data architects, data architects are people who are all responsible for moving data from one place to another place. So they are responsible for ETL, extraction, transformation, and loading, right, of data. They don't generate insights. They are the ones who bring data to you. They bring the data and they store it somewhere. They do data pipelining, moving data from one place to another place, moving data from, let's say, application systems to, let's say, enterprise data warehouse. That's what they specialize in. Big data engineers or big data architects are people who work on large volumes of data and let's say build Hadoop clusters and move data continuously into Hadoop clusters and things like that. That's essentially what a big data engineer is all about. What you and I do is called as data science. And if you're looking out for profiles, look for the term data science in the role. In most cases, it is referred to as data scientist or machine learning scientist or machine learning engineer or AI specialist and things like that. So the roles that you might want to look for is data scientist, ML engineer is not our role. I mean, is not a pure play data science role. Not a pure data science role. Data scientist is a pure data science role, or let's say AI specialist or data science specialist, or a ML machine learning specialist, and things like that. So again, different companies have different names. I think we are 90% of the cases we're looking at data scientist as the name of the profile. Right? Data scientist, junior data scientist, senior data scientist, principal data scientist, and things like that. And data science lead, data science team manager, and things like that. So for freshers, you're looking at data scientist, junior data science roles. And for people who are slightly experienced, you're looking at data science or senior data science roles. I would not suggest you to get into a senior data science role, because senior data science role expects you to have prior experience in the field of data science. So senior data science role is a very tricky role. I mean, I know most of you might already have had experience in other IT sectors, but it's not probably directly possible to move into a senior data science role or a team lead data science. It's the general movement is moving into an individual contributor role and then moving into data as a lead or as a data science lead or a data science manager. So irrespective of the amount of experience you have, I think personally it is suggested to move as a individual contributor, because you need to learn how data science works. If you move in as a manager, I don't think we will be able to gain enough respect from our team. I think you have to be hands-on as a data scientist to appreciate the work that your team does. So that's how I would suggest, and that's the general thing as well. Even in my org, I don't see people directly moving in as a manager from a completely random role. No, that's not that never happens. People who are actually eligible data scientists with good amount of experience become data science managers, or data science leads for that matter. Okay. So yeah, that's more or less it. I have a few resources for a couple of more questions that I've put down here. So feel free to look into those.
What I'll probably take from it is that you are exposed to recommendation engines, right? But you just don't know what it is. Okay. Okay, so I'll give you a couple of examples. Okay, when you go to, let's say, does everyone consume video content, right? I'm sure if you want to watch a video, right, let's say an entertainment video, you would go to platforms like YouTube, right? Or let's say if you want to watch a movie, if you want to watch a web series, you would probably go and explore platforms like Amazon Prime, Z5, Netflix. I mean, there are multiple players, right? I mean, there are multiple OTT platforms that offer you um, content, right? Premium content to watch. Have you noticed whenever you watch content, right? Whenever you watch content, let's take the example of YouTube, right? Whenever you watch content on YouTube, YouTube suggests some pieces of content to you, right? You would have something called suggested watches, right? Or you would have something probably when you watch a video, right? There'll be a video which will if your player is on autoplay, there'll be a video, right, which will play right after the video that you've sort of clicked, right, has ended, right? There'll be a new video that will come up, right? And that's also what YouTube thinks you would like to watch. Okay, so whenever you go to YouTube, or let's say any platform for that matter, right, what that platform does is that it looks at your behavior, it looks at your consumption, right? Let's say you've watched 100 videos on YouTube in the last 10 days. What YouTube would do is it would analyze the kind of content that you watched. Okay, what kind of creators do you usually watch content from? What kind of genres do you prefer watching videos of, right? What duration of videos do you generally watch, right? Do you watch long form content? Do you watch short form content? um, do you watch horror? Do you watch comedy? Do you watch English content? Do you watch Hindi content? Do you watch regional content, right? So YouTube essentially looks at all your consumption, right? All the consumption that you made in the past. Okay, and based on that, it tries to analyze, it tries to understand what do you like watching, right? It tries to build a profile for you, and it says that this person, for example X, right, is someone who uh, likes watching a particular kind of content, right? That could be as specific as comedy content from content creator X, which is within the duration range 5 minutes to 10 minutes, right, which is in Hindi or in a regional language, right? So it tries to build a profile in its head, and based on that, right, based on that, it basically does a filtering on its entire database, right? All the content that YouTube currently has published, right? It looks at it and it generates recommendations for you, right? It says that this kind of content this user X is most likely to watch, right? So why not show it to them proactively, right? So that there's good likelihood, right, that the user will end up clicking on one of those pieces of content. Because if you offer something that I want to watch, right, let's say I know that I'm someone who has come to the platform, right, to watch a particular kind of content, and if the platform is able to preempt that, if the platform is able to understand, right, that I want to watch a particular kind of content, right, without me having to go and search for it, if it just shows me all such pieces of content, then there's of course a good likelihood that I will end up clicking on some of those videos and then end up watching them. What would it lead to? It would lead to more time spent from me on the platform, right? And if I spend more time on, let's say, on YouTube has more opportunities, right, to show an ad to me, right, or to show multiple ads to me. Okay, and I'm sure all of you know, right, on platforms like YouTube, Facebook, etc., the only mode for them to earn money from users is ads, right? So if you're able to increase the time spent by users on the platform, it means that YouTube is going to generate more money out of me, right? Of course, they're not going to take money from me, but the advertisers who have who are paid for playing ads or specific pieces of content by targeting a specific kind of audience, right? Based on that, if I spend more time, you have more opportunities to show ads to me, right? And hence, you have more opportunities to generate more revenue out of me, right? Not from me, but out of me. Okay? So that's what recommendations are, right? So when these platforms, they preempt your behavior, they preempt the kind of content that you want to watch, right? And show it to you proactively as suggested content or as recommendations, right? All such pieces of content are nothing but their recommendations, and the algorithm, the engine that generates all such recommendations is called a recommendation engine. Okay, so that's what recommendation engines are, right? So when it's also a predictive algorithm, right, wherein the algorithm predicts, right, based on your past behavior, it predicts that this is what you're most likely to watch next, right, and it shows it to you in the form of recommendations, right? That's what recommendation engines are, and recommendation engines are everywhere, right? It's not just on YouTube, or it's not just on Netflix, it's not just on Amazon Prime. Of course, they're there on all of these platforms, right? You would see recommendations in all of these platforms, right? There are various ways in which you get exposed to recommendations, right? For example, if you watch a video, right, as soon as you watch a video, there's, of course, on the tab where the video was playing, there'll be some multiple suggested watches, right? And let's say if there's autoplay activated on YouTube, or let's say on Netflix, there'll be another piece of content, right, that will start showing up already. That's also a recommendation, right? That's a recommendation which is more closely connected to the content that you've already seen before, right? The most recent pieces of content that you've seen, right? But there are other kinds of recommendations as well. For example, there's a tab that you would see on Netflix, right, which says suggested watches, or which says recommendations for you, right, especially for you. And this is highly customized. Okay, this is not that it's not that what Netflix or what Amazon Prime is doing is it's trying to create segments of customers, right, and it's showing recommendations, same recommendations to a specific cohort or a specific group of customers. No, this recommendation is getting generated almost at a user level, right? So it looks at your consumption specifically, right, and it looks at all other users as well, right, who have similar consumption patterns as you. Okay, and it tries to give you suggestions out of it. All right, so that's what recommendation engines are, right? And recommendation engines, as I said, are everywhere, right? I mean, YouTube, Netflix, Amazon Prime are pieces which I'm sure most of you are most exposed to, right? That's why I gave that example. But like, there are recommendations happening on, let's say, on Facebook as well, right? So let's say Facebook is also a video viewing platform now, right? So on Facebook as well, there's recommendations. There's like when they show you that these are people who you could possibly add as friends, right? Those are also recommendations. LinkedIn is another example which Ganesh is saying, right? Amazon, of course, all of these are examples. In Amazon as well, you would see that you get suggested like this is what you're most likely to buy, right? Or of course, the Amazon will never claim, right, that this is what you're most likely to buy. They would just give that as a form of a recommendation, right? Are you looking for something like this? Okay, which is very discreet, right? It's not as direct as, let's say, just saying that this is what I am predicting that you will buy next, right? But it's sort of making it more discreet and saying that would you like to buy this, right? So all such, can you think of more platforms where recommendations would happen? I think what we've listed down so far is YouTube, Facebook, LinkedIn, all the OTT platforms. Are there any other platforms where you think recommendations are possible? I'm using an Airtel broadband, okay, which has a cap on the amount of data that I could use. Okay, let's say I have a limit of 100 GBs or 100 GB. I can only use 100 GB of data every month. Okay, now looking at the consumption pattern, right, of me. Okay, let's say if I end up using all 100 GB of my data in the first 15 days itself, and then I have to buy more booster packs, right, so that I could enhance the amount of data that I could possibly use. Then what Airtel could do is they could think of upselling another product to me, right? They could say that given you end up consuming all of your data, right, within the 15 days, within half of what your actual time frame is, right, and also you have to spend extra money to buy pocket-sized data, why don't you go for a data pack, right, which is unlimited, right? It means you're offering a superior, right? You're offering a better product to me, right? By predicting, right, what is the next best purchase out of it. That's also a prescription, right? But it's not recommendation, right? It's not essentially a recommendation. Rather, it's another algorithm. It's called propensity to buy or next best purchase, right? But it's also a way in which you use data, right, to come up with ideas of improving sales out of your for your business, right? So let's say if I was using let's say an inferior service, okay, I was of course paying a lower cost for it as well, right? And then whether I want to buy more data is my choice, right? Sometimes I do it, sometimes I don't, right? But if I go for a superior package, if I go for a superior data pack, it means that now Airtel has a fixed income from me, right? They've fixed my monthly um, cost, right? And I have to end up paying a higher cost every month. That's fixed, right? It doesn't have anything to do with the kind of consumption that I have now. Okay, so dot, or let's say when you look at an overall, let's say if you aggregate this amount over a specific time frame, you would realize that I ended up paying more money, right, for the superior service as compared to what I was doing before. Okay, so that's also a form of that's also a form of prescription, but it's not something which you would call recommendation engines, right? And it's also obvious, right, when you have the power of using data, right? Because you're collecting data, everyone knows that. If you're collecting data for a customer, why not use it, right, to improve the sales of your product, right? Improve the amount of revenue that you could possibly generate out of your customer, right? So that's essentially what all companies are doing. Okay. um, so today what happens is every customer is essentially facing multiple choices, right? You have, let's say, in anything that you want to buy, right, you will have multiple choices, right? You could go to several places to buy that item. You would have multiple models to choose from, right? um, let's take an example of a book, right? For example, if I'm interested in let's say reading a book, okay, I'm looking for a book to read without, let's say, any specific idea of what I want to read, right? Then of course there's a wide range of possibilities on how my search might pan out, right? Let's say I go to Google and I say, right, what are the best books to read? Okay, I could get some suggestions from Google, but they're not very well customized to me, right? Google doesn't know what exactly is running in my mind, right? When I say I want to when I say I want to read a book, okay, Google would of course give me a suggestion in the sense that what is it that most users find interesting, right? But it doesn't know that whether I would definitely like that book or not, right? So what could happen is I might waste a lot of time, let's say, browsing around the internet and maybe crawling across different websites, right? uh, just hoping to find a good book, right? But let's assume, what if there was a site, right? Let's say, what if there's a website, right, which could recommend me books, right, based on what I have read previously. Okay, that would be a massive help, right? If the algorithm is able to predict, right, it basically reduces choices for me, right? When I have multiple choices and I'm not very sure of what I want to do, right, um, it's a lot of wastage of time. In return, if, let's say, if the platform is able to suggest ideas, right, if it's able to say that probably this is what you might want to read, there's a very good likelihood that I would end up reading one of them, right? Goodreads is, by the way, a platform, right, which does this, right? Goodreads is a platform where you could go and rent books, you can read books, right? And then based on what you've read before, read before, it gives you suggestions, right, that this is what you might find interesting, this is what you might like to read next. Okay, so that becomes a massive help, right? Of course, I'm sure all of you agree with that. It, of course, is useful for the customer, right? Because the customer, it's a better experience for the customer, right? Rather than, let's say, searching for things, right? Let's say looking out, wasting a lot of time to read a book or watch a piece of content. You get it as a recommendation in front of you, right? So that's of course a better customer experience, and also it ends up making sure that you're spending more time on that platform. if recommendations didn't exist, right, your YouTube session might end after a couple of videos, right, that you intended to watch when you logged into YouTube. Okay, let's say you wanted to watch a comedy show, right, a comedy video. You went to YouTube, you watched that video. If you do not have any recommendations, most likely you will just log out and probably continue what you were doing before. But if you see recommendations there, right, if you see more suggestions, right, which of course are similar to what you wanted to watch already, then you might end up, there's a good likelihood that you will end up watching some of those pieces of content, and it will increase the amount of time spent for you, right? So for the organization as well, it's a win-win situation. Okay, so that's what recommendation engines are essentially, right? In the grander scheme of things, that's how recommendation engines work, right? They are intended to provide a better customer experience for you. It's intended to essentially make sure that the business is getting more profitability out of you. Okay, so what recommendation engine is, it's a data filtering tool that makes use of algorithms and data to recommend the most relevant items for a particular use, right? It's essentially you could say it's a replacement of or an automated way or form of a shop counter guide, right? When you would, let's say 15 years back, if you wanted to buy a TV, right, you would go to a store, right, and you would tell this guy, right, whoever is attending, that what is the kind of TV that you're looking to buy. Okay, and based on that, what they would do is they would basically apply filter on all the inventory that they have and suggest, right, let's say you tell them that this is my budget. I want to only buy a TV from a particular brand, let's say Sony, right? I also want to buy a speaker along with it, right? So what the shop counter guy would do in that case is, if he or she will apply those filters and then present you options. The same thing is happening here as well, right? I mean, instead of you telling the product, right, let's say YouTube, that what you want to watch or what you've come to watch, it preempts that, right? Of course, you don't need to do that because YouTube has all your data, right? All OTT platforms have all your data, so they know what you want to watch or what you want to do, right? And based on that, they generate recommendations for you. Okay, now I hope all of you now have a decent idea of what recommendation engines are, right? And I'm sure all of you would be able to relate to it, right? I'm sure all of you have had some exposure or some experience of being exposed to recommendation engines. Is there anyone who still doesn't understand what recommendation? Of course, you might not know how these recommendations are generated exactly, right? But does everyone understand the funda, right? What this whole concept is all about? Okay, very good. Cool. So what are the different types of recommendation engines then, right? What are the various ways in which you could generate recommendations? There are 3 of them. Okay, there are 3 types of discrete recommendation engines, right, that you could possibly build. The first one is called collaborative filtering. Okay. Collaborative filtering, what happens is the recommendations that you see are generated based on the similarity between user preferences. Okay, so to give you some idea on how this happens, let's say I am someone, right, who let's say I go to let's stick to the same example, right? YouTube. Okay, I go to YouTube, I watch some content, right? What YouTube will do is it will look at my data for a specific time frame. It will most likely consider more recent data because that, of course, the tastes of users, the moods of users keeps changing. So it will look at more recent data from me, let's say the last 28 days, last 30 days, and it will try to come up with a profile of me, right? What is this user's profile? What kind of content does he start like watching, right? And then what it would also do is that it will try to find similar users like me. Okay, users, right? Let's say in this batch of people who are listening to me, who are all of those people who have similar preferences like me, right? Who like to watch similar content as me. Okay, let's say out of 50 of you or out of 100 of you who are here in the session, there are 5 people, okay, who have very similar tastes as me, right? So very similar preferences like me. What the algorithm will do now is that it will list all the pieces of content that you guys have seen and liked, Okay, and it will see what out of all of these pieces of content, what is it that I haven't seen yet. Okay, and such content pieces or such pieces, such videos will be shown as recommendations to me. Right. So in this case, what the recommendation engine is doing is it's looking at my consumption, right, and it's looking at my preferences, right, and based on those preferences, it is trying to find lookalike users, lookalike people, right, who have similar preferences as me, right, and then the videos or the content that other similar users have seen, but I haven't seen yet, right, such pieces of content will be shown as recommendations to me. Okay, that's what collaborative filtering is all about. Okay, the second kind of recommendation engine, right, is called content based filtering. Okay, in content based filtering, what happens is the algorithm recommends products, right, or when I say products, I would also I mean content, right, in the case of YouTube, right, the algorithm will recommend products or content which is similar to the one that I have liked or watched before. Okay, let's say I have seen I like to see a lot of comedy content, for example, right? In that case, and this also special, like in most algorithms, you would have both kinds of algorithms fit in, right? In most recommendation engines, you would not just use collaborative filtering or you would not just use content-based filtering, rather it would be a combination. Okay, so but content-based filtering is when, for example, I watch a comedy video, right? I watch a comedy video, right, from a particular creator. Now the algorithm will say that this guy likes to watch this content in this genre, right? So what the algorithm will now do is it will try to find similar videos or similar content in similar genre from similar creators from with similar let's say titles, etc. Right? That's what content based filtering is, right? So in this case, you're not really looking at user preferences. Okay, rather you're just looking at, okay, that's what content based filtering is. The last kind of recommendation engines, right, that you would see is a hybrid recommendation engine. When I say hybrid recommendation engine, it's essentially nothing but a combination of both of them, right? So where for certain kinds of, and like let's say hybrid recommendation engine is a combination of both collaborative filtering and content based filtering. Okay, in some cases you might use collaborative filtering. In some surfaces you might use content based filtering. For example, in YouTube, right, in YouTube itself, where do you think you would use content based filtering and where do you think you would use collaborative filtering, right? There are different kinds of recommendations that you see on the platform, by the way. When you watch a video, right, and all the videos that show up as suggestions to the same video, right, let's say on the video tab itself, on the tab where the video was playing, as soon as the video ends, right, there's a bunch of videos which will show up as recommendations to you, right? Those pieces of content are generally generated through content based filtering, right? Those are your immediate, they are very closely related to your immediate watches, right? The things that you've watched immediately, very recently, right? They have a close connection to the videos that you've seen very recently, and those pieces of content will show up as recommendations for you. That's content based filtering, and that's mostly on the same tab, right? Or you would say a chaining, when YouTube wants to generate a chain of videos or chain of consumption, a chaining consumption from you, right, in similar genre, in similar space. That's what content based filtering is. Collaborative filtering is when you as soon as you go on YouTube, right, you would see a bunch of suggestions, right? They are not very linked to, let's say, that your immediate consumption, but in general the algorithm has created a profile for you, and it has, based on that profile, it has come up with suggestions for you, right? On your feed you would see a lot of suggestions, right? From, it could be from people who you follow, it could be people whom you do not follow, right? All such pieces of content are generally generated from collaborative filtering, right? So you, in most cases, hybrid recommendation engines is what you would use. In most mature surfaces, in most mature organizations, you would use hybrid recommendation engines where you're using both collaborative filtering and content based filtering, right? Yeah, so that's how it happens. Okay, in this course, right, in today's session, we are going to focus more on collaborative filtering, right? Within collaborative filtering as well, there are the couple of couple of different ways in which you could use collaborative filtering. So that's what we're going to focus on. We're not going to focus so much on the content-based filtering and hybrid recommendation engines. Okay, so now what happens in collaborative filtering, right? What are the different types of collaborative filtering algorithms that you have? Okay, there are two of them. Okay, there's user-based collaborative filtering. Okay, and then there's item-based collaborative filtering. This one is called UBCF, user-based collaborative filtering, and the second one is called item-based collaborative filtering. Okay, both of them work in a slightly different manner. Okay, in both cases, of course, you look at the preferences of customers, you look at the consumption behavior of customers, right? But how you consume it and how you convert it into an output is slightly different. Okay, so what happens in case of user-based collaborative filtering, right? The first algorithm is that what the algorithm would do is that it will identify similar users based on similar user preferences. Okay, and then recommend new items to a user, to an active user, based on the rating given by similar users on the items which are not rated by the active user. Okay, so user-based collaborative filtering, what happens is you look at overlap, okay, between consumption of different users. Let's say I am someone who has watched 10 videos, right? You will look at all other users that you have in your database, and you will try to find users who have watched, who have a very good overlap with the kind of content that I have watched, right? Let's say there are 10 other users who have seen 8 or 9 out of the 10 pieces of content that I have also seen. It means it's just a way to establish that these users have similar consumption like me, right? They have similar preferences, they have similar consumption behavior like me. Now all the pieces of content, right, that these similar users have seen but I haven't seen yet, okay, those pieces of content will be shown as recommendations to me. Okay, that's how user-based collaborative filtering works. Okay, maybe I'll probably take another example here. Okay, let's say there's a user. Okay, there's a user. There's a user A. There's a person A. Okay, this person A, let's say, has seen and liked 3 movies. Okay, there's 3 movies that this person has liked. First one is let's say Interstellar. Okay, Interstellar. Okay, I'm just going to write INS, Interstellar. The second movie that this person has seen and liked is, let's say, Inception. Okay, mostly sci-fi movies. Okay, Inception. Inception is not sci-fi, sorry. Yeah, and the third movie, let's say this person has liked and watched, is Predestination. Okay, the 3 pieces of content, like, and these pieces of content are not very closely, let's say, connected to each other, right? Let's say this is user A, he has watched these 3 movies, and then you have another user which is B, right? Let's say this user has seen, he's also seen 3 movies. Let's say the first one that he's seen is let's say.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Let's say Inception. Okay, he's also seen Inception. The second user, let's say they've seen Predestination. Okay, Predestination. And then the third movie that they've seen and liked. By the way, when I say seen, I mean they've also liked that movie, right? There's also, you look at the ratings that the users have given to the movies that they've watched, right? It's not just based on consumption, it's based on behavioral aspects, right? Like whether you actually showed signals of enjoying that movie or not. Okay, sometimes it might just be visible in the form of the rating that you have given to that movie, right? Sometimes the algorithm might generate signals to identify whether you like that movie or not. Okay, but the point is that you liked these 3 movies. User A likes these 3 movies. User B likes, let's say, Inception, Predestination, and let's say Prestige. Okay, a third movie, Prestige, which, so basically because between these 2 users, right, there are 2 movies that are common, right? So Inception, user A has also watched Inception, user B has also watched and like Inception. User A has watched and liked Predestination, user B has also watched and liked Predestination. right? So basically what you're trying to establish with this is that these two users are similar users. They have very high similarity between their preferences, right? They watch similar kind of content. Okay, so you've established that these are similar users. Now, because these are similar users, what you can do is this guy, right, because he is similar to B, right, and he has not watched Prestige yet, which user B has watched and enjoyed, right, this movie will show up as a recommendation to this guy. Okay, and this movie, which is Interstellar, right, which user A has enjoyed but B hasn't seen yet, this will show as a recommendation to user number B. Okay, that's how user-based collaborative filtering works. Okay, so the first of all, what you have to do is you have to establish that the users have similar preferences. Once you have done that, all such pieces of content that the similar users have watched and liked, right, those pieces of content can show up as recommendations to the first user, to the active user. Okay, that's what user-based collaborative filtering is. And the second kind of collaborative filtering approach is item-based collaborative filtering. Okay, item-based collaborative filtering. In the case of item-based collaborative filtering, what happens is you try to calculate the item similarity based on the item preferences. Okay, and then you find top similar items to have been non-rated item, like to the non-rated items by the active user and recommended. Okay, your item-based collaborative filtering is very similar to association rule mining. Okay, let's say there are two users. Okay, user A and user B. User A has bought, let's say user A buys two products, right? Two or three products frequently in their transactions, right? User B buys three products frequently in their transactions. User C buys three products frequently in their transactions, right? So if you want to identify what are those products, right, that are frequently bought by customers, right, in their transactions, right? And let's say if one user, right, I am a user, I have bought two out of those three products in my transaction, but I have not bought the third one, right? But a lot of customers, in a lot of transactions, you see when someone buys those two products, right, the third product is also present, right? Which means they have a very close association between each other. The third product, which has a close association with the second product or with the first product or both the products, that product will be shown as a recommendation to me. Okay, so item-based collaborative filtering is also looking at user preferences, right? How do you look at user preferences? Because you're looking at co-occurrence, right, of items in the same transaction or in the same session, correct? Which means that like there's a lot of users who prefer watching or prefer let's say buying these two items together, right? Based on that learning, you would establish that these are the set of items that have tendency of frequently being bought together, right? Frequently being purchased together, right? These are common items. These are items which have very high correlation between each other, right? And then if you, let's say, bought one out of those two products, right, the second product can be shown as a recommendation to you, right, which has close correlation with it. So that's what happens in item-based collaborative filtering, right? It is different from the item the item collaborative filtering, or so the content-based filtering that we saw in the first case, right? It's different from that because there you look at the content metadata, but here you look at the preferences of users itself, and based on that, right, you suggest items, right, which have very high likelihood of being bought together. Okay, so you have user-based collaborative filtering and you have item-based collaborative filtering. We will look at both, right? We will look at both the concepts and understand how you would implement, let's say, an item-based collaborative filtering or a user-based collaborative filtering in R. Okay, before we move on to the implementation, I think it's important to understand how this whole algorithm works, right? Like what kind of data do you need, or what are those metrics, right? What are some of those parameters on which, let's say, user-based collaborative filtering is getting optimized, or item-based collaborative filtering is getting optimized. Let's just probably look at a couple of examples, right? Let's just do a deep dive on both these algorithms, user-based collaborative filtering and item-based collaborative filtering, and then once we have very good clarity in terms of how these two algorithms are structured, that's when we can move into the implementation of both the algorithms. Okay, so let's do a deep dive on both these algorithms, right? User-based collaborative filtering and item-based collaborative filtering, and see how they're actually getting calculated, right? How they're actually getting structured. Okay. So a very like a similar example to the movies example that I gave you, right? Let's say there's this user, okay, user A. Okay, let's say there's user A, and then there's user B, right? User B has bought pizza, right? User B has bought salad, and user B has also bought, let's say, a can of soda. Right? User A has bought a pizza, right? User B has bought a salad, right? Which means these two users, because they have a good level of overlap between the kind of products that they buy, right? Both of them have bought pizza, both of them have bought salad, right? So you've established that these two users have similar users, right? So you found out that these two users have similar preferences in the sense that the kind of product that they buy. So product soda, which user B has bought, right, but user A has not bought in his transactions, you could show that product as a recommendation to user A. That's how user-based collaborative filtering works, right? So you try to find similarity between users, right, and based on the similarity index, right, find more similar users and the content that the similar users have liked, right, and bought. Those products will be shown as recommendations to the other user. Okay, and like, see, this is a very simple example, right? It's sort of trying to break down this problem into a very, very simplistic manner, but in reality, you should realize that, let's say, if this is a user, right? If this guy on the cycle is a user, there will be several users, right, who would be found similar to them, right? There'll not be just one user, right, who would have similarity to this guy. There'll be, because let's say you're sort of crawling into a database which has millions of customers, right? If you go to YouTube has, even if I limit myself to, let's say, India, a region, right? I'm sure YouTube would have anything close to 500 million users, right, who are active on the platform every month. Okay, so if I look at this user, I'm sure I will find thousands of users, right, who have similar tastes, similar preferences as this user, right? So how do you decide which are those videos or which are those products that you would show as recommendation to this user? Okay, it is evaluated based on the similarity index, right? You would try to find out the most similar users, right? Who are those users who have very high similarity, very high correlation between the user in consideration, and then the content that those users have watched and liked, right, will become the top recommendations for this user, right? Because you've identified that these users have very, very similar taste, right? They're almost identical users. Okay, so that's how your user-based collaborative filtering would work in this practical scenario. Okay, let's understand the math behind how the predictions get generated. Okay, I'll also show you an example which will make this even clearer. But this is the function. This is how you would generate the predictions, right? For, let's say, a user U, right, to buy an item I, right? Or let's say if item I should be shown as a recommendation to user U or not. Okay, so what would happen, right? You would generate a prediction, right, of whether this item should be shown to user U as a recommendation or not. So you, for every such product user combination, you would generate a prediction score. Okay, you would generate a prediction score. How would you generate that prediction score? That prediction score is generated based on the summation of the sum product of the rating that a user V, right, as another user, as a different user V, has given to the item I, okay, multiplied by the similarity between user U and user V, right? The similarity index of user U and user V, okay, divided by the similarity between user U and user V. Okay, so in this case, there'll be many such V's here, right? I mean, V is just an example. This V will move from 1 to 100,000, right? If you have 100,000 customers in your database, right? with each customer with each customer, right, except you, right, and each item that other customers have, let's say, bought or consumed, this equation would run, right? So it's a summation, sum product of the rating that other user V, right, and a different user V has given to the item I, okay, multiplied by the similarity between the user and between the user U, which is the user in consideration, this user for who you are generating a recommendation, and another user V, divided by the similarity between user U and user V. As you could realize from this, right, items which have very high rating, okay, which have high rating from users who have very high similarity to user U will have high chances or will have very high prediction of being shown as recommendation to the user U. Okay, so it does not just depend on similarity, it also takes into consideration the rating. And rating is, in some cases, as I said, rating could be sometimes generated as an input by the user, right? A user can rate a movie. Okay, sometimes you might have to look for signals from the data, right, to identify whether this user actually liked or actually enjoyed watching that video or not, right? So in that case, how would you do that, right? Let's say you do not have the rating, you would generate a rating, right? You would predict a rating. It would basically be a combination of, um, let's say if you're generating a rating for a video, you would see whether the user reacted to that video, right? Whether the user liked that video or whether that user commented on that video. It's generally a signal of user actually liking that video, right? Being involved in that video. If the user watched the entire video at one go, right, which means they had a very high retention on that video. That's also a way to identify that the user liked the video. If the user uh, watched that video multiple times, right, that's an indication of that user being like really liking that video, right? And then there could be other signals. There could be many other signals as well, right? Users searching for that video and then watching that video, right? User liking and watching a lot of pieces of content from the same creator, right? So all those are signals to identify that, to come up with a prediction for a rating, in case the rating is not already provided, right? But generally, you would have ratings available, right? Netflix, in most cases, you would have ratings. Like when you watch a content, right, you would also probably give a rating for that movie that you watched. Okay, so this is how the prediction algorithm works, right? This is how the prediction is generated. I think it's important for us to identify now how would you calculate similarity between users, right? I think what we've covered is the prediction, right? Rating is something which is straightforward, but how do you identify the similarity between users, right? What is the formula to do that is something that we should understand now. Okay, so let's come to that. For that, I think I'm going to show you a very simple example, right? And by the way, this also will give you an idea in terms of how the data gets structured, right? When you're building a recommendation engine. Okay, this is how you would have to, let's say, structure your data as well, right? When you're building a recommendation engine, you will have to build a matrix, right? A matrix sort of a structure. Okay, a matrix sort of a structure. Okay, where let's say you want to generate recommendations of movies to different users, right? You will have to have a matrix like this, right? Where you have in rows different users, right? Each user is one row of data, right? Each observation is one user, right? So this is user A, this is user B, this is user C, right? And each column, okay, is basically the rating that the user has given to the movies, right? So in this case, what we are saying is we have a movie rating matrix, right? So X1, X2, X3, X4, X5 are different movies, right? Right, which are available on a platform, right? And then you're based on the consumption or based on the ratings that the users have given to these movies, you're trying to find out whether these users are similar users or not. Okay, so whenever you have to do that, whenever you have to build a recommendation engine, you will have to create a structure like this. You'll have to make sure your data is structured in this way, where you have in rows different observations or different users, right? And in columns different movies that they may have or may not have rated in the past, right? Here you are going ahead with an assumption that if someone has not rated a movie, they haven't watched that movie yet. Okay, so for example, user A, they have watched a movie 4. Sorry, they've watched the movie X1 and the rating that they've given to the movie is 4. Okay, this rating is out of 5. Okay, this rating is out of 5. Okay, so user A has watched movie X1 and they've rated that as 4. User A has watched movie X2, they've rated it as 1. A has not watched X3, so X3 is not watched yet. They've watched X4 and they've given a high rating 4 to it, right? And user A has not watched movie 5 yet. Okay, similarly, B has not watched 1 and 3, but they have watched 2, 4, and 5. User C has not watched 1 and 3, but they have watched 2, 4, and 5. Okay. Now, given this data, right, how can you generate similarity between users? How can you find out if there are similar users or not? That is based on this formula that you see before. Okay, this formula. I will also break down the formula for you. But how you do this? How you calculate the similarity? Let's say if you want to find out similarity, okay, you want to generate recommendations for this user, right? Let's say this is the user who you want to generate recommendations for. So what you will do is you will find its similarity to user A, right, and its similarity to user B, right? Whichever user has higher similarity to it, right, the content that they have liked or they have rated as high, okay, will show up as recommendations to users. Okay, so for that, what you'll have to do is you'll have to find similarity between user A and user C and similarity between user B and user C. This is how you would find out similarity between users. Okay, similarity between users. What would you do is that first of all, for each user, okay, each user, you will find out their mean user rating. Okay, the mean user rating, which means what is the average rating that they've given to all the movies that they have rated in the past. Why is this mean user rating important? This mean user rating is important because rating, right, rating, or let's say the rank that you provide, rating that you give to a movie is a very subjective matter. Okay, for example, for someone like me, right, if I am a very strict rater, right, then for me, let's say if I absolutely enjoyed a movie, right, that's when I might give a rating 5, or let's say that's when I might give a rating 4 to a movie, right? A movie that let's say I didn't like much, right, but I found it at average, I might just give a rating 2 to it. Okay, but there's another user, let's say for example, if they absolutely enjoy a movie, they will give that movie a rating 5, right? But if they found it average, they will give that movie a rating 3. So this is a lenient user, this is a strict user, right? This is a lenient rater, this is a strict rater, right? But you don't you cannot really take care of the leniency and the strictness here, right? You will have to generate a normalized metric. So for that, what you do is you look at what is their average user rating, right? What is that average that they provide to every movie that they rate, and then anything which is higher than the average is considered likable. Anything that is lower than the average is considered non-likable, right? So you're trying to remove that subjectivity here, right, of what for a user what is good and what is bad, right? For someone, let's say 4 can be bad, right, and only 5 can be good, right? For another user, 4 can be absolute gold, right, and 1 can be bad, right? So because there are different kind of people, they have different ways of rating, right? You have to have a mean user rating which sort of normalizes for their preferences, for the kind of rater they are. Okay, so that's why this is important. Okay, so how will you calculate how will you calculate similarity between users, right? It will be based on this formula, right? So let's say if you want to find out similarity between user A and user B, right, you would first of all look at the kind of movies that they have common between each other, right? So in this case, user A and user C have movie number 2 and movie number 4 common, right? They watched 2 and they watched 4, both of them, right? So what you would do is this is how you'll calculate. Okay, so you'll do the rating that A has given to movie 2 minus the mean user rating, okay, 1 minus 3, multiplied by the rating that user C has given to the movie, okay, x2, and multiplied by the mean user rating, right? So 1 minus 3 multiplied by 1 minus 3 plus 4, right, the rating that the user A has given to movie number 4 minus the mean user rating 4 minus 3 multiplied by the rating that user C has given to movie number 4 minus 3, okay, that becomes your numerator, right, divided by the squared distances, right, which is 1 minus 3, okay, 1 minus 3 whole square plus 4 minus 3 whole square of user A, the square root of that, plus 1 minus 3 whole square plus 4 minus 3 whole square and the square root of that. Okay, so what's the formula here? The formula is nothing but, let's say, the summation of the rating, okay, the rating that user A has given, right, to a movie, and then this movie is I, right, and I will go from 1 to whatever, right, to whatever movies that you watched, right, and let's say there are n movies that you watched, right. Okay, so rating that user A has given to movie 1, right, multiplied by their mean user rating, R bar, same thing by, actually this is how it is, right. So this is RA, okay, of I minus R bar multiplied by uh, rating B, right, to the movie minus RB bar, okay, divided by square root of the summation of RAI minus RB bar. So this is the formula, right? This is how you would sort of generate these recommendations. That's also, this formula, by the way, is essentially the same formula that you have for correlation. Right? This is a way of finding out correlation between different users, right? This rating that you see, right? This R8C, or the similarity between users that you find here, is nothing but, it's a term which is between -1 and +1. Okay, -1. If it is -1, it means that these two users have absolutely opposite tastes, right? And if this similarity is 1, it means that these users have exactly similar taste, right? So identical taste versus opposite taste, and anything between 0 and 1 is considered some level of similarity, okay, and anything between 0 and -1 is considered some level of dissimilarity, right? You are trying to find users who have similar taste, right, who have very similar taste, right? So if RAC is high, if RAC is closer to 1 tending to 1, right, that would mean a better thing for your predictions, right? In this case, because user A and user C have like the common movies between them, they've given the absolute same rating to both of them, right? And hence their similarity comes out to be 1. Okay, when I do the same thing, when I calculate this formula for user B, instead user B and user C, that there are although they have 3 pieces of content that they have watched, okay, the rating that they've given to those movies is very different, right? So 4 minus 3 multiplied by 1 minus 3, plus 2 minus 3 multiplied by 4 minus 3, plus 3 minus 3 multiplied by 4 minus 3, okay, divided by 4 minus 3 whole square plus 2 minus 3 whole square plus 3 minus 3 whole square root of that, multiplied by 1 minus 3 whole square plus 4 minus 3 whole square plus 4 minus 3 whole square, and square root of that, right? So the similarity between user A and user C comes out to be 1, and the similarity between user B and user C comes out to be minus 0.86, right? Which means user B and C are highly dissimilar users, right? Their similarity is actually opposite. It means that they have actually opposite taste to each other, right? Because this number is very close to -1. Okay, so it means their tastes are absolutely different, right? Although they might have a more overlap between the content that they watch, but whatever they watched, right? One user likes that movie, the other user absolutely hates, right? So they have their taste is absolutely, their tastes are actually opposite, right? This user has very similar taste as user number C, right? So what content, the content that user A, right, because it's a very similar user, right, has seen and has given a high rating, which is movie number 1, will be shown as a recommendation to user number C, right? Because this movie has been liked by user number A, who is a very similar user as user number C. That's how your user-based collaborative filtering is. Okay, it's based on the similarity between users, which is nothing but the same formula that you would use for correlation, right? Multiply the similarity, use that similarity in combination with the rating of the product, to generate the prediction, which is coming from this formula. Okay, so this is how you would generate predictions for different items from different users, right? All users who have very high similarity will of course have high chances of their liked pieces of content showing up as predictions, right? For users. Okay, Arshad is asking if user always rates same, let's say 3 consistently, do we consider that user in the analysis? We do consider that user in the analysis, Arshad, right? I mean, we do not really ignore any users, right? If the user has always the same rating, it could also mean, right? It could also mean that the user is like, you can just show anything to them, right? They will just end up watching that, and they will not have either a positive review or negative review, right? So you don't really remove any users, right? It's like, why would you just remove someone, right? You will have to generate recommendations for them as well. Okay, so irrespective of what rating they give, right, you will have to consider, of course. Now, if you're saying that if the user always gives the same rating, it could mean that it's a bot, right? If you're saying that, like, you want to eliminate bots out of data, right, eliminate noisy data, then of course, yeah, that makes sense, right? If you want to make sure that your data set is as clean as possible, right? So if you want to eliminate, if this is one of the ways through which you want to eliminate, right, some of the noisy data, right, data which is not user entered, rather it's bots sort of entering the same rating for every movie, right? And it happens, right? It's not a rarity, right? I mean, there are platforms generally apply bots, right, so that they could increase the number of ratings to their content, right? And of course, something which has been reviewed, which has been rated more, is more likely to be purchased, right? Because there's a certain level of reliability that the user feels, right, on watching or buying that content, right? So I understand if that's what you meant, right, which is to eliminate bots, right, to eliminate let's say fraudulent activity, right? That we can, right, we can remove all users who absolutely have no taste, right? They give the same rating, which is actually an identifier of that user being a bot. Yeah, that's right. So there could be more filtering criteria, right? That's essentially a form for you to clean up your data, right? So that your data is closely representing a real life scenario, right? That it's not heavily biased on like what data which is fraudulent. So yeah, it's if you yeah, data cleaning it's something which we would do essentially before this step, right? But in this step, whatever is clarified as qualified will basically be considered in the ratings. All right, so that's recommendation. That's the user-based collaborative filtering, right? Item-based collaborative filtering works very similar to user-based collaborative filtering, right? So if you understand how user-based collaborative filtering is, it's the same formula that is basically getting applied here. It's just that instead of finding similarity between users, right, what you would do is you would find similarity between items, right? So for example, if there's user A, okay, I should change my pen. Yeah, if there's user A, right, user A, user B, and user C, let's one, user 1, user 2, user 3. If user 1 in the same transaction has bought orange, right, they bought an apple and they bought a banana, okay. Why am I even doing that? It's already like the arrows are already there. Why am I still sort of using my pen there? Anyway, so user 1 has bought in the transaction an orange, okay, an apple and a banana, okay. User 2 has bought, it's an orange, and they bought a apple in the same transaction, right? But user number 3, right? So basically, from let's say from these two transactions, what you've identified is that orange and apple are two products that are generally bought together, right? Someone who buys orange also buys apple in the same transaction. Someone who buys apple also tends to buy orange in the same transaction, and that is being seen in 67% of the data. Assume there are only 3 customers in your database, right? And of course, it doesn't mean that you would have 3 customers. You would have millions of customers, right? You extrapolate the same percentages in your data set, right? So let's say if this is observed in 67% of the cases, two out of 3 cases, every 3 cases, which is in every 2 out of 3 cases, when an orange is purchased, right, an apple is also purchased along with it, right? So what you can do is for user number 3, who has bought an apple, right, but has not bought an orange, because you know that orange and apple are products that are generally bought together, right? They are very similar products, right, in the sense that based on the user preferences, okay, you will show this product as a recommendation to user number 3, right, because they've bought a product which is frequently bought with orange. Okay, that's how your item based collaborative filtering works, and it's exactly the same as association rule mining, isn't it? right? You can use the concept of support, confidence, and lift to identify what are those products that get a very high lift, right, in their purchase when they're combined with other products, right? And anything which has a lift greater than 1 can be shown as recommendation to users, right, whenever they purchase the antecedent product. Okay, and then the consequent can be shown as a recommendation to them. Okay, so that's exactly what happens in the case of item-based collaborative filtering, right? You make use of association rule mining. You make use of similarity between user preferences in the sense that in the context of the kind of product that they've purchased, right, and products that are frequently bought together and are not present in many of the customers' basket, right? If they bought only one out of those two products, then the second product will be shown as a recommendation. Okay, that's how item-based collaborative filtering works. If we use the same formula, right, to identify similarity between users. By the way, the formula that's used in the case of item-based collaborative filtering and user-based collaborative filtering, they're mostly similar. Okay, they're mostly similar. It's just that the way you have to sort of aggregate your data, the way you sort of structure your data is slightly different. That's all. Okay. So let's look at how would you do that, right? How would you do item-based collaborative filtering? Let's say if you have the same database where you have movies from a user, right, and where you have the ratings, right, that the different users have given to different movies that they watched. Okay, so yeah, so if let's say if that's what we have available. Okay, 1 second. Okay, let's say this is the matrix that we are working with. Okay, we have in our rows we have different users, right, and in our columns we have different movies that these users have seen, right? These users have seen and rated. Okay, so you have user A, user B, user C, right? And you have movie 1, movie 2, movie 3, movie 4, movie 5. Okay. Now, in case of user-based collaborative filtering, what did we do, right? We found similarity between users, right? User A, whether it's similar to user B or not. User B, whether it's similar to user C or not. That's what we did, isn't it? Okay, we're not going to look at similarity between users because that's not relevant to us. We're rather going to look at similarity between items. Okay, so if you want to say that what are which items have very similar, are being let's say frequently watched together, right? Whether it's movie 1 and movie 2, whether it's movie 1 and movie 3, whether it's movie 1 and movie 4, whether it's movie 5 and movie 1, right? So in that case, what you will do is you will find similarity between pieces of content. Okay, so in this case, what you have to find out is, let's say if someone has watched movie 1 already, right, what is that other movie that I can show him or her as a recommendation? Okay, let's say if you find out that movie 1 has a very high similarity as compared with movie 2, right, then anyone who has watched movie 1 will be shown movie 2 as a recommendation. Okay, so you use item similarity between item preferences as compared to user preferences in this case. Okay, to generate your recommendations. How would you do that? How would you generate the recommendations? Or sorry, how would you generate similarity between items? Is based on the same formula. It's the exact same formula. It's just that instead of looking at similarity between users, you're looking at similarity between movies, right? Let's say if you want to find out whether movie 1 and movie 4 are similar movies or not, what would you do is you would look at all the users, right? All the users who have watched both the movies, right? Let's say this is user A who has watched movie 1 and movie 4, and user B who has watched movie 1 and movie 4, right? So what you would do is and for each product, for each item, you will also calculate the mean item rating, right? For every, based on the different ratings that the users have given to different movies, you will calculate the mean item rating, right? So for calculating the similarity between movie 1 and movie 4, what you would do is 4 minus 3, which is the rating that user A has given to movie 1, minus 3, which is the mean item rating, okay, multiplied by 4, the rating that user A has given to movie 4, minus the mean user rating, plus 2, which is the rating that user B has given to movie 1. Okay, so 2 minus 3 multiplied by 2 minus 3, okay, divided by 4 minus 3 whole square, plus 2 minus 3 whole square, multiplied by 4 minus 3 whole square, okay, plus 2 minus 3 whole square, right? That comes out to be 1, right? Because all the users who have watched both these pieces of content, they've given absolutely the same rating for those movies. Okay, so these movies have very similar. They have very high similarity between them, right? They're almost identical movies in the sense, you can say, based on the ratings. So anyone who has watched movie 1, right, and has also given a high rating to it, right, can be shown movie 4 as the recommendation. Okay. Now we will also find out the similarity between movie 1 and movie 4. So movie 1 and movie 5, just to see whether the same thing holds true here as well. So between movie 1 and movie 5, right, this and this is what we're looking at. Okay, who are the users that have watched both movies? So it's the same users, right? User A and user B who have watched both the movies, right? 4 minus 3, right, multiplied by 4 minus 3, okay, plus 2 minus 3 multiplied by 1 minus 3. In this case, B has given a rating 1 to movie 5, right? But user A had given a rating 4 to the same movie. Okay, so 4 minus 3, okay, multiplied by 4 minus 3 plus 2 minus 3, okay, multiplied by 1 minus 3, okay, divided by 4 minus 3 whole square plus 2 minus 3 whole square multiplied by 4 minus 3 whole square plus 2 minus 3 whole plus 1 minus 3 whole square, right? That number comes out to be 0.94. Of course, 0.94 isn't a bad score. 0.94 is also a good score. But out of, let's say, if you have a choice of which has to be a top prediction, right? Then of course 4 is a better prediction, a better movie to recommend to users who have watched movie 1 as compared to 5, right? Because 1 and 4 have a better similarity as compared to 1 and 5. Okay, so that's how you generate user-based similarity. Sorry, you generate item-based similarities as compared to user-based similarities. Okay, so that's how your item-based collaborative filtering works, right? It's exactly, I mean, like someone who understands user-based collaborative filtering, right? Item-based collaborative filtering is exactly the same approach. It's just that the level at which you're finding similarities is different, right? In case of user-based collaborating, you're finding similarities between users. In the case of item-based collaborative filtering, you're finding similarities between items. Okay, we're not looking at user level attributes, right? That's a second level of analysis that you could do potentially, but we, like, in general, user-based collaborative filtering does not really look at the, let's say, the demographics or similarities of users outside of the ratings that they've already given to the movie, right? It's essentially a very simple analysis which just looks at the ratings, and based on the ratings, it will calculate the score, right? The similarity score and the prediction of an item for a particular user. That's all, right? In the case of item-based in the case of hybrid models, in the case of item content-based filtering, right? You will look at genre, you will look at language, you will look at actors, you will look at all of those things, right? To identify the metadata of the content, right? But in this case, you're not really looking at the metadata of the content. Rather, you're just looking at the ratings, right? So if a user has watched and liked a movie, irrespective of whether that movie is of the same genre, same language, same actor, etc., it doesn't matter, right? Someone just giving a rating is an indicator of whether they like or whether they do not like that movie. Okay, so that's all that is used, right? So it's essentially an algorithm which looks at very, very, very let's say granular information, because this information itself is very granular but very specific information, right? It's not subjective. It's not something which requires a lot of problem solving between different stakeholders. Just the collaborative filtering part, right? And as I said, right, you can combine collaborative filtering with other approaches and also look for, let's say, similarities between, based on, let's say, the movie language, actors, etc., right? That will be a second level of analysis, but at a primitive level, at a collaborative filtering level, you will not look at all of those attributes. Okay, cool. So that's about both the approaches, user-based collaborative filtering and item-based collaborative filtering, right? So what are we going to do now, right? What problem statement are we trying to solve here, right? We're going to use recommendation engines to predict, right, or to basically generate recommendations for users based on the kind of books that they've watched and rated before. Okay, so essentially, we're going to generate recommendations for books, right? And for every user that we have in our data, we will generate around 6 recommendations for them, right? What are the top 6 books that should show up as recommendations to these guys? That's what we're trying to do here. Um, by the way, the implementation of recommendation engines is quite straightforward, right? When I say straightforward, what I mean is the 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 machine learning aspect of it is quite straightforward. You don't really need to probably spend a lot of time understanding how this whole algorithm is structured, right? Because it's quite similar to the other kind of analysis that we've done, right? The biggest, the most complex part, right, or slightly different as well, I would like to call it. The different, the difference in the implementation of this recommendation engine concept is essentially in the data manipulation part, right? So the way you bring your raw data, okay, to a structure which you could then use to build your recommendation engine is where the complexity, or it's where the larger effort is, right? Then once that data structure is created, okay, once you have that model, the data model ready, right? After that, implementing the concept and then getting recommendation out of it, it's probably the simpler part, okay, of the recommendation engines. So what you need to do is you need to have two data sets available to you, right? Two data sets that you should have in your library. The first one is the books data set, right? And the other one is called the ratings data set. Okay, the more important data set for us is this one. It's called the ratings data set. What does it have? It has for each user ID. By the way, user ID is a unique identifier for each user in this data set. For each user, what are the different books that they have read? Okay, you have a book ID, you have a user ID. Each book ID represents one book. Each user ID represents one user, and then you also have the rating that this user has given to the book that they have rated. Right? So for example, user ID 1 has rated this book ID 258, and the rating that they've given to this book is 5. Okay, similarly, user number 2, they've rated this book ID which is 8519, and they've given a rating which is 5. Okay, so this is the data set that we're going to use to build our rating, right? Build our recommendation engine. There's another data set that we're going to use, which is essentially a supporting data set to it. Okay, that data set is the books data set, this data set, which just contains the metadata of the book. Okay, so for every book ID that you see here, this book ID is the same as the book ID that you saw in the rating data set. Okay, the same book ID which you have here, right, in your ratings data set is also available in the books data set that you have here. And what you have in the books data set is essentially the metadata of each book, right? So book ID, okay, you have information like who was the author of that book, okay, which year was the book published, right? What is the title of the book, okay, the language of the book, the average rating of that book, the total number of users who have rated that book. Okay, so a lot of different pieces of information with respect to the book itself, okay, is available in the books data set. But what we essentially need from this data set, okay, is just.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
The book ID and information about the book, right? Everything else is not relevant. Our primary data set to build the recommendation engine on is going to be this data set, right? The ratings data set. Okay. Now what we have to do is we have to bring this data set to the structure as you saw in one of my slides, right? We have to generate a user rating matrix, right? A rating matrix where a user has ratings for all of the books that they have read on not read. Okay, and using that you have to generate a recommendation model. Okay, so let's see how this whole data manipulation exercise is performed. Right, what are the different things? What are different functionalities that you need to explore, right, for arriving at this data model itself, and then how would you use that data model to generate recommendations is a different ball game after that. So you would need several libraries. Okay, you would need several libraries. You would need the dplyr library, okay, for some of the data manipulation that you're doing. You would also need a library which is called tidyr. Okay, tidyr is a library which is also used for data manipulation. There's another library, another package that you would need, which is called the matrix package. Okay, matrix package is required here. it will give you some idea around. It will basically be used for converting the data frame to several types of matrices, right, which is required, which is an additional requirement here. And what we also have to use is a library called the recommender lab. Okay, recommender lab is the package or the library to generate recommendations, right? To build your recommendation model, you need this library called recommender lab. Okay, so I think you would have only this library out of the 4 libraries which I mentioned there. You would only have dplyr installed with you already. You should library, right? You should run install.packages. Okay, and then within that, the 3 libraries that you need to install. Okay, you should run this code first on all of these libraries and then activate the libraries. All right, I'm going to just activate them directly because I have these libraries already installed in my machine. Import the dataset, which I have already done. Okay, what I'm going to do next, okay, from in this dataset is that I'm going to take the ratings dataset. I'm going to call it, I'm going to take the ratings dataset, right, and I'm going to generate, okay, a list of unique users, okay, unique user IDs and a list of unique book IDs out of this. Okay, so all the unique user IDs from the rating datasets and all the unique book IDs sorted in the ascending order in a list, right? Within the list, I have 2 components, 2 elements: user ID and book ID. The user ID will have the list of all the users, okay, and book ID will have the list of all the books. Okay, I have dimension names here, right? This gets created, and it's a list which has a component called user ID, which has 1806 elements within it, which means there are 1806 unique users. Okay, in this data set. Yes, I can zoom in. Yeah, so I have 1806 unique users, right, in this data set, and I have 5033 unique books that I'm going to rate. Okay, so dimension names, right, is essentially a list that I've generated which has the list of, or you could say it's a list of all the unique users and all the unique books, right, all the unique user IDs and all the unique book IDs that I have in my ratings dataset. Okay, that's all I have here. The reason I'm creating this dimension names object is because when I generate, by the way, when you build a recommendation engine, right, to build your recommendation engine is a matrix, right? You cannot build a recommendation engine on a data frame. You will have to build it on a matrix object, right? And not a simple matrix, but a specialized matrix object, which is called a real rating matrix. Okay, a real rating matrix. That's what we're going to use. Okay, I am generating this dimension names object, right, so that I can name the rows and columns, right, of that object using this dimension names. Okay, I will show that to you, right? I'll bring this back and show you how I assign row names and column names to my data set using this dimension names. Okay, now the next step, in this data manipulation exercise is that if you remember when we were looking at the slide, the way we want to capture our data, right, in user-based collaborative filtering or item-based collaborative filtering is this, right? We want each row to represent a user and each column to represent a book or a movie, right? So I want to create a similar structure here as well. Right now, the data that I have is structured in this manner, right? I have user IDs repeating. So one row is not unique to a user, right? Rather, each row is unique to a user and a book, right? I want to create a data set where each row is unique to a user and each column is unique to a book. Okay, so essentially, if I take the unique of all the book IDs and generate a column out of it, I can do that, right? So that's exactly what I'm trying to do here. I'm using a function called spread. Okay, spread. This function comes from this library called tidyir. Okay, tidyr. It is a way of transposing data, right, of changing the data structure, right, from a long data set to a wide data set. That's exactly what I want, right? Right now my data set is long because my user IDs are repeating. I want to make it wide, right? Instead of having just 3 columns, I will have columns equal to the number of books that I have, almost 5033 different columns, right? Because I have 5033 different books in this data set. All right. In a way, not unpivot, rather generate a pivot out of it, right? Unpivot is not the right word to use, right? Because let's say if you have a book ID, like if your book ID is in different columns, you cannot create a pivot, right, and bring it all in the one in one column, right? That's not something you could do. So yeah, basically doing a transpose, right? You will and yeah, this is how you do it. Spread is the function that you would use. The data set on which I want to do the spread is ratings, right? Book ID is the column on which that I want to put on the columns, right? So the field that you want to generate columns out is the second argument that you have to specify, book ID, and then the values that have to be inserted in each cell, right, is the rating, right, that the user has given to each book that they've rated. So that's what I'm doing. I'm running this, right, and then it's run, by the way, right? It has, if you see, now my data set initially had 100,000 rows and 3 variables. Now the rating matrix that I created has 1806 observations, which is equal to the number of users that I have, okay, and 5034 variables, although the number of books that I have is 5033. Okay, I'm just going to show you quickly the first few columns, or the first, like, a subset of my data set. This is how my data set looks like. Okay, in my rows, I've just taken the first 6 entries, by the way. I've not taken the entire data set, but I have 1806 observations. This is how I have it, right? Like, I have a field called user ID, 1, 2, 3, 4, 5, 6, 7, and then each row represents one book, right? This 2, 3, 4, 5, 7, 8, 9, etc. are the labels of the columns, is nothing but the book ID. Okay, this 14 is a book, 15 is a book, 18 is a book, right? For example, user number 1 has not rated any of these books, right? The first 25 books that I have in my data. But user number 3, right, user ID 3 has rated the book 4 and has given a rating 3 to it, right? So wherever you see an NA, it means that user has not rated a movie, has not rated that book, right? So user number 4 has rated book 2 and given a rating 5. They have not rated the book 3, which is why you have an NA here. They have rated book 4 and 5 and given rating 4 and 4 for it, right? And for book ID 7, they haven't rated yet. 8, they haven't rated. 8 they have rated and given the rating 4. 9, they haven't rated. 11, 14, 15, they haven't rated, right? So anywhere that you see an NA is basically because they haven't rated that movie. Okay, so what I've done so far is that I've converted the structure of my data, right? I have book IDs in my columns, and ideally I should have row IDs in my like my row IDs should be indicating users. I do not want this user identifier, right? Because user ID is a string field, right? It's essentially a character field. If I want to generate a matrix out of it, right, I only want ratings, right? I only want numeric quantitative ratings. I don't want this user ID column. So what I'm going to do is, from this rating matrix, okay, I'm going to delete the user ID column. Okay, I'm going to delete the user ID column. Okay, so select rating matrix and minus user ID. Okay, so this is how my user ID, this is how my table looks like now. Okay, I have only ratings. In my columns, I have books, right? And in my rows, I have users. I have, each row is depicting a user, but I do not know what user is in row 1, what user is in row 2. I can assign a row name, okay, to this matrix. If I create a matrix, I can assign a row name, okay, and then I would know that this row is identification of which user. Okay, I'll do that later, but for now, I have created a matrix. I have created a data set. It's still a data frame, by the way, right? Where you have each row representing a user and each column representing a book, and each number representing the rating that user has given to that book. Okay. What you're going to do next? Divya, yeah. Why have I deleted the user ID? Is because in my rating matrix, I only want the content which should be present in my dataset, right? The actual values that I have in my dataset or in my matrix should only be the ratings, right? I do not want any additional fields. Okay, so I'm removing user ID. But then your question would be that how would you identify which row belongs to what user, right? So I will basically, what I will do next, or what I will do in some time, is that I will assign a row name to each row, right? And that row name will be identified by the user name or the user ID, right? So I will use user ID field to identify a row, right? I'll give a row name and a column name, right? And that will be my way of identifying that this row belongs to this user. But in the content, I do not need that user ID. I just want the rating that a particular user has given to a particular book. Okay, because a matrix, you can only create a matrix if you have only numeric fields in your data. Okay, so that's why I've done that. The next thing that I'm going to do is I'm going to convert that into a matrix. Right now, without the user ID, it means I'm only working with ratings, right? And ratings are all comparable fields. They're all numeric fields, right? So I can just convert this into a matrix. A matrix is a homogeneous object, right? That's why I have to remove user ID before doing that. So if you see, if I look at the class of a matrix, it's essentially a matrix, right? And like the subcategorization is array, which isn't important. But yeah, if I just want to show you how my rating matrix looks like, this is how it looks like, right? You have a few row names, right? 1, 0, 2, 0, 3, 0, 4, 0, and you have column names. And within this data, you have the ratings that a user has given to a particular book. Okay, now what I'm going to do is that I'm going to use this dimension name object that I had created earlier, right? Which stores the user IDs, the list of user IDs and the list of book IDs sorted in ascending order. I'm going to use this field to assign the dimension names of my matrix, right? So the row name can be identified from the row index of my dimension names, and the column names can be identified from this book ID column, right? So now what I'm going to do is I'm going to use this function called dim names, right, which is used to assign dimension names, right, a row name and a column name to each value or to each row and column of my matrix, and I'm going to assign that using this dimension names object. Okay, that's what I do. And now if I look at the rating matrix, you'd see my rating matrix now has a row label, right? This is a row label. It's not an actual data set. It's not in the actual data, but it's only a row label, right? It's saying that this row belongs to user 1, this row belongs to user 2, this row belongs to user 4, 5, 6, 7, etc. This column belongs to user A, this column belongs to book ID 2, this column belongs to book ID 3, this column belongs to book ID 4, etc. Okay, so that's all I'm doing, right? It's not inside your data set, it's not inside your matrix, but it's a way of just having row names and column names into your data set. Okay. If I want to see what is the number of rows and number of columns that I have in my data set now, I could just do dim. Okay, the dimensions of rating matrix. It tells me there are 1806 users, there are 1806 rows, okay, and 5033 columns, which means that there are 1806 users, okay, in my data, and 5033 books that have been rated by at least one user, right? Okay, in my dimension names object as well, which I had created earlier, I had the user ID field ranged from 1 to 1806 and book ID field ranged from 1 to 5033. Right, so 5033 book IDs and 1806 users. These are also present in this matrix that I've created. Okay, now what I've done is I created a matrix, right, which has ratings of all the users of all the different books that they've rated. This is not enough. Okay, this is not enough. We have to create a structure. We have to create a data object, right, which is called a real rating matrix. Okay, we have to create an object which is called a real rating matrix out of our existing object, which is a required condition for building a recommendation engine, right? So you cannot build a recommendation engine on a simple matrix. Rather, you have to use you have to create a specialized form of a matrix, which is called a real rating matrix, right? And on that, you can build your recommendation engine. Okay, so the next set of steps that you see here, right, is basically a few steps that you need to follow, right, to convert your simple matrix, okay, a rating underscore mat, a simple matrix, to an object which is called a real rating matrix, right? I will also show you why we would have to do all of these adjustments, why they're important, right? Why are they almost a compulsion in your implementation, right? I will tell you the reasons for all of it, right? And I think that's when you will be able to better appreciate it. So first of all, what I'm doing here is that I'm just creating a duplicate of this rating matrix, right? So rating underscore mat is 0. is just a duplicate of this rating matrix, right? I just want to work on a duplicate, not on the actual object, because let's say if I make some changes in my rating underscore mat, right, which I did not want, then I'll have to again run all of these codes, right? And because this is like a very computation expensive sort of an operation, I would create a duplicate and run on it, right? Rather than like moving back and generating all of those um, data outputs again if I end up making a mistake. Okay, so I've created rating underscore mat underscore 0, which has the same dimensions, right? 1806 rows and 5033 columns. Now, what I'm going to do is that I want to make sure that all the NAs, right, in my data in this rating matrix, okay, all the NAs in my rating matrix are converted to 0, right? Because if someone has not watched a movie, or sorry, if someone has not rated a book, it means that they have not given any rating to a book, right? So you why not just convert that into 0? You cannot work with NAs, right? In a model, right? Your data cannot have missing values. So what I'm going to do is I'm just going to use this function called is.na. Okay, is.na on my rating underscore mat 0 object, right? Wherever it finds an NA, right, on this object, it will convert that into 0. Basically converting missing data into 0. So that's exactly what I'm doing here. So if I look at the output when I have done this replacement of NAs with 0, this is how it looks like, right? So all NAs have been replaced by 0. It means wherever you see a 0, it means that that user has not rated that movie anything. A 0 rating would mean that user has not read that. Okay. Now the next step that you need to do, okay, on your rating matrix or on your object is that you have to convert this matrix into a specialized object which is called a sparse matrix. Okay, you have to convert this rating underscore matrix to an object, a specialized form of a matrix which is called a sparse matrix, right? What does a sparse matrix do? A sparse matrix basically is a compressed form of your existing matrix. Okay, it identifies 0 values and encrypts them in the form that it takes much lesser space, right, and it compresses the data. Why is it important for you to compress the data? Why is it important for you to do all of those modifications? Is because when you build a recommendation engine, right, in a real life scenario, you would be working with almost millions of rows of data, right, almost terabytes of data. So it's very important that you're also optimizing for space, you're also optimizing for efficiency of your code, right? And hence this is important, right? A sparse matrix is a much more efficient object as compared to a simple matrix. Okay, so I'm using a function called as, right, which converts this rating underscore mat 0 to a sparse matrix, and this sparse matrix I'm naming it as sparse ratings. Okay, this you will be able to run this function only if you have the matrix library installed. Okay, so this comes from the matrix library, this library that we are using earlier. Okay, let's look at the first 15 rows and the first 15 columns of sparse ratings. And this is how it looks like, right? So what it has done is that it's converted all zeros, right, to dots, right? It is only retaining the actual values. All zeros have been truncated to dots, right? Which is essentially a way in which it's trying to save space. Okay, it's trying to save space. Okay, cool. So we've created a sparse matrix, right? There's just one last step which is required to be done now before you can go ahead and create your model, right? That step is converting this sparse matrix into another specialized format which is called a real rating matrix. Okay. For generating recommendations, for building a recommendation model, right, you will have to make sure that your object, right, the data object that you supply to a user-based collaborative filtering model or an item-based collaborative filtering model is essentially in the form of a real data matrix. Okay, so real ratings is an object that I'm creating, right? New is the function that I use, and then within new, real rating matrix is what I want as the object output, right? And the data that I'm going to convert that from is the sparse matrix. Okay, when I run this, this is how I get the output, right? If I try to output this data now, right, if I want to look at how this output looks like, you'd see that it does not really give me an output. It just tells me that this real ratings is a matrix which has dimensions 18 into 6, 1806 into 5033, which means 1806 users and 5033 books, right, of class real rating matrix with 100,000 ratings. Right, it has a total of 100,000 ratings, 100,000 ratings that the users are given, right, and it's essentially a way in which you would save a lot of space, right, as you could see. And it's important for you to also notice this, right? Say, for example, the rating matrix that you had created earlier, this rating underscore mat, it's an object which takes around 73.2 MBs of your data. Okay, takes around 73.2 MBs, but this sparse matrix or the real rating matrix that you've generated, okay, it takes only 1.7 MB, right? So it's basically very, very efficient in terms of its storage. Okay, and that's why it's important to create a real ratings format, right? Because when you give a real ratings format to a user-based collaborative filtering, because it generates so many permutations and combinations, the data will essentially expand, right? And then if your data set is large, it will just run into full space error, right? You'd not be able to complete your operation. Okay, so for that reason, right, you need a real rating matrix, right, and make use of it. Okay, so this is what you'll have to do, right? All of these steps that we saw, right, are all the steps that are required to be done so that you can bring your raw data, right, which was earlier in this format, right, this format, where each user ID is repeated multiple times across different rows, and each book ID has one row dedicated to it, right? One user book combination has one row dedicated to it. You have converted it into a format, right, which you can't even look at, right? It just tells you that it's 1806 rows, 5033 ratings, right? And there are a total of 10,000, 100,000 odd ratings available there. Okay. Once you've done this, it means that your data manipulation operation is over, right? You sort of reach that step where you can now start building your user-based collaborative filtering method. Okay, your user-based collaborative filtering model. Okay. Now let's get into the implementation of the user-based collaborative filtering model. Okay, we'll first try and generate a user-based collaborative filtering model, and then we'll look at a item-based collaborative filtering model as well, and see how recommendations are different across these two types of recommendation engines. Okay. So what do you need to do, right? For any prediction, you have to split your data, right? You have to split the data into 18. You can choose 75-25. You can choose 80-20, whatever. Right? Yeah. Okay. So the first thing is to split my data, right? I could either split 75-25 or I could do a 80-20. In this case, I'll just go ahead with 80-20. Okay. 80% of my data is my training data set. 20% of my data is test data set. I cannot use the CA split function here, right? Because sorry, the CA2's library, the sample split function that we have there, because that function doesn't work on matrices, right? And it definitely doesn't work on a real rating matrix, right? For that reason, I have another function here, right? That function is called a sample. Okay, I'm using a sample function. In the sample function, I'm saying there are two inputs that I need to specify. Okay, two inputs or two outputs that I need to have, okay, in my data. I want a true and I want a false. Okay, I want a true and I want a false. Okay, this is the total size of my data set, right? Number of rows in my real ratings object, right? Replace is equal to true will mean that you want to do sampling based on replacements, right? You can, it's an optional statement. If you want to ignore, that's okay. Okay. And then you have to specify probabilities corresponding to true and false, right? So if you say 0.8 is to 0.2, it would mean that 0.8 80% of the data will be randomly populated with true and 20% of the data will be randomly populated with false. So 80% of the size, right? 80% of the number of rows of the data will have values true that will be assigned to them, and 20% of the data 20% of the size of the data, right, will be replaced with false. Okay, same thing that you do with the sample split object, right? Just that because you cannot use that function here, I have created I'm using the function sample which does the exact same thing, right? I'm splitting my data into training and testing. Okay, wherever real rating matrix is split tag is equal to true, right? The split tag is true. Okay, that's where I'm generating a rec underscore train. Wherever it is not true, right? Split tag is not true. Okay, that's where I'm generating a test. Okay, I have a train, I have a test, right? Train is of course for 1.4 MB and test is 618 MB. Okay, so train is a larger dataset, test is a smaller dataset. Okay, so you have created training dataset, you have created a testing dataset. What is left now, right? It's only about building your model. Okay, so this is how you'll build your model. The function that you use, right, to build a recommendation engine model is called the recommender function. Okay, recommender is the name of the function that you would use to generate recommendations. Okay, generate recommendations. Recommender data is equal to rec train because you want to train your data on the training dataset. Okay, and then the method that you use to train is UBCF. When you say use UBCF, it would mean that you want to run a user-based collaborative filter. Okay, when you specify the method as UBCF, okay, what it would do in the backend is that it would basically try to identify similarity between users, and then based on the similarity between users, it will make predictions taking into consideration similarity between users and the ratings that each similar user has given to the movies that they've to the books that they have read and rated. Okay, so UBCF is what we're going to use first, right? And we can also build a model on the item-based collaborative filtering, but we'll look at item-based collaborative filtering later. First, we'll do a UBCF model. Okay, UBCF. It might take a couple of minutes for it to run. Okay, and then what you have to specify is the total number of recommendations that you want to generate for each user, right? This recommendation will be done at a user level, right? Because you want to show these recommendations to the user on the website, right? So what are the total number of recommendations that you want to see? How many items can you possibly fit in that let's say in that tile, right? That is in that tile which is going to show all the recommendations, right, on the website or on the app. Let's say there are 5 recommendations that you could possibly show. So just do n.rec is equal to 5, which means you want to generate 5 recommendations. Okay. Then what you have to do is you have to use the prediction function predict, right? Object is equal to rec underscore model underscore UBCF, right? New data is equal to rec underscore test, right? And then you have to generate predictions on each user. Okay, you cannot generate recommendations at once, right? You will have to generate recommendations at a user level because this whole algorithm is only relevant as a user at a user level. Okay. So yeah, I mean you can use any user ID, but I'm just using 5 as a user on which, or the 5th user. Okay, from the top on which I want to generate the recommendations, right? So new data is rec underscore test, right, and 5th user. Okay, I run this, right, and I also specified the number of recommendations that I want to generate. What happens as a result of this? Okay, we can also look at the object that gets generated. By the way, you'll have to generate multiple such objects. Okay, if you want to generate recommendations for multiple users, you can use an iterative loop, right? And you can use an supply. You can use you can also use a for loop or any other kind of loop, right? That will go to every user and generate recommendations. Otherwise, you can use an supply, right? And you can change this value, right, from 1 to the number of users that you have in your rec underscore test. And of course, very simple to do that. But yeah, at a code level, right, this code the predict function will only work for 1 user at a time. Okay. So what has it generated? It has generated rec underscore predicted underscore UBCF. This is what the output that it has generated. It is showing me, it is telling me that these are the different items, right, that have been shown as recommendations for my user, right? Right, and sorry, these items, right? These are the different book IDs that have shown as the recommendations for my user. 4065, 3690, 4317, 591, and 1417, 1547. Right, and these are the average ratings that the users have given to these books. Okay. Now, how do we use this, right? How do we use this to find out what are the kind of recommendations that have come out. Okay, what you have to do next is extract, right, entities out of these recommendations and then look at them, compare it with the titles and everything, and see what are the different recommendations that you see, right? So what I'm going to do here is I'm going to just generate, okay, a list out of this object rec underscore u predicted underscore UBCA, right? Okay. Right now it's not a list. It's essentially uh, it's a formal class top n list, right? I want to generate a list object out of this. Okay, this is how my top 5 list looks like. These are the different book IDs, right, that have come out as recommendations for this user ID 5. What I also need to do is that I will have to rather look at the kind of books that have come up as recommendations for this user, right? So what you'll do now is that you will map these book IDs to this original object that we had, right, which was the books table, right? This books data set that you have in your environment. You will map these recommendations to these book IDs and see what are the different books that have been recommended to the user, right? What is the title, what is the publication year, what is who's the author, etc. Okay, that's how you would know that these are the different books that are shown as recommendations for different users for which you are trying to generate recommendations. Okay, so first thing that you do is you convert this into a data frame, this top 5 list object that I have. I'm just calling that data frame as top 5 DF. Okay. It has a label X32, right? And then it has these book IDs. I don't want X32 as a label, so I'm just going to change that column name to book ID. Okay, so now my top 5 DF object data frame has a column name book ID. Okay. What I'm going to do next is that I'm going to convert this into a numeric format. The reason I'm converting this into a numeric format is because I want to join it back to this books dataset. And in the books dataset, this book ID is also in the integer format. So if I want to join these two tables on the book ID field, I want to make sure that the data types are similar. Okay, so I'm going to convert this into numeric as well. Okay, and then what I can do is I can do a left join, right? This left join is coming from this dplyr function, by the way, right? This dplyr, in dplyr you have this flexibility to join, to do a left join, right join, or whatever, right? So left join top 5 DF on my left table is the top 5 DF. In my right table, what I'm doing is I'm selecting these fields from my books dataset, right? I'm selecting the book ID, the author name, the title, the language, the average rating, right? And I'm going to do the join on book ID, right? I have book ID in books dataset. I have book ID in top 5 DF. I want to join both of them, right? And retain the information from both the tables. Okay. So that's what I'm doing here, right? So names, the names gets generated, and if I do a view of names, this is the kind of output that I get. Okay. These are the 5 books that have shown up as recommendations for this user 5, right? These are the these are the authors. By the way, you also see that the couple of authors, right? Margin Satrapi is common between 2 books, right? In fact, it's the same book, right? Persepolis and Persepolis 2, right? Which similar users. Actually, this is also an identification of the fact that when you look at similarity between users, it also sort of takes care of the genre, the kind of likeness that people have towards content, right? So you see, there are 2 books, right, out of 5, which are essentially the same genre, the same author, right? Although you haven't really put that as an input, right? You just looked at user preferences, right? You just said that I want to see that who are these users that have very similar preferences as me, right? Who have similar taste as me with respect to the ratings that they've given to the books that they've read, right? And 2 books, right, which are essentially from the same author, right, which are also probably in the same genre as well, right, same language, have come up as recommendation. Okay, so it also sort of takes care, and this is a good validation of that. And also the other thing that you should check, right? There are 2 books that are in Persian, right? So it means that this user is also reading a lot of books in Persian, right? And you should, I mean, we haven't used all of these features in our model anywhere, right? We haven't specified that we want to look at the language code, we want to look at the genre of the book, we want to look at the authors, right? But it just comes out naturally, because when you look for similar users, right, the kind of books that they have, that you have overlap with, right? When you're given a very high rating to one book, let's say 5 books, the other users who have given a very high rating to the same book are also users who have similar preferences like you, right? They read similar kind of languages, they read similar types of books as you, right? So it sort of takes care of the genre, it takes care of the metadata of the books as well. Okay, and it's evident here. Also, you should see that the average rating of all of these books that have shown as predictions, right, or recommendations for this user are also very highly rated books, right? So average rating, like all these books have rating which is greater than 4, right? And 4 out of 5 is generally decent rating, right? So yeah, that's how you generate recommendations, right? And then look at the recommendations finally to show up on your tile. You can quickly generate recommendation for another user and see how they turn out to be. Let's say we want to generate recommendation for maybe the 15th user in my dataset. I could do that. Okay. The same set of steps will repeat, top 5 list for each user. And then all of this will repeat, and then you will finally look at the names of the books that you want to suggest. Right? Yeah, these are different books: Watchmen, Cat's Cradle, Speaker for the Dead, Why, Last Man. All of them, by the way, are fictional movies, right? Fictional movies which are in English, right? The authors aren't common. I don't see any common authors, but they're all in the same genre, in the sense they're all fictional movies, and the ratings are also really high. Someone who has good knowledge of books will have will probably be able to appreciate this better, right? I haven't read any of these books, right? So I don't really know if there are similar books. What I know though is that most of them are. Watchmen is a fiction book. Cat's Cradle is also fiction. Right? Speaker of the Dead also sounds like a fiction book. Yeah. Okay, so this is how you generate recommendations, right? That's how you generate recommendations, right? For using user-based collaborative filtering, right? I think what would make sense for us to do now is look at one example where we generate recommendations using item-based collaborative filtering, right? That's also one of the ways through which you can generate recommendations, right? How you generate recommendations and how you extract features out of it is something we can look at in a while. But look, I'll just quickly look at the example that okay. Yeah, so let's just quickly look at how you would generate a recommendation engine, right, using the item-based collaborative filtering, right? The only thing that changes in your execution when you do item-based collaborative filtering is this, right? So the method that you're going to say, that you're going to specify, okay, in the case of user-based item-based collaborative filtering, is that you will make in this code, right, where you did the recommender function, you would just say method is equal to IBCF. When you do IBCF, right, instead of looking at similarity between users, the data will start looking at similarity between items, similarity between books, right? What are the 2 books that have very similar scores, right, in terms of people rating them? Okay, so let's just generate that model, right? I'm training my model here. Might take a little bit of time to get trained. Okay, we have to specify the number of recommendation that you want to generate, right? Let's say it's 5. Everything else, by the way, remains the same, right? You don't have to make any changes to it. It's still running, by the way, because there are more items as compared to number of users, right? When you were finding out similarity between users, because you have only 18, you have around 1806 users, right? So you have to look at 1806 C2 combinations. Now you have 5033 books, right? So you have to do 5033 C2 combinations, right? So that's why it's taking a lot of time. It will take at least 1.5 2 minutes in a good machine, right? But if your machine has lesser uh, computation power, it might take 5 7 minutes as well. Okay, while that happens, right, while the code is running, what we have to do is let's just see if we have to modify any of this going below. No, we don't have to modify anything, right? Everything else remains the same. We have to specify once the model has been run, just do the recommendations, right? What recommendations you want to generate for this user. It's the same user, by the way, right? 15. Uh, these steps also remain the same, right? So you're just generating a list out of your recommendations, top 5 books, convert that into a data frame calc, change the column name to book ID, change the column to numeric, right? Because you want to join it with the top 5, with the books data set. The select basically makes sure that you're not selecting the entire data set, but you're selecting only the fields that you need, right? Some 4 or 5 fields that I need. That's what I'm doing here. Then I do a left try. And then I look at the recommendations. These are the recommendations that get generated, right? Based on item-based collaborative content, right? Which means these are the books, right, that have very similar score, very similar rating as compared to the books that this user has read already. Okay, again, I think because it's the same user number 15 who we are generating the recommendations for, you see that the books are also the same genre, right? Fictional books, most of them, English language. Ratings doesn't matter, but the average rating is high, right? Close to 4, better than 4. But they're all fictional authors, by the way. Agatha Christie, William Goldman, Jeffrey, Eugene Knight, whatever. I don't know this guy, but yeah, most of them are actually fictional authors. Let's try to generate the recommendation for the 5th user, right? So who we are generating the recommendation, the one which had some Persian books as recommendation. Do we see that in item-based collaborative filtering as well? No, we don't see any Persian recommendations, right? In item-based collaborative filtering, we only see English recommendations for the 5th user. Yeah. So essentially, the recommendations that you would generate from item-based collaborative filtering and user-based collaborative filtering are going to be very different from each other. Okay.
So, have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So, our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So, as the name suggests, ratings.csv contains all users' ratings of the books. So, there are a total of 980,000 ratings for 10,000 books from 53,424 users. So, the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So, this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So, the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
Task which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Right, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our datasets, guys. So we have the ratings dataset, which comprise of these three columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags, and here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings dataset by user ID and book ID. After which I am using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function, and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users, and I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings, so now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Alright. And I am also setting the guides to be false. Let me hit enter. So this is what we get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we had to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the dataset in descending order. And after arranging the dataset in descending order, I will also left join the tags dataset to the book tags dataset. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So up next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Alright guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books dataset, I am arranging it in inverse order of the ratings count column. And then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs, and I'm also extracting all of the unique book IDs, and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID, and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column, this value of book ID 2 would become the second column, this value of book ID 3 would become the third column, and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix, and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book, and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating math 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in two parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now, and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here, and this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into two parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store this split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is unrecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in unrecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here rec predicted UBCF at the rate items1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274 and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @ tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @ item labels. And inside this, I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jhumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users. Hey guys, welcome back, and in today's session we'll be working on a project. So let's have a look at the problem statement. So consider yourself to be the manager of a supermarket, Walmart, and your task as the manager of the store would be to increase cross-selling. That is, you'd want to encourage the customers to buy items related to what they've already bought. And to do this, you'd have to find the association between different items. That is, you'd want to figure out if a customer buys item A, how likely is he to buy item B as well. So you'd have to start off by understanding the transactions. So you'll have to find the total number of transactions. Then you'll have to find the total number of items available in the inventory. After which, you'd have to find the total number of items purchased. And then finally find out the 10 most frequently bought items. So let's go to our studio and implement these. Right guys, so we are back to our studio. So we are supposed to load the A rules and A rules Wiz packages. And I'll be loading them with the help of the library function. Right, so we have loaded both of these packages. Now it's time to load the dataset. So now to load the dataset, I'll be using the read.transactions functions. So this read.transactions function helps us to read a dataset in the form of transactions, right? So the file name is marketbasket.csv and I have a parameter format and the value which I'm assigning to this is basket. So this basically means that each record in the dataset would be in the form of a transaction. Then I'll go ahead and remove the duplicates. So I'm setting rm.duplicates to be equal to true. And then I'll skip the first record. That is, I'm not reading the first record and I'll read the rest of the records from the dataset. And I'll be storing this in a new object and name that object to be market basket. Right, so we have successfully loaded the dataset. Now let us have a glance at the summary of the object which we've just created. So summary of market basket. So you see all of these values over here. So these values basically tell you the number of items which were purchased in each transaction. So let's take this. So this basically tells you that there were 1359 transactions in which the number of items bought were 2. Similarly, if we take this value over here, so there was one particular transaction in which the customer had bought 548 items. Similarly, if we take this value, so there were 433 transactions in total in which the customers had bought 19 items. If we take this value, so this is 165 items. So there was one particular transaction in which the customer had bought 165 items in total. Right. So we had to find the total number of transactions and the total number of items available in the inventory. So the transactions would be the number of rows. That is, the transactions are listed in the form of rows. So the number of rows would give us the total number of transactions. And since the total number of rows are 18,440, the total number of transactions would also be the same. That is, the total number of transactions in the dataset are 18,440. Now the columns represent the items. So that is why the number of columns which we have would also represent the total number of items. And since we have 22,346 columns, that would basically mean that we have 22,346 items in total in our inventory. And then we also have a value of density. So this density value basically gives the percentage of all of the non-empty cells in our matrix, right? And then we'd also had to find out the total number of items which were purchased. So to find out the total number of items which were purchased, we'd have to multiply the total number of transactions with the total number of items available in the inventory with the density value. So let's go ahead and do that. So I am multiplying the total number of transactions with the total number of items available in the inventory with the density value. And this is what we get. So you see that in total 4,08,582 items were purchased. Now let's actually have a glance at the first 5 transactions. So what I'm
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
doing here with this command is I am giving the name of the object which is market basket and I am inspecting the first 5 transactions. So these are the first 5 transactions, guys. So in the first transaction, the customer had bought just one item and that item was medium ceramic top storage jar, and this is the second transaction. So there are around more than 30 items in this, right? So in the second transaction, the customer had bought more than 30 items. Similarly, this is the third transaction, this is the fourth transaction, and this is the fifth transaction. And the final task was to find out the 10 most frequently bought items. So let's go ahead and make a plot for that. So now, since we want to give different colors to the different bars which we are making, we would require the R color brewer package. So let me go ahead and load that. Right, so I have loaded the R color brewer package. Now to find out the frequency of different items, we have the item frequency plot. So I'll be using this function. So let me guide you through this function. So first off, we will give in the name of the dataset, which consists of all of the transactions. And then I'll give in the number of the transactions of which we'd want to make this plot. And since we'd want to make a plot of the top 10 most frequently purchased items, I will give in top n equals 10, and then type is equal to absolute. So this will give us the absolute count of all of the items which have been purchased. After that, I will stack the bars horizontally. So horizontal equals to true basically means that I am stacking all of the bars horizontally. And then this brewer.pal, this function comes from the rcolor brewer package. And I am assigning 10 different colors from the spectral palette. Right. So let me hit enter and this is what we get. So guys, these are the 10 most frequently purchased items from the entire data. So this white hanging heart tea light holder is the most frequently purchased item, right? So now that we're done with the first task, let's go ahead and build our first set of association rules. So here we'd have to build a priori algorithm with support value 0.005 and confidence value 0.8. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. After which we'll go ahead and sort the rules with respect to lift and inspect the top 5 rules. And finally, we'll plot the rules using different methods. Right, so let's go ahead and perform all of the above mentioned tasks. So we were supposed to build an a priori algorithm with these parameters. So let me put in the command over here. So what I'm doing is, on top of the market basket data, I am building the a priori algorithm with these parameters. So here the support value is 0.005 and the confidence value is 0.8. So the support value of 0.005 basically means that out of all of the transactions, I am selecting those item sets which occur at least 0.5% times. So I'm reiterating guys. So the support value of 0.005 basically means that out of all of the transactions, I am extracting only those item sets which occur at least 0.5% times, right? And then we have this confidence value which is 0.8. So this confidence value of 0.8 basically states that out of all of the item sets or out of all of the antecedents which we have extracted, the consequence should be present 80% of the time, right? So we have assigned the support value to be 0.005 and the confidence value is 0.8, and I am sorting the rules with respect to confidence and I am storing it in an object and naming that object to be rule 1. So let me run this. Now let me have a glance at the summary of the rule which I've just built. So summary of rule 1, and we get a summary of this, right? So there are 6 rules which comprise of 6 items including the LHS and the RHS, that is including the antecedent and the consequent. Similarly, there are 79 rules which have 5 items, and there are 211 rules which have 4 items, 201 rules which have 3 items, and 64 rules which have 2 items, right? So this is the length of the item sets and this is the count with respect to those item sets. Now let's inspect the top 5 rules. So I am giving the name of the rule which is rule 1 and I am inspecting the top 5 rules. So these are the top 5 rules when sorted with respect to confidence. So we see that if someone buys garbage design, that customer is also likely to buy key fob, and the support value is 0.005 and the confidence value is 1. So the support value of 0.005 means that out of all of the transactions, garbage design would be present at least 0.5% times. And this confidence value of 1 means that if someone purchases garbage design, then he is 100% likely to also buy key fob. And then we have this next rule over here. So if someone buys elephant, then he is also likely to buy birthday card. And the support value is 0.006 and the confidence value is 1. So the support value of 0.006 means that out of all of the transactions, this elephant has been purchased 0.6% of the times, and this confidence value of 1 indicates that if someone purchases elephant, then he is 100% likely to also buy a birthday card. Right? Similarly, if we take this rule over here, so for this, the support value is 0.006 again. So this means that out of all of the transactions, RetroSpot was bought 0.6% of the times, and this confidence value of 1 means that if RetroSpot is bought, then birthday card is likely to be bought 100% of the times along with the RetroSpot. Now let's go ahead and glance at the bottom 5 rules. So we given rule 1, and from this rule 1 we are inspecting the bottom 5 rules. So that is why we're using the tail function. So these are the bottom 5 rules, guys. So let's examine this rule over here. So there are 2 items in the LHS and there is 1 item in the RHS. That is, the antecedent comprise of 2 items and the consequent comprise of 1 item. So for this, we have the support value to be 0.006 and the confidence value to be 0.8. So the support value of 0.006 basically means that out of all of the transactions, customers are likely to buy this item set 0.6% of the times. And this confidence value of 0.8 means that if someone buys this item set over here, then he's 80% likely to also buy a set of 3 wooden stocking decoration. Now let's have a glance at this rule over here. So on the LHS, the item set is lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland. And on the RHS, we have lunch bag red retro spot. So for this, the support value is 0.006 and the confidence value is 0.8. So the support value of 0.006 basically states that out of all of the transactions, this item set was bought 0.6% of the times, and this confidence value of 0.8 states that if someone buys lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland, then he is 80% likely to also buy lunch bag red retro spot. Now let me go ahead and also sort the rules with respect to left. So rule 1, and I'm sorting this rule 1 with respect to left, and I'm storing the result back to rule 1. Now let me inspect these rules. So I'm inspecting the top 5 rules over here. Right, so after sorting the rules with respect to the left, this is what I get. So if I examine this first rule over here, on the LHS, the item set is Dolly Girl Children's Cup and Space Boy Children's Bowl. And on the RHS, or the consequent is Dolly Girl Children's Bowl. Right, so for this, the support value is 0.005 and the confidence value is 0.96. So again, here the support value of 0.005 means that out of all of the transactions, this item set is present 0.5% of the times. And this confidence interval of 0.96 means that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he is 96% likely to also buy Dolly Girl Children's Bowl. So now let me go ahead and plot these rules. Now let me change the method. So I'll be plotting the rule 1 again, but the method which I'm giving would be toKey. So let's see what is the difference which we get over here. So now this time the coloration is with respect to the length of the item set. So if the length of the item set is 6, then the color of the dot would be yellow. Similarly, if the length of the item set is 2, then the color of the dot would be purple. Similarly, if the length of the item set is 5, then the color of the dot would be green over here. So let's examine this rule over here. So since the length of the item set is 6, so there are 5 items in the antecedent and there is 1 item in the consequent. So here the support value is 0.007 and the confidence value is 0.9. Similarly, let's examine this over here. So the length of the rule is 3 over here. And the items in the antecedent are pink Regency teacup and saucer. And we also have roses Regency teacup and saucer. So if someone buys these two, then there is 80% likelihood that he would also buy green Regency teacup and saucer. So here what we are basically doing is we are segregating these points with respect to the length of the item set. Now let us make the final plot. So this time the method which I'm using is graph. So let me hit enter and let's see what do we get this time. So this time we get a graphical result over here, right? So let me zoom in. So we have all of these rule numbers over here. So let me put my mouse pointer over here, right? So this is rule number 92, which states that if someone buys herb marker mint, herb marker parsley, herb marker thyme, then he's also likely to buy herb marker chives. So for this, the support value is 0.007. The confidence value is 0.89. Now, let me zoom out. So the distance or the gap between these two graphs basically means that there is absolutely no association between these items and these items over here. Similarly, let me zoom back. There are two items over here as well. So these item sets are completely different. These item sets are completely different, and these item sets are completely different. That is, there is no association between these three set of items over here. So let me zoom in again and let me have a glance at this rule. So this is rule number 100 over here, which states that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he's also likely to buy Dolly Girl Children's Bowl. Similarly, let me zoom out and let me have a glance at this rule over here. So this is rule number 87, which states that if someone buys pink vintage spot beaker, then he is 87% likely to also buy blue vintage spot beaker. Now we'll go ahead and build the second set of association rules. So here we'd have to build a priori algorithm with support value 0.009 and confidence value 0.3. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. And finally, we'll plot the rules using different methods. So we'll make the second set of association rules. So this is the command for that. So this time again on top of market basket, I'm building the a priori algorithm. So for this, the support value is 0.009 and the confidence value is 0.3. And I'm sorting the rules with respect to confidence and I'm storing the result in an object named as rule 2. Let me hit enter. We have successfully built the a priori algorithm. Now let me have a glance at the summary of rule 2. So here we see that the length of the item set could be either 2, 3 or 4. So there are 16 rules where the length of the item set is 4. There are 288 rules where the length of the item set is 3. And there are 537 rules where the length of the item set is 2. Now going ahead, let me have a glance at the top 5 rules and the bottom 5 rules. So this is the command for that, rule 2. And I'll be inspecting the top 5 rules using the head function. Right, so these are the top 5 rules. So here let's have a glance at this first rule over here. So if someone buys set 3 retrospot tea, then he's also likely to buy sugar. And for this the support is 0.013 and the confidence is 1. So the support value of 0.013 means that out of all of the transactions, people are likely to buy set 3 retrospot tea 1.3% of the times. And this confidence of 1 means that if someone buys set 3 retrospot tea, then is 100% likely to buy sugar. Similarly, let's have a glance at this. So the rule is backdoor gives us key fob. And for this, the support value is 0.012 and the confidence value is 1. So again, if the support value is 0.012, this means that out of all of the transactions, backdoor has been bought 1.2% of the times. And this confidence value of 1 means that when someone buys backdoor, he is 100% likely to also buy key fob. Now let's have a glance at the bottom 5 rules. So I am inspecting the bottom 5 rules with the help of the tail function over here. Right, so let's examine this. So here the rule is in the antecedent we have home building block word and the consequent we have white hanging heart tea light holder. So for this, the support value is 0.011 and the confidence is 0.3. So the support value of 0.011 means that this item is bought 1.1% times, and this confidence value of 0.3 means that if someone buys home building block wood, then there is only 30% likelihood that the person would also buy white hanging heart tea light holder. Similarly, let's examine this rule over here. So for this, support value is 0.012 and the confidence value is 0.3. Similarly, if someone buys jumbo shopper vintage red paisley, then there is only 30% likelihood that he'll also buy jumbo bag baroque black white. Now let's go ahead and plot these rules. So I'll start off by making a simple plot over here. So I'll use the plot function and I'll give in the rule 2 over here. Engine is HTML widget, which gives us an interactive plot. So you see these bright red colored dots over here. So these are the dots with the maximum lift. So the lift of these dots is more than 85, so it's around 89, 90, right? So if you want a lift of 90, then the confidence should be greater than 0.8 and the support should be less than 0.01. Now let's go ahead and make another plot. So this time we'll be making the 2-key plot. So the method is equal to 2-key. So again, we have 3 different colors over here. So yellow is for all of those rules where the length of the item set is 4. Green is for all of those rules where the length of the item set is 3. And purple is for all of the rules where the length of the item set is 2. So if you have a closer glance at this, then we see that those rules whose length of the item set is 2, they are mostly scattered, right? So they are present everywhere. But when it comes to those item sets whose length is 3 or 4, then for them, the support should be less than 0.015, you see. So these item sets which have 3 items in them, so they are mostly in this bracket over here. So for them, the support needs to be less than 0.015. And if we take these yellow dots over here, so for these yellow dots, the confidence value should be greater than 0.6 and also the support needs to be less than 0.015. Now let's go ahead and make the third plot. Right, so let me hit enter. So we get many different sets over here. So this item set is not associated with this item set. Again, this item set is not associated with this item set. Similarly, this item set over here is not associated with this item set. So let me zoom in and have a glance at these set of association rules. So let me have a glance at rule number 96. So here, if someone buys herb marker parsley, then he's also likely to buy herb marker rosemary. Now let me zoom out and let me have a glance at this association rule. So here, this is rule number 59 and this states that if someone buys set of 3 wooden tree decorations, then he's also likely to buy set of 3 wooden stocking decorations. Let me zoom out. Let me have a glance at another rule. So this is rule number 20 and rule number 21. So this tells us if someone buys blue happy birthday bunting, then there is 71% likelihood that he would also buy pink happy birthday bunting. Let's examine this. So this tells us if someone buys Scandinavian paisley picnic bag, then there is 62% likelihood that he would also buy pink vintage paisley picnic bag. So now we'll build a third set of association rules. Here we will build a priori algorithm with support value 0.02 and confidence value 0.5. Then we'd sort the rules with respect to support and inspect the top 5 rules and the bottom 5 rules. And finally, we will plot the rules using different methods. So guys, we are back to our studio. So let's go ahead and build a third set of association rules. And this would be the command for that. So here on top of the market basket data set, I am building the a priori algorithm where the support value is 0.02 and the confidence value is 0.5. And I am sorting those rules by support. Right, so now let me have a glance at the summary of these 3 rules. So summary of rule 3. Let me maximize this. So we have item sets with just two different length distributions over here. So there are 26 rules with the item set length to be 2, and there are 3 rules whose item set length is 3. Now let me examine the top 5 rules. Right, so this is the first rule, which tells us if someone buys jumbo bag pink polka dot, he is also likely to buy jumbo bag red retro spot. And the support for this is 0.029 and the confidence for this is 0.62. Now let me have a glance at the bottom 5 rules. Right, so rule 3, and I am inspecting the bottom 5 rules with the help of the tail function. So these are the bottom 5 rules, guys. So this is the first rule over here, which tells us if someone buys alarm clock bake like pink, then he's also likely to buy alarm clock bake like red. So for this, the support value is 0.02 and the confidence value is 0.64. So the support value of 0.02 states that out of all the transactions, 2% of the times alarm clock bake like pink was bought. And if someone bought alarm clock bake like pink, then there was 64% probability that he would also buy alarm clock bake like red. Now let me go ahead and plot these rules. So plot of rule 3, I'm making a basic plot. Now we see that we can't really find some association with this, so these are quite scattered over here. So let's go ahead and make the 2 key plot now. Right, so I'm using the plot function. I'm making the plot for rule 3 and the method is 2 key. So we have 2 different colors over here. Yellow is for those rules where the length of the item set is 3 and the purple is for those rules where the length of the item set is 2. So now if we take these 3 dots over here, this is for yellow. So this is for all of those rules whose length of the item set is 3. And we see that the support value needs to be less than 0.02 and the confidence value needs to be greater than 0.7. Now let me make the third and the final plot. So this time the method is graph. So these are the different set of association rules which we have. Let me zoom in. So this is rule number 2, which tells us that if someone buys green Regency teacup and saucer, he is also likely to buy roses Regency teacup and saucer. So the confidence for this is 0.78. Now let me zoom back. So let me have a glance at rule number 19. So this tells us if someone buys Dolly Girl lunchbox, then there is 68% likelihood that he would also buy Space Boy lunchbox. Let's have a glance at this. So this is rule number 5. So this tells us that if someone bought alarm clock bake like red, then there is 60% likelihood that he would also buy alarm clock bake like green.
So now let's move on to the skills required to become a data scientist. So we'll be looking into all the set of skills that are required so that we can get an idea that what all certifications we need to do in order to become a data science professional. So let's go to this data analysis. First of all, a data science professional must be thorough with data analysis, and for this they should have knowledge of data science with R, that is R programming. So R consists of various libraries and packages that helps in statistical analysis of the data, visualization of the data, manipulation, and to perform exploratory data analysis. It also consists of various packages that helps in implementing machine learning algorithms. So it is a highly recommended language by the professionals and statisticians for various tasks of data science. Then comes Python, that is widely used for various development processes such as web development, application development, and it is comprehensively used in the field of data science, machine learning, and artificial intelligence because it consists of various numerous packages and libraries such as scikit-learn, pandas, numpy, and various frameworks that helps in data visualization, manipulation, exploratory data analysis, and also to build machine learning algorithms and models that helps in automation. After that, a data scientist must have knowledge of mathematics, especially calculus, linear algebra, and statistics. Then comes data visualization skills. So R, Python, SAS, and Tableau are widely used for data visualization tasks. So it depends on organization that whether they are comfortable with R or Python. Most of the organization uses Python and R for data visualization. Some uses Tableau, and SaaS is mainly used by companies who build high-end softwares. So it is a paid tool that consists of various special features for statistical analysis and visualization of the data. Then comes processing of big data. So a data scientist must be thorough with big data technologies such as Hadoop, Spark, Apache Kafka, and Scala. And finally, a data science professional must have knowledge of the fields of machine learning, artificial intelligence, and deep learning. So in this, they should be aware of various machine learning algorithms, which lies under the category of classification, regression, clustering, and boosting algorithms. So it completely depends upon the organization in which you are working or you are willing to work. So in which domain it is working. If it is a healthcare firm willing to hire a data scientist, so you must be aware of these clustering, classification, regression, and boosting algorithms so that you can classify the data of the patients. And next, if you are willing to work in a mobile phone company where you will be involved in developing mobile phone softwares, then you must be aware of NLP concepts and how to implement them, because nowadays mobile phones are coming with voice recognition technology and voice over search technologies. So you must be aware of that if you are willing to join a mobile phone company to develop the softwares of the mobile phones. And if you are willing to go in automobile industries, that is developing self-driving cars, then you must be thorough with neural networks and how to improve neural networks, as all the automobile industries who are developing self-driving cars rely on neural networks to ensure a safe drive. So it completely depends upon the organization in which you are working. So these are all the overall skills that a data scientist must possess in order to become a data science professional. After that, we'll see top 5 data science certifications that you must pursue according to the skill set that we saw in the previous section, that meets the industry requirements. So starting with the first certification, that is data science online training and certification, and this is basically for beginners who are willing to start with programming language. So first you should start with R programming, as we already saw in the previous section that R programming is recommended by the professionals and statisticians who are in the field of data science, who analyzes and visualizes the data in the daily basis. So this certification is very important for the beginners who want to build strong portfolio, and it also teaches advanced skills, that is it includes machine learning algorithms and various projects that helps to give a comprehensive hands-on experience to the learner. So this is an online certification training. So there are two types of training over here. So the first one is instructor-led live classes, that is led by highly trained and skilled industry professionals who are working in this domain from 10 to 15 years. And the next one is self-paced, that is prepared by our subject matter experts from the industry. So you can opt for any of these types of training, either instructor-led or self-paced. And the validity of the certification is lifetime. So in this certification course, you will learn the foundational skills as well as advanced level of skills that will help you to make a career in the data science field. Now the next one is Python for data science. So as we already know, Python is in every field. So Python programming is used for development purpose. Either it can be for web development, desktop application development, and it is extensively used in the field of machine learning, data science, and artificial intelligence. So you can go for Python data science course and certification by Intellipaat in both ways, either instructor-led live classes or self-paced training. So in instructor-led live classes, you will be trained by the instructor who are the subject matter experts from the industry, and in self-paced, you can watch the videos of data science professionals who prepared the course as per the industry standards. And the validity of the certification is again lifetime. So this course is specially designed for beginners who want to learn foundational skills as well as advanced skills along with Python libraries and implementing various machine learning algorithms, working on real-time projects. So learning Python will help you to nourish your implementation skills and work on various projects, real world projects, along with solving critical organizations generate zettabytes of data every day. So how do they process and evaluate and analyze this data? So it is with the help of big data technologies. So it consists of Hadoop, Spark, Scala, which helps in processing huge volumes of data. So a beginner who is willing to make a career in data science should have knowledge of big data tools. So this course will provide a foundational skill as well as advanced level of skills in the field of big data. So it also gives comprehensive knowledge of data analytics. So after pre-processing the data, helps data scientists to perform some analytics on the data that is processed. So it majorly consists of Hadoop, Spark, Scala, and in this online training you can learn by industry experts by opting for instructor-led live classes or self-paced training where you will be guided by the subject matter experts who prepare the course according to the industry requirements. So by learning big data and acquiring a certification in big data, you will be enhancing your skills of data analytics, because most of the organizations who work on building high-end softwares uses big data technologies that helps in processing of big data, which in turn helps in developing perfect algorithms for the software. So this certification, the validity of this certification is also lifetime. So it will help you to make your career and it will help you to work in a reputed organization. Now the next very important certification is machine learning training and certification. So Intellipaat provides machine learning training and certification course, which is one of the top certification course. So any beginner can take up this course and it teaches all the fundamentals along with the advanced level concepts, machine learning algorithms, statistics, various Python libraries that helps in developing various automated models. Also, you will work on some really interesting projects that will help you to nourish your skills. So the reason that this machine learning training and certification course lies under the category of top 5 certification for data science is that the task of a data scientist is not limited to data manipulation or visualization. It is also to build effective strategies and build algorithm that helps in automation of the software. So it becomes highly necessary for a data science professional to have a knowledge of machine learning, especially machine learning algorithms and various methodologies that helps in creating perfect algorithms for a software. So you must go for machine learning training and certification immediately after learning big data so that you can have a comprehensive knowledge of how industry projects really work. So validity of this certification is also lifetime and it will help you to enhance your knowledge of working in data science projects and encourage you to solve real world problems using data science and machine learning. Now the next important certification is artificial intelligence training and certification. So artificial intelligence is one of the very important field where it deals with creation of various neural networks that helps in creating automated models. So it is the part of data science field as many of the companies have started using neural networks for solving their real world or business problems. So in this course you can learn advanced skills as well as basic skills, deep learning algorithms, neural network, TensorFlow and deep learning framework. So this training and certification will help you to fine tune your career in the field of data science. Also, this artificial intelligence certification will add a high value in your resume while you are going for a data science interview. So these are the top 5 certification that you must pursue in order to make a career in the field of data science.
Alright, guys. To come to the first point of the agenda, it's what's trending in the world of data science right now. Well, here's a very simple Google Trends picture for you guys, and from the graph, you can pretty much see that right from the inception of data science, all those years ago until now, until 2019, 2020, all you can see is a very steep and a steady increase in the graph. Well, to me and to all the enthusiasts around the world today, this means only one thing. It means that data science had a very strong foundation in all of these past years, and now it's going to see nothing but a raise compared to all those previous years and those previous numbers that we've been seeing. And this directly correlates to it becoming a $1 billion industry very, very soon. I mean, of course, there are already top companies in today's world who have invested everything in their power to make sure they leverage data to be the best. And these graphs do prove the same. And the best thing is that nowadays, with the help of data science, there is more emphasis given to the actual problem solving procedure. See, data science came into the picture when there were certain problems which needed to be solved and people were hunting for a solution. And now, since data science is far away from its inception and it is pretty much deeply embedded in every company, the employers now face a situation where they can put all of the manpower, all of the energy into actually solving the problem rather than understanding what they could have done, or pretty much to see if the data was useful or useless. They're beyond all of that now. Pretty much ensuring that you put greater emphasis on problem solving will relate directly to increased profits, increased revenue, and of course at the end of the day, better efficiency for the company overall. Coming to the next point, it's pretty much understanding that artificial intelligence has been implemented so subtly these days that we don't even notice it's there anymore, right? So think about it. When you open your smartphone, when you unlock your smartphone, there's artificial intelligence working. When you say hey Siri, when you say hey Google, all the way to opening Google Maps, using Google Translate, Tesla's autopilot system, or whatever it is, pretty much there is a huge rise in the AI driven systems in today's world. And this at the end of the day increases all sorts of design complexities as well, because when you think about it, it's not really simple to achieve artificial intelligence. It requires a lot of data, and when there is a requirement for a lot of data, it comes with the task of pretty much handling all of this data at every point of time. So here is where again the world looks to data science to ask for its help. And when we have to talk about how AI is being again put into our lives, think about robot intelligence, think about any form of artificial intelligence that makes it easy. Everything from Roomba. Roomba is basically the housekeeping robot which pretty much goes around sweeping your houses as well. So all the way from that to right to bringing it to your watch, to bringing it to your necklaces and whatnot, artificial intelligence is right there to pretty much be implemented in our daily lives in all of these low cost low powered devices. For example, a smartwatch battery, many of the companies do say that they can last 20-25 days, and of course to achieve this they have to use low power. And then to use low power doesn't mean that they're compromising on stuff, right? At the end of the day, it's very intelligent, or even the most simple smart bands of today. So once we understand all of this, once we know that data science is the thing right now, data science is the future right now, and of course I would urge all you dear viewers to pretty much jump on this trend train to make the best out of it. It can be a career, it can be those dream jobs that you guys are looking for, or if you're just enthusiasts who are willing to learn it in a very dedicated way, this is the right time to get into data science. And on that note, what are the prerequisites that are put into place for you to get into data science? Well, the first question I get asked every time we talk about data science or helping anyone, helping a nascent member in this pretty much technology to get into data science, the first question I get asked is them asking me, hey, how important is my degree? I'm coming from a financial background, I'm coming from a banking sector, I'm coming from multiple places which might not be computer science per se. So, what is my scope in data science? Well, guys, as you can see on your screen right now, I've put out three of probably the world's biggest companies right there. Everyone from IBM, Google, Apple, Tesla, Bank of America, Hilton. Well, all these guys have stopped looking at people in their degree perspective. So what I mean by this is when they're hiring, degree is no longer a criteria for these guys. So you might be wondering, okay, if they're not looking at degree, then what are they looking at? Well, let me tell you this, if they're not looking at your degree or where you're coming from, they would of course need another way where you can prove to them that you're actually good at what you do and for the role that you're applying. This comes with you generally, your knowledge, your learning. You might be a person who's working a finance day job, and at the end of the day or at night, you might be a very hardcore coder who's pretty much putting in all of the hours, all of the efforts to actually get yourself a name in the world of coding. Well, if you're one of these guys, or if you're interested to be one of those guys, or in general, even if you don't have a degree related to computer science or mathematics, it doesn't hurt in today's world, because if these big companies, in fact even the startups, have pretty much gone the same route now. They really don't care if you have a degree or not. All they want to see is if you have the skills to take on the job and how well you are at what you do. So that comes to the question where, okay, so a degree is not that important, but of course it always helps. So what about certifications? Well, guys, let me tell you something about certifications. All these big companies, right? So when you don't have a degree, you need to substantially prove to them that you have the skills. So this can be done, well, pretty much using certifications, because it is one of the key documents for your resume. It is like a stamp of excellence to prove to your employer or prove to any interviewer around the world, saying that, hey, I have put in all the work that is required and I am certified by this reputable organization to pretty much do this. And at the end of the day, this directly relates to you getting hired by them, because they know if you're certified by a reputable company, at the end of the day, these guys will have an assurity that you know what you've done and that you're certified well, because you have actually done the job, put in the hours, and learned everything there is to learn. And the most important thing that you need to understand right now is that this will give you a substantial increase in pay. Yes, of course, you might think that 20 to 30% hike is a usual thing that you might get away with. Well, with respect to a good certification, absolutely not. You can pretty much double up your salary right from then and there, even though you might be just jumping in the same domain, switching your career, or doing something entirely different. So guys, understand this point, that substantial increase in pay is something very important. It is there, and at this point of time, I'd like to tell all my dear viewers that I want you guys to pretty much make use of this fully as well. And of course, sometimes you will have corporate requirements which need to be cleared. For example, see, when you think about cloud computing technologies like AWS, Amazon Web Services, they do have certain examinations that you have to clear, and clearing these examinations are not really simple. So I'm sure you guys could use some training in that particular field, where you're prepared for that examination, you clear the examination in one shot, and then you prove to, again, prospective employers and interviewers that you've actually put in the work, by picking up a program which actually taught you end to end about what you need to do for that exam. You clear that exam, and this shows that you're dedicated, you have a structured way of learning, and much more. And so it's not all about the money or getting that right job. Ladies and gentlemen, a good certification program will give you all the knowledge that it is that you have to take, and they ensure you're working on. But the most important thing here is that you have to have the hands-on experience. You need the assignments, you need the projects, and you need everything else that will basically add to your knowledge, to put on a strong foot, saying that yes, you have worked on it, and here is what I've done, and I'm good at this. So ladies and gentlemen, I hope you guys really understand the situation at hand out here. It's not all about learning every time, it's about implementing something and solving the problems in today's world. And that can be done when you bring the best of both worlds with respect to knowledge and projects. So, what are the prerequisites to become a data scientist in today's world? Guys, there are multiple things and multiple approaches you can take to become a data scientist, and here's my view on that. You can start out with understanding machine learning, find out where machine learning is used, why the world requires machine learning, what machine learning actually is, and more. Because with respect to machine learning, the world is doing multiple things in today's world. It's helping so much. In fact, even in our battle right now with the coronavirus, machine learning has shown immense progress, and people around the world are leveraging that. And of course, we have neural networks as well. With respect to neural networks, they are directly trying to implement and imitate a human brain, the neurons in our cognitive brain. So pretty much we're trying to make sure we put that down to the computer, try to make it a little intelligent, make it think for itself, and do our tasks faster for us. So that is neural networks. And then statistics, of course. If you're a data scientist,
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
statistics is going to be a key thing. At the end of the day, if I have to put it in very simple terms, data science is all about bringing together mathematics and code. So ladies and gentlemen, with statistics, concepts such as probability, concepts such as correlation, and much more play a very vital aspect here. And then if you have to talk about programming languages, I just mentioned, okay, so we have Python, we have R, we have multiple other languages which are beautiful to work with, and Python and R are in fact one of the top languages in today's world to learn. These languages are mostly used to go on to achieve machine learning, to achieve deep learning, to achieve good working of neural networks, and all of this correlates to what? Well, it basically correlates to achieving artificial intelligence when you think about it, ladies and gentlemen. And then coming to cloud computing, of course. So, all the computing power that comes from today's world is not exactly computers sitting at everyone's home. In a world where we're surrounded by data, in a world where we're surrounded by all of this information, it would be really tough to hoard information with respect to each and every system out there. So, the world of cloud computing helps us here. We can move all of the data to a cloud computing solution where you can have someone else manage the data for you while you have complete control over it. And as a data scientist, since you'll be seeing a lot of data, this is something which is very important, because scaling the data to the clouds, well, that's an advantage for this decade and the coming decades for sure. So let's say with respect to distributed computing, there are tools like Apache Spark which pretty much help you scale one network into multiple nodes, where instead of drawing the computing power of just one machine, you can make use of multiple machines. So at the end of the day, if you can make sure your data can be handled by multiple systems at the same time, well, of course, it's a win-win for you, your organization, and everything around that as well. So in my opinion, these 6 components form the very major foundation of the prerequisites when you have to talk about you guys becoming data scientists across the world. So guys, in your opinion, what do you think about these prerequisites? As always, let's keep this session very interactive. Make sure you head down to the comment section below and do let us know what you think about this at the same time. So on that note, alongside all of the primary things that we discussed, is there anything else? Well, of course there is. As a data scientist, you will need very good verbal skills, you will need very good communication skills, because at the end of the day, it's just not you working with data, it's you working with data from various teams across a spectrum of teams in your company. It can be everyone working with the data ingestion team, it might be the data visualization team, or whatever it is, because at the end of the day, if you have the right communication skills, you can become a good data scientist. And then team working ability, just like I mentioned, it complements to my last point, because when you think about it, team working is very important, because in the morning you can be working on how to bring in data into your company, in the afternoon you can actually be working with that data, and the evening you can sit with the team pretty much to visualize all the data and much more. So as a data scientist, you'll have varied responsibilities throughout the day, and ensuring that you can go along very well with the other teams and work with them together is a very big skill to have, ladies and gentlemen. And of course, you'll be interested in collecting data and analyzing data as well, because why else would you want to become a data scientist? Sure, it pays really well, it is the number one career in today's decade, but ladies and gentlemen, you need to have that kind of a calling towards data. You need to have that kind of a calling to ensure that you want to solve problems across the world today in a very nice way, in a very interesting way. And this directly correlates to you understanding how to collect data, how to work with data, and eventually solving these problems. Solving these problems again directly correlates to having good problem solving skills. Well, at this point of time, do not worry, ladies and gentlemen, if you do not have very good problem solving skills right now, you can be trained and of course be on your way to become a very good data scientist. Well, make sure to stick till the end of the video and I shall guide you on the same. And of course, education knowledge is only preferred, it's not a compulsion in today's world. As I said, pretty much, it would always give you an edge, it would always give you an advantage of having a degree in computer science, information technology, mathematics, statistics, or any sort of work experience in a related field to this. Is this compulsory? Again, I'm reinforcing, absolutely not. You can get away with a good certification program, you can get away if you have the right calling for data, as I just mentioned, and pretty much, if you understand everything thoroughly, a degree is not needed. But again, it won't hurt to have one. And of course, you might be thinking, whoa, okay, that's a lot of skills, that's a lot of primary skills, it's a lot of secondary skills, what's going on? Well, ladies and gentlemen, again, the most important thing, guys, please pay attention to this slide, because this is the most important thing that I can tell you. It's all about focus when you talk about data science, because you cannot become an expert in all of the 6 concepts that I showed you. Then you will have to pick up something and you'll have to go through with that. See, for example, you're interested in natural language processing, you're interested in neural networks, or you're interested in data visualization. So you have to pick your focus area to work with, and then ensure that you build upon that. You start with something which of course you might or might not know, and then you build on it. So this calls for you understanding, of course, all of the 6 primary skills to a certain beginner level. But then when you have to get proficient, you need focus and you need that tunnel vision to ensure you pick up one thing and you are a master in that, ladies and gentlemen. I hope that point was clear. So with that, you might be asking, okay, so what is important as for a data scientist? Well, here is a beautifully put together image that conveys the same. See, programming tools, again, as I mentioned, Python and R are very important for a data scientist. Visualization and communication skills, as I mentioned, of course, very important. Data intuition, looking at data and understanding it, having a knack for data, very important. Statistics and mathematics, as I told you guys, it is pretty much top notch as well. And skills like data wrangling and machine learning, of course, form the foundation of a data scientist. So it is very, very, very important. So what about the skills such as, software engineering or calculus or linear algebra or all of these things? Well, guys, it is somewhat important, all right? It's not like without these you cannot do any of the data science tools or you cannot work with any of these programs. Well, no, pretty much without these as well, you can become a good data scientist. But it's important. It's needed now and then, but then not really to the frequency that you might actually think. So I hope it clears with all of the prerequisites and how you can go on to attack these prerequisites and become a data scientist. Let us check out a couple of job descriptions. Here's one from Spotify who are looking for data scientists right now. So they say that you need to have the ability to basically solve loosely defined problems, come up with insights, and pretty much drive any product development based decisions. You need to have a deep understanding of statistics, we discussed this, and you need to have experience working with real world data. Again, a good certification training program will give you all the real world data experience that you need. And of course, technical skills, as I told you, coding skills is required, Python, Scala, R, SPSS, and of course, SQL is a very good analytics tools as well. Database technologies, here we go. And of course, when you think about working with statistical competence, as I told you, all of this will come in statistics and machine learning, regression modeling, A/B testing, significance testing, and much more, guys. So Spotify also say that you need to have hands-on statistical modeling. You need to have the knowledge about machine learning, concepts such as classifications model, clustering techniques, predictive modeling, decision trees, and much more. So everything that we have discussed until now correlates directly with the requirement of Spotify. So let's try to see if we can further amplify that. Here's a job description from the people at Nike. Well, even the people at Nike believe that, as a data scientist for them, you need to be able to build some business insights for them. You need to have the skills to master all of the big data fundamentals. You need to understand how to gather the data, how to clean the data, validate very, very large amounts of data on their cloud platform. Again, to work on the cloud platform, here you need the big data skills and you need the cloud computing skills as well. And they say that, you need to create pipelines and production queries with their data warehousing. We discussed data warehousing and it's needed as well. And they say you need to possess the character and have continuous improvement throughout the projects by making use of concepts, such as automation, process enhancements, and much more. And at the end, check out the last point, ladies and gentlemen. They say, of course, you need to create reports, visualizations for all the core app features, and in fact even marketing campaigns by making use of these visualizations, because at the end of the day your communication skills will matter here. Why? Because you'll be taking all of these technical results and concepts and explaining it to a non-technical audience, right? Guys, think about it. So all the points that we have discussed, we've put a strong footing on how you can actually go on to become a data scientist. So coming to the average salary of a data scientist, it's an amazing number. So basically a data scientist in the USA gets paid somewhere over $132,000 per year, and in India it's over 18 lakhs per annum, and in the UK it's 65,000 pounds a year. So these are just the average numbers considered by putting in all the lower thresholds and the upper thresholds as well. I mean, I have a lot of friends who earn a lot more than you see on your screen right now. But then to keep it to the scope of all the viewers, we have decided to keep in the average numbers on the screen, guys. So in fact, you should not feel dejected, because these are great salary numbers, and of course, this is the most lucrative career in today's world, which is data science. So you guys have to be very excited, and you need to keep your bars up very high to actually, understand and get to the salary. So what do you guys think? Again, head on to the comment section and do let me know. So on that note, pretty much you can be asking, okay, so who's hiring across the world if it's this popular, right? Well, look on your screen. I have tried to fit in all the companies that I can, and I did not have space to fit in any more companies in one slide, ladies and gentlemen. Every social media site that you can see right now, Instagram, LinkedIn, Pinterest, Viber, WhatsApp, Evernote, people at Android, Twitter, WeChat, Facebook, YouTube, Vimeo, Amazon. Well, I'm trying to name all of these guys. So all these guys again are hiring data scientists on a daily basis. In fact, companies in India as well, such as Edgeworth, they're an Infosys company. They have Oracle, Siemens. We have Ola, Mu Sigma, Unisys, Fractal Analytics, Ernst and Young, IBM. All of these guys are again they're looking for data scientists. And as I told you at the beginning of this presentation, there is a huge gap in between demand and supply, because in today's world there is a huge demand for data scientists, but the supply for experts are very less. Supply for expert data scientists. So to fill all of these gaps, we are pretty much trying to get you guys on the roll to ensure you get your dream jobs. In fact, Skype, BBC, Google, Adobe, Best Buy, Apple, Walmart Labs, everyone you think of, just ensure to head to their website and check out their careers page. They will of course be hiring for a data scientist, because that is the need of this hour, that is the need of this decade, ladies and gentlemen.
What is the difference between data science and data analytics? Well, the first main thing that you need to know is that, while many people actually, change around these terms, data science and data analytics, and use it together, there is a very keen difference, because the main difference, in my opinion, is the scope in which data science, spreads its wings in, and data analytics is good in. So we can consider data analytics to be a part of data science, guys. So data science is the umbrella, and the data analytics is a part of that. So coming to the differences, well, data science is a complete umbrella term for a group of fields, again, which is basically used to mine large data sets, which basically means that we'll be, looking and hunting into large data sets and driving meaningful insights from them. But at the same time, data analytics is a more focused version, which is basically, considered to be just a larger part of the entire process, because at the end of it, all the data collected by the data scientists can be used by the data analytics team to pretty much go about doing visualizations, analyzing trends, and so much more. So coming to the next point, it's pretty much think bigger picture, think data science, because data science isn't concerned with answering any specific queries with respect to a specific set of data. It works its scope in a very wide way. But when you talk about data analytics works extremely well when you have a small scope to work with, when it is focused, and the questions which need the answer to. And these questions, the answers that you can derive from these questions are basically from the existing data which is already present. So this is another simple difference between data science and data analytics. Coming to the next one, well, data analytics is all about the present data and the future. Well, let me tell you, again, data science pretty much, produces broader insights, as we've been talking about, and, that you should concentrate on the questions which should be asked based on the past data, where you can mine the data and make sense of it. This is the data sciences team. But then coming to data analytics, here we basically we basically drive into discovering answers to questions that are being asked at that very moment, at that very instant, to drive something in the present, or to produce a trend or an analytics for the future, guys. So again, when we've been talking about scope, here's a quick reminder slide for you guys. Data science has a vast scope, it has a macro scope, while data analytics is more preferred for a microscope. So what this basically means is that data science is a more vast field, and so we've already spoken about how data analytics come under data science. So data analytics is used to do a certain set of tasks really well, and a data scientist can also go about doing all of these tasks as well. But then there are many other tasks for data scientists that a data analyst cannot do, and this brings us to the goal. Well, the goal of the data science field is basically to ask the right questions and get the right answers from the data. But then the data analytics goal is to pretty much find some actionable data where you can make sense out of it, and drive business decisions and more. And this brings us to all the major fields that we can go about using. You might have heard of the term data science in majority of the fields in today's world. Well, it is used in machine learning, it is used to achieve artificial intelligence, search engine engineering, corporate analytics, it is used in the field of medicine as well, it is used in the field of manufacturing, and so much more. Data science has its foot deep in today's world of technology. And coming to data analytics has been a boon to the field of healthcare, to the field of gaming, travel, a lot of other industries, again, manufacturing industries too, where the data requirement is immediate, and the analysis and the analytics which goes with it is also immediate, guys. So this brings us to the question whether data science and data analytics are the best of both worlds. Well, think about it this way. The two fields basically, can be considered as two sides of same coin, because again, when you think about it, it's one coin where their functions are extremely highly interconnected.
but then there are two faces to the coin where they are actually a bit different from each other. And this brings us quickly to check out the skills of a data scientist and a data analyst, guys. So basically, a data scientist, as we have discussed, pretty much works with all the data he or she gets and applies a lot of mathematics on it, applies a lot of statistics on it, and so much more. To do that, the primary skill that a data scientist requires is pretty much having a strong knowledge of languages such as Python, R, SAS, Scala, and so much more. And the second thing is pretty much knowing how the person can work with unstructured data, because at the end of the day, a data scientist can be working with images, can be working with videos, can be working with music, or text data which is unstructured, and so much more. And then this brings us to some backend development where the person, the data scientist, needs to have some knowledge over backend development with respect to databases, data warehousing, handling data on the backend, and making the backend talk to the front end as well, guys. And this brings us to the fourth skill, which is basically having the knowledge of machine learning and sometimes deep learning as well. Because at the end of the day, we can use machine learning and deep learning and all of these concepts to achieve artificial intelligence and make the data a little smarter. This brings us to the skills that make a data analyst. Well, a data analyst basically works with the data he or she gets, and at the end of the day creates beautiful visuals out of it, gives us future trends, predictions, and so much more. Having the knowledge of statistics is one of the most vital skill for a data analyst, but then having very good statistical skills without implementing it in the world of computer science would not make sense. Hence, a data analyst would also be benefited if he or she knew a bit of programming in terms of Python or language such as R as well. Then coming to data wrangling, again, we've talked about data and we know how data can be so much messy, especially if it's unstructured, or data can be a very unruly entity, if you may. So data wrangling is again basically picking up all the data that you particularly require in a hunt. It's like hunting for a needle in a haystack, and data wrangling is pretty much something similar to that as well. And a good data analyst will have very good data wrangling skills, guys. And then at the end of it, a little bit of big data technologies are needed as well. You need to have knowledge of big and technologies like Hive and more. So to bring it all in one single gist, here is on the screen. So basically, a data scientist is responsible for working all of the raw data and converting it into valid information. A data analyst will be basically performing prediction and presenting all of these informations to clients and peers. Where think about this scenario where a data scientist gives lots of numbers to data analysts, and then a data analyst is a person who can figure it out. He can convert the numbers into graphs. But then when you're going into a business meeting or you're going into, say, a board of directors meeting, giving them the numbers, they might not be able to make more sense of it. So basically, you convert these numbers and make them look into beautiful visuals, very good graphs, pie charts, and whatnot. And all of these eventually can make sense, because at the end of the day, a part of the data analyst's job is to basically convince a person who doesn't know the technology eventually about the data that they have been working on.
Now we have our second question over here. So on the same diamonds dataset, we are supposed to make a scatter plot between the price and the caret. And we are supposed to do that using the ggplot2 package. So over here, the price needs to be on the y-axis and the caret needs to be on the x-axis. So this column, it needs to be on the x-axis, and then we have price. This needs to be on the y-axis. And the color of the points need to be determined by the cut value. So again, let's head back to R and let's implement this. So again, to implement the scatter plot using ggplot, we are supposed to load the ggplot2 package. Alright, and this would be a command to make that particular scatter plot. So ggplot2 is something which is based on grammar of data visualization. So ggplot helps us to stack multiple layers on top of each other. So first off, we'll start with the data layer. On top of the data layer, we'll stack the aesthetics layer. And on top of the aesthetics layer, we'll stack the geometry layer. So first, we have the data layer where we'll give the name of the data frame to this data attribute. And we are working with the diamonds data frame. So the first layer is diamonds. After that, we will map these columns onto the aesthetics. So using this aesthetics attribute inside this ggplot function, I will map this caret column to the x aesthetic, and similarly I will map this price column onto the y aesthetic. And as the question stated, the color of these points need to be determined by the cut column. So again, I'm reiterating it. Caret is mapped onto the x aesthetic, price is mapped onto the y aesthetic, and cut is mapped onto the color aesthetic. And once these two layers are done, we are supposed to build the final layer, which is basically the geometry. And since we are supposed to make a scatter plot, we'll be using the geom point geometry. And this gives us the required scatter plot. Let me zoom this. So as we see over here, price is mapped onto the y-axis, caret is mapped onto the x-axis, and these colors which you see, these basically denote the different cut values. So yellow, it denotes the ideal cut, and this purple which you see, that denotes the fair cut. So you see that if the cut is fair, then mostly the price of the diamond is higher and also the carat value is higher. And when it comes to the ideal cut, we see that the carat range of the ideal cut, it starts from 0 and it's mostly till 3 or 4. So this is the sort of interpretation which we can make from the scatter plot. And then we have our next question. So this time we are supposed to introduce 25% missing values in the iris data set and impute the sepal length column with the mean, and similarly impute the petal length column with the median. So this is the iris dataset. So again, let's head back to RStudio and perform these tasks. Let me have a glance at the iris dataset first. View of iris. So this is our iris dataset, which comprises of these 5 columns. So we have sepal length, sepal width, petal width, and species. And our first task is to introduce 25% missing values in this entire dataset, and that'll be totally random. And to introduce missing values, we'll be using the Miss Forest package. So let me load the Miss Forest package using the library function. Now, this Miss Forest package comprises of this prod any function. And using this prod any function, I'll be introducing 25% missing values. So this basically takes in 2 parameters. First is the data frame or the object into which we are supposed to introduce missing values. The second parameter is the percentage of missing values that we'd want to introduce. So in this iris data frame, we are supposed to introduce 25% missing values. So I'll give the value of 0.25 and I'll store this in a new object and name that object to be iris.mis. Now let me have a glance at this modified dataset. View of iris.mis. So this is a new data frame which comprises of 25% missing values. Now I'm supposed to impute this sepal length column with the mean and similarly this petal length column with the median. And to impute those 2 columns separately, I would require the HMISC package. So I'll load this package now. Library of HMISC. And this package comprises of the impute function, with the help of which I'll be imputing different columns. So first I'll use the width function, and this takes in 2 parameters. First is the data frame, which consists of missing values. So in this data frame, we are supposed to impute the missing values. So this is the iris.mis data frame, and this is the first parameter. Next, we'll use the impute function, and inside the impute function, again, it takes in 2 parameters. First is the column which we want to impute. Next is the function by which we want to impute this column. So I want to impute the missing values in the column with the mean of this column. So wherever you see any values in this column, all of those values would be replaced with the mean of this column. And I'll store the result back to this column, which is iris.mis $sepal length. I'll hit enter. Now let me have a glance at this imputed dataset. So view of iris.mis. So you see that wherever we had the any values, all of those values have been imputed with the mean. So this 5.85562 which you see, this is nothing but the mean. So initially there was an any value over here and that has been imputed with the mean. Similarly, there was an any value over here and that has been imputed with the mean of this column. Next, similarly, we are supposed to impute this column with the median of this column. So let us do that. So again, I'll use the width function and then pass in this data frame with the missing values. After that, I'll use the impute function and I am supposed to impute this petal length column, and the imputation would be done with the help of the median function. So wherever there are any values, all of those any values would be replaced with the median of this column, and the final result, I'll store it back to the same column. I'll hit enter. Now again, let me have a glance at the modified data frame. So view of iris.mis. So this is a modified data frame. So this 4.2 which you see, this is nothing but the median of this column, right? So wherever there were any values, those any values have been replaced with the median of the petal length. Now let's head on to the next question. So what do you understand by linear regression? Well, linear regression is a supervised learning algorithm which helps us in finding the linear relationship between two variables. So one is the predictor or the independent variable and the other is the response or the dependent variable. So we try to understand how does the dependent variable change with the independent variable. So linear regression is a supervised learning algorithm which helps us in finding the linear relationship between two variables. So one is the predictor or the independent variable and the other is the response or the dependent variable. And we try to understand how does the dependent variable change with the independent variable. So let's say there's this telecom company called as Neo. And now the data scientist at this company wants to understand if there's a linear relationship between the monthly charges incurred by the customer and the tenure of the customer. So he collects all of the data and builds a linear model between the monthly charges and the tenure. So here, monthly charges would be the dependent variable and tenure would be the independent variable. And in linear regression, there could be more than one independent variable. So if there's just one independent variable, it is known as simple linear regression. And if there's more than one independent variable, it is known as multiple linear regression. So guys, this is the underlying concept of linear regression, where we have one dependent variable and multiple or a single independent variable, and we try to understand the linear relationship between the dependent variable and the independent variables. So next, we're supposed to implement this simple linear regression in R on this empty cars dataset, where the dependent variable is this MPG column and the independent variable is this displacement column. So again, let's head back to RStudio and implement the simple linear regression. So this is our empty cars data frame, which comprises of all these columns. So we have MPG, the number of cylinders, displacement, horsepower, DRAT, weight, cubic, VS, AM, gear, and carb. So as the question stated, MPG is our dependent variable and displacement is our independent variable. And we want to try to understand how does MPG vary with respect to the displacement of this column. So now, before we go ahead and implement the model on top of this data frame, we are supposed to divide this data frame into training and testing set so that the model does not overfit the data. So what happens when we don't divide the data set into training and testing sets is it overfits this data set. And when we give it new data, it'll fail miserably on that new data. So that is why it is always necessary to divide a data set into train and test sets. So let's go ahead and do that. And to divide a data set, we would require this caret package. So let me load up this caret package, library of caret. And this caret package comprises of the create data partition function. Now, this create data partition function would give me true or false labels. And this create data partition function comprises of these parameters over here. First is the column which determines the split. So that is obviously the MPG column. And then we are supposed to give in the split ratio. So I am giving the split ratio would be 0.65. That is 65% of the labels of this column would have the true label and the rest 35% of the records would have the false label. And I am storing this into the split tag object. So again, I'm reiterating it. So I am taking this empty $MPG column data set and 65% of the records would have the true tag associated with it and the rest 35% of the records would have the false tag associated with it. And I'm storing this result in split tag object. Now, once I have the split tag object ready, what I'll do is from this entire empty cars data frame, I'll select all of those records where the split tag value is true and I will store those records in the training set. Similarly, from the empty cars data frame, wherever the split tag value is equal to false. So if I just give in split tag, it'll have all of the true values in it. And when I put in the minus symbol in front of the split tag object, it'll contain all of the false labels. And I will select all of these records and store them in the test set. So now we have our training and testing sets ready. Now let's have a look at the number of rows in training and testing set. So I'll type in n row of train. So see that there are 23 rows in the training set. Similarly, I'll type in n row of test. And now we see that there are 9 rows in the testing set. Now we'll go ahead and build a model on top of the training set. And to build the simple linear model, we would require the lm function. This lm function again takes in 2 parameters. First is the formula. So over here, the formula is mpg tilde symbol displacement. So whatever column we give on the left side of the tilde symbol, that is taken as the dependent variable, and whatever columns we give on the right side of the tilde symbol, all of them are taken as the independent variables. So this time mpg is our dependent variable and displacement is our independent variable, and we are building this model on top of the train set. And we'll store this result in mod underscore empty cars. So now that we've built the model on top of the train set, it's time to predict the values on top of the test set. So for that purpose, we'll be using this predict function, which again takes in 2 parameters. First parameter is the model which we've built, and the second parameter is the data frame on which we want to predict values. So we want to predict values for the test set, and I will store this in predict empty cars. Now let me have a glance at the predicted values. So head of pred empty cars. So these are the predicted values of MPG for all of these cars. So Mazda RX-4 WAG, the mileage predicted for this car is 22.55. The mileage predicted for Valiant is 20.04. The mileage predicted for Mercedes is 18.08, and so on. So this is how we can build a simple linear model on top of this empty cars dataset. So now we'd have to calculate the RMSE value for the model built. Now when we actually build a regression model, it predicts certain Y values associated with a given X value. But there always is an error associated with this prediction. So to get an estimate of average error during prediction, RMSE or root mean square error is used. So again, let's go ahead and calculate the RMSE value for the model which we've just built. So now that we have the actual values and the predicted values, let's bind both of them into a single data frame. So for that purpose, I will use the cbind function, and our actual values are basically present in this MPG column from the test set. And our predicted values are stored in this pred empty cars object, which we had created in the previous question. So I will create this new column and name that column to be actual. And again, similarly, I'll create another column and I'll name it as predicted, which would have the predicted values. And I will store this in a new object and name that to be final data. Let me have a glance at it. View of final data. So these are the actual values of all of the mileage, and these are the predicted values of the mileage for these cars. Now we see that there is an error present in the prediction. Now what we have is actually a matrix. So we are supposed to convert this matrix into a data frame. So I will use the as.dataframe function and convert this object into a data frame. So as.dataframe, I'll pass in this object, which is final data, and I'll store the result in final data again. Now I'll have a glance at the same thing. View of final data. So these are the actual values, these are the predicted values, and we see that there is an error present in the prediction. Now the error is basically the difference between the actual values and the predicted values. So let's go ahead and calculate the error. All I have to do is subtract the predicted values from the actual value. So it'll be final data $actual minus final data $predicted. And I will store this result in a new object and name that object to be error. So now that we've done this, I will also go ahead and bind this error calculated to the same final data frame. So cbind, I'll bind the error object to this final data and I'll store the result in final data again. So it'll be view of final data. So this time we have the actual values, we have the predicted values, and we also have the error in prediction for each of these records. Now to get the average error which is present throughout all of the predictions, we would have to calculate the root mean square error. So the root mean square error, as the name states, first we'd have to calculate the error, then we'd have to take the square of it, then we'd have to take the mean of it, and then finally we'll take the square root. So this is how we can calculate the root mean square error. So final data $error, and we'll square this error first. After that, we'll take the mean of this squared error, and then finally we'll take the square root of the mean squared error. So this is what we have. So the RMSE value for this model which we built is 4.33. Now you guys need to keep in mind that the lower the value of RMSE is, the better the model. So let's say if we had some other model and the RMSE value for that model was 5, then this model would be better than that model. Similarly, let's say if another model's RMSE value was 2, then the second model would be better than the model which you built. Now similarly, we are supposed to implement simple linear regression in Python on this Boston dataset, where the dependent variable is this MEDV column and the independent variable is the LSTAT column. So now in the data science interview questions, it's not necessary that you'll be asked questions only with respect to one programming language. So you might be asked questions with respect to R and Python, both of them. So that's why it's necessary to be good with both of these languages. Right, so I'll head on to Jupyter Notebook and implement simple linear regression on top of this Boston dataset. So I'll start off by loading the pandas package. So I'll type in import pandas as PD, and then I'll load this Boston dataset, and to load the dataset I'll be using the read_csv function. So pd.read_csv and the name of the file, which is boston.csv, and I'll store this in the data object. So now that we've loaded the data, let me have a glance at the head of this data. So these are all the columns and the first 5 records present in the data frame. So we have Crim, Zn, Indus, Cas, Knox, Age, and so on. And for the task of simple linear regression, MEDV is our dependent variable and LSTAT is our independent variable. So this MEDV is basically the median value of price of the houses. And we are trying to understand what is the median value of the price of the houses with respect to this LSTAT column over here. Now, before we go ahead and implement the model, let's understand the dataset a bit more. So I'll use this data.shape, which would give me the number of rows and columns present in this data frame. So we see that there are 506 rows in total and 14 columns in total. Now I'll go ahead and separate the independent and dependent variable from this entire data frame. So for that purpose, I'll use this data.loc, and since I want all of the records, I'll take all of the records, and the only columns which I want from this entire data frame are LSTAT and MEDV. And I'll store this result in data1, and I'll also have a glance at the first 5 records of this data frame. So these are the first 5 records of this new data frame where I have only LSTAT and MEDV columns. Now I'll also go ahead and do a bit of visualization with respect to these 2 columns. And for that purpose, I would require the matplotlib package. So I'll go ahead and import this matplotlib package as well. So here what I'm doing is, I am mapping the LSTAT column onto the x-axis and the MEDV column onto the y-axis. And I will give the label of the x-axis as LSTAT and the label of the y-axis as MEDV. And finally, I'll show this graph which I've built. So what I've built is basically a scatter plot where MEDV is on the y-axis and LSTAT is on the x-axis. So you see that as LSTAT increases, MEDV decreases. So there is an inverse relationship between MEDV and LSTAT. So again, I'm reiterating it. As LSTAT increases, MEDV decreases. So this tells us that there is an inverse relationship between MEDV and LSTAT columns. Now, to build the model, we are supposed to separate the independent variable and dependent variable into 2 separate objects. So I'll take this LSTAT column from data1 and store it into X object. Similarly, I'll take this MEDV column from data1 object and store it in Y object over here. So X consists of my independent variable and Y consists of my dependent variable. Now it's time to divide the data set into training and test sets. So we have this train test split function from sklearn.model_selection. I'll go ahead and load that function, and this function over here takes these 3 parameters. So X and Y are basically the dependent variable and the independent variable, and then we have test size is equal to 0.2. So this states that 80% of the records would be in the training set and 20% of the records would be in the testing set. So it's a 80-20 split. And this random state which you see, so this is basically a seed value, so that if I want to get the same values again, I can set the same random state to get the same values. And I am storing these values in xtrain, xtest, ytrain and ytest. So xtrain contains all of the train values for that independent variable. Xtest contains all of the test values for the independent variable. Similarly, ytrain contains all of the train values for the dependent variable, and ytest contains all of the test values for the dependent variable. So now that we have xtrain, xtest, ytrain and ytest, it's finally time to build the model. So I'll go ahead and load the linear regression model from sklearn.linear model, and then I'll fit the model. So first I'll create an instance of this. So linear regression, and I'll create an instance and I'll name that instance to be regressor. And with the help of this instance, I'll fit the model on top of the training set. So regressor dot fit, and I will pass in xtrain and ytrain. So to sum it up, what I'm basically doing is building the linear regression model on top of the training set, which basically comprises of the independent variable and the dependent variable. I'll click on run. Now let me have a glance at the intercept and the m value of it. So linear regression is nothing but y equals mx plus c. And that c is nothing but the intercept. So you see that the intercept is 34.12. And m, which you see, this is the coefficient. This coefficient is nothing but the slope. And you see that the coefficient is minus 0.91. So there is a negative value associated with the coefficient because there is an inverse relationship between the dependent variable and the independent variable, as we saw over here. So as LSTAT increases, MEDV decreases. And that is the reason this coefficient is associated with a negative value. So now that we've built the model, it's time to predict the values on top of the test set. So again, I'll use this instance and I will use the predict function with the help of this instance. So regressor.predict, and I will pass in this xtest object inside this function, and I'll store this in the ypred object. So we've built the model and we've also predicted the values. Now let me have a glance at the number of rows and columns of the actual values and the predicted values. So we see that both the predicted values and the actual values comprises of 102 records in total. So now that we predicted the values, we'll go ahead and calculate some metrics. So we'll find out the mean absolute error, the mean squared error and the root mean squared error. I'll click on run. So see that the mean absolute error for this model is 4.69, the mean squared error is 43, and the root mean squared error is 6.62. So again, the lower the values of these three, it means the better the model is. So let's say if we are comparing these values with some other model, and if these values are less than that second model, then the first model would be better than the second model. So that was implementing simple linear regression in Python. Now we have our next question over here. So the question is, what do you understand by logistic regression? Well, logistic regression is actually a classification algorithm which can be used when the dependent variable is binary. So let's take this example. So here we are trying to determine whether it will rain or not on the basis of temperature and humidity. That is, temperature and humidity are the independent variables and rain would be our dependent variable. That is, we're trying to understand whether it will rain or not on the basis of the temperature and the humidity. And again, logistic regression algorithm, it actually produces an S-curve. So let's say x-axis over here, it represents the number of runs scored by Virat Kohli, and the y-axis represents the probability of Team India winning the match. So let's say this point over here, it denotes 50 runs. So what we can see from this graph is, so if Virat Kohli scores more than 50 runs, then there is a greater probability for Team India to win the match. And similarly, if Virat Kohli scores less than 50 runs, then the probability of Team India winning the match is less than 50%. So let's take this value over here. So let's say the number of runs scored by Virat Kohli is around 60. So if the number of runs scored by Virat Kohli is around 60, then the probability of Team India winning the match would be, let's say, around 65% or so. Again, let's take this value here. So let's say this is around 97 runs or 95 runs. And if Virat Kohli scores 95 or 97 runs, then the probability of Team India winning the match is 1, which is 100%, isn't it? So similarly, this value over here, so let's say this is around 5 runs or 10 runs. So if Virat Kohli scores 5 or 10 runs, then the probability of Team India winning the match is 0. So basically in logistic regression, the Y value lies within 0 and 1 range. And this is how logistic regression works. So now we are supposed to implement logistic regression on this hard data set where the dependent variable is this target column and the independent variable is the age column. So let's go ahead and implement logistic regression. So let me start off by loading this data set first. I'll use the read.csv function. Now let me have a glance at this data set, view of heart. So this is our entire data frame, and this target which you see, this is our dependent variable, and we have the age column over here, and this is the independent variable. So we are actually supposed to rename this. So we see that the column name is incorrect over here. So our first task could be to rename this column. Let me go ahead and do that. So I'll use the column names function and I'll pass in this data frame which is heart, and I am supposed to rename the first column. So I'll give in 1 inside the parenthesis and I will rename this to be age. So now again, let me have a glance at this modified data frame. So it'll be view of heart. So see that we have successfully renamed this column from IH to age. Now let me have a structure of this data frame. So structure of heart. So you see that most of these are integers. But then again, since we are building a logistic regression model on top of this data set, this final target column is supposed to be categorical. It cannot be an integer. So we'll go ahead and convert this into a factor. So I'll use the as.factor function and convert this integer value into a categorical value. So as.factor, and I'll pass in this column over here, which is hard $target, and I'll store the result back to hard $target. Now again, let me have a glance at the structure. So that will be structure of hard $target. So initially it was integer. Now we have converted that integer column into a categorical value, which has 2 levels, which are 0 and 1. So now I'll actually build a simple logistic regression model, and I'll not divide this data set into training and testing sets. So we'll do this and we'll see what are the different probability values for the person to have heart disease on the basis of the different age values. And to build the logistic regression model, we'll be using the GLM function. So again, this takes in 3 parameters over here. First parameter is the formula. So here target $age is the formula, which basically indicates that target is our dependent variable and age is our independent variable. And we are building this model on top of the entire data frame, and family is equal to binomial. So when we state family is equal to binomial, we are basically telling R that this is a logistic regression model.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.
And I'll store the result in log mod 1. So now let me have a glance at the summary of the model which we've just built. So summary of log mod 1. So we have this p value over here, and we see that there are 3 stars associated with this p value. So this basically means that we can reject the null hypothesis. That is, the null hypothesis states that there is no relationship between the age and the target columns. But since we have 3 stars over here, this states that the null hypothesis can be rejected and there is a strong relationship between the age column and the target column. Now again, we have other parameters over here. So we have something known as null deviance and residual deviance. So simply put, the lower the deviance value, the better the model. So this null deviance basically tells us the deviance of the model when we don't have any independent variables. That is, when we are trying to predict the value of the target column with only the intercept. So if that's the case, then null deviance is 417.64. And residual deviance is that deviance when we include the independent variables and try to predict the target column. So when we include the independent variable, which is age, we see that the residual deviance drops. So initially when there were no independent variables, the null deviance was 417. after we included the age column, we see that the null deviance has reduced to 401. So this basically means that there is a strong relationship between the age column and the target column, and that is why the deviance has reduced. So now that we've built the model, we will go ahead and predict some values. So now I want to know the probability of the person not having heart disease when his age is equal to 30. So now let me actually head back to this data frame over here. So the values in this target column, it is 0 and 1. So when we predict the values, we get the prediction for 0. That is the person not having heart disease. So when the person's age is 30, we see that the probability of the person not having heart disease is 81.2%. Now similarly, I'll predict the probability of the person not having heart disease when the age is 50. So when the age is 50, we see that the person not having heart disease, the probability, it comes down to 60%. Now what I'll do is, I'll predict the values for a set of age values. So this time the age value, it starts at 29 and it goes on till 77. So I'll get a set of predictions starting from 29 to 77. So you see that when the age is 29, the probability of the person not having heart disease is 82%. Similarly, when the age of the person is 30, the probability of the person not having heart disease is 81%. So as the age increases from 29 to 77, the probability of the person not having heart disease decreases. So this is the final case over here when the age of the person is 77. So when the age of the person is 77, the probability that the person does not have a heart disease is 26%. So this is quite an interesting relationship, isn't it? So we see that as the age of the person increases, there is more likelihood that the person would have heart disease. So this model we built on top of the entire data set. Now what we'll do is, we'll divide this data set into train and test sets and build a model on top of the train set and predict the values on top of the test set. So again, for that purpose, I would require this caret package. So library of caret. Again, this caret package comprises of the create data partition function. So this takes in these parameters over here. So this is the split criteria, which is hard $target. That is, I want to split this data frame with respect to this target column. And the split ratio, which I'm stating over here, is 0.7. That is, 70% of the records would have the true label associated with them, and the rest 30% record the false label associated with them. And the final result, I am storing it in split tag. Now, what I'll do is, from the entire hard data frame, whichever records have the true label associated with them in the split tag, I'll take all of those records and I'll store them in the training set. Similarly, from the entire hard data frame, wherever the split tag value is equal to false, I'll take all of them and I will store them in the test set. So I have my training and my testing sets ready. Now let me have a glance at the number of rows of the training and testing set. So n row of train, there are 213 rows, and n row of test, there are 90 rows. So now that we have the training and testing sets ready, let me go ahead and build the model on top of the training set. So again, we'll use this GLM function and build the model. So this time the formula is the same, which is basically target tilde symbol age. So target is the dependent variable, age is the independent variable, and we're trying to determine the probability of the patient having heart disease with respect to his age. And we are building this model on top of the train set. And since this is a logistic regression model, the family would be equal to binomial, and I'll store this result in log mod 2. Now that we've built the model, it's time to predict the values. So I'll use the predict function, and this again takes in these three parameters. First is the model which we've just built, and then second parameter is the object on which we want to predict the values. So we want to predict the values on top of the test set. And finally, we'll set the type to be equal to response, which will basically give us probabilities for these predictions, and I'll store the result in pred hard. So let me have a look at the range of the predicted values. So we see that the range of the predicted values of the heart disease it varies from 0.21 to 0.86. That is, the probability of the patient having heart disease, it varies from 21% to 86%. And this is how we can build a simple logistic regression model on top of this heart disease dataset. Now let's head on to next question. Metrics. So confusion matrix is actually a table which is used to estimate the performance of a model. It tabulates actual values and the predicted values in a 2x2 matrix. So these are the actual values and these are the predicted values. So this what you see, true positives. So this denotes all of those records where the actual values were true and the predicted values were also true. So these denote all of the true positives. After that, we have the false negatives. So false negatives denotes all of those records where the actual values were true, but the predicted value was false. So where the actual value is true, but the predicted value is false, that is known as a false negative. Then we have false positives. So in false positive, the actual value is false, but the predicted value is true. And such values are known as false positives. And finally, we have the true negatives where the actual values are false and the predicted values are also false. So if we want to get the correct values, then correct values should basically represent all of the true positives and the true negatives. And this is how confusion matrix actually works. So now we are supposed to build a confusion matrix for the model which we built, where the threshold value for the probability of predicted values is 0.6, and then we have to find the accuracy of the model. So as I've already stated, accuracy is basically true positives plus true negatives upon all of the values. So this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. So when we divide the left diagonal with all of the values, that is when we'll get the accuracy of the model. So let's go to RStudio and find out the accuracy of the model which we built. So to build a confusion matrix in R, we'll be using the table function, and inside the table function, first we'll give in the actual values and then we'll give the predicted values. So the actual values are stored in this target column of the test set, and the predicted values are stored in the pred heart object which we had created. And then we saw that the range of the probabilities, it was from 0.2 to 0.8. So from that range of 0.2 to 0.8, I am setting a probability threshold of 0.6. That is, wherever the probability is greater than 0.6, it will be classified as 0. Or in other words, it will be classified that the person does not have heart disease. And similarly, wherever the probability is less than 0.6, it will be classified as 1. Or in other words, that the patient has heart disease. So I'm reiterating it again. So wherever the probability of pred heart is greater than 0.6, it will be classified as 0. And wherever the probability of pred heart is less than 0.6, it will be classified as 1. So let's go ahead and build a confusion matrix. So you see that this is our confusion matrix, and this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. And if you want to find the accuracy, all we have to do is divide this left diagonal with all of the values. So that'll be 31 plus 17 divided by 31 plus 17 plus 10 plus 32. So you see that we get an overall accuracy of 53% for this model which we built. Now let's head on to the next question. So what do you understand by true positive rate and false positive rate? So let's start with true positive rate. So in machine learning, true positive rate, which is also referred to as sensitivity or recall, is used to measure the percentage of actual positives which are correctly identified. So the formula for true positive rate is true positives divided by all the positives. So I am stating it again. True positive rate is basically the measure of the percentage of actual positives which have been correctly identified. Now let's look at false positive rate. So false positive rate is basically the probability of falsely rejecting the null hypothesis for a particular test. So the false positive rate is calculated as the ratio between the number of negative events wrongly categorized as positive, that is, all of the false positives, upon the total number of actual events. So this is how we can calculate true positive rate and false positive rate. Now we have the next question, and we're supposed to explain what is ROC curve. So ROC curve, which actually stands for receiver operating characteristic, is basically a plot between the true positive rate and the false positive rate. And it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So the closer the curve is to the upper left corner, the better the model is. Or in other words, whichever curve has greater area under it, that would be the better model. So let's say we have this curve over here, and let's say there is another curve which goes like this, which is nearer to this upper left corner. Then in that case, since the second curve covers greater area under it, that would be a better model than the first model. So this ROC curve helps us to find out the area under the curve as well as the right trade-off between the true positive rate and the false positive rate. Now we are supposed to build the ROC curve on top of the logistic regression model which we've built. So let's head back to our studio and do that. So to build the ROC curve, we would have to load the ROCR package. So I'll use the library function and load up the ROCR package. Now, this ROCR package comprises of the prediction function, which would give me a prediction object. So this takes in two parameters. First parameter is all of the predicted values. So this spread hat comprises of all of the predicted probabilities for the target column. And the second parameter is the labels of the dependent variable. So test $target has all of the labels of the dependent variable, and I will store this result of the prediction object in ROC pred hat. So now that we've created the prediction object, we can go ahead and build the ROC curve. And to build the ROC curve, we'll use the performance function, which is again a part of the ROCR package. So this over here takes in three parameters. First is the prediction object which you built. So the name of the object was ROC pred hat. After that, we will just give in TPR and FPR. So TPR and FPR stands for true positive rate and false positive rate. So for this prediction object which we built, we are basically trying to find out the right trade-off between the true positive rate and the false positive rate. And I'm storing the result in ROC curve. Now, let me go ahead and plot this ROC curve which I've just built. So this is our ROC curve over here. Let me zoom this. So we have this curve for different probability values over here. So this what you see are the different probability values. And our ideal curve should be something like this, where we have more of true positives and less of false positives. And this green color which you see, so this green color actually represents the ideal threshold value. So the ideal threshold value over here would be somewhere between 0.48 and 0.62. So this is where we would have the ideal threshold value of the probability, and this is somewhere where we can get the right trade-off between the true positive rate and the false positive rate. So maybe it could be this over here. So this point which we see, so the probability would be somewhere around 0.5 or somewhere around 0.55. So this is where we could get the right trade-off between the true positive rate and the false positive rate. So now that we've built a logistic regression model in R, again, we need to know how to build a logistic regression model in Python. So this time we are supposed to build this logistic regression model on top of this customer churn data frame, where the dependent variable is this churn column and the independent variable is this monthly charges column. And after that, we are supposed to find out the log loss of the model. So we are basically trying to determine whether the customer would churn or not on the basis of this monthly charges column. So again, I'll start off by loading the pandas data frame and also load the customer churn.csv file. And for that purpose, I'll be using the pd.readcsv function. Right, so we have successfully loaded the file. Now it's time to have a glance at the head of this data set. So these are the different columns which we have. So we have this customer ID, then we have the gender of the customer, we have the senior citizen column, which tells us whether the customer is a senior citizen or not. This column tells us whether the customer has a partner or not. This column tells us if the customer has any dependents or not, the tenure of the customer, whether the customer has phone service or not, and so on. Sort of all of these columns, the columns which are of our concern would be the monthly charges column and churn column. So this monthly charges column basically tells us the monthly charges incurred by the customer in dollars, and this churn column tells us whether the customer would churn or not. So now since we have our data set, the data set with us, let me go ahead and separate the dependent variable and the independent variable into two separate objects. So I'll store this monthly charges column from this customer churn data frame in the X object. Similarly, I'll store this churn column from the customer churn data frame in the Y object. So we have our dependent variable and independent variable to be separate. Now I'll go ahead and divide this model into training and testing set. And for that purpose, I would require this train test split function, which is part of the sklearn.model selection package. Now I'll use this train test split function, and this takes in these parameters. First are basically the independent variable and the dependent variable. So the independent variable is stored in X and the dependent variable is stored in Y. After that, I'll set the test size to be equal to 0.3. So this basically states that 70% of the records would be in the training set and the rest 30% of the records would be in the test set. And again, I'll set a random state value so that I can use these same values again if I want to. And I am storing all of these values into xtrain, xtest, ytrain, and ytest. So xtrain comprises of the training set of the independent variable. Similarly, xtest comprises of the test set for the independent variables. After that, we have ytrain, which comprises of training set for the dependent variable. And then we have ytest, which is the test set for the dependent variable. So now we have xtrain, xtest, ytrain, and ytest. It's time to build the model, predict the values, and get the log loss value. So first, I will import this logistic regression function from this sklearn.linear model package, and I'll create an instance of logistic regression. I'll store it in L, and then I'll fit the model on top of the training set. So L.fit, and I'm fitting the model on top of xtrain and ytrain. After that, I'll predict the probabilities on top of the test set. So L.predict underscore proba, and I'll pass in x underscore test, and I'll store the predicted probabilities in y underscore pred. So now that we've fit the model and also predicted the probabilities, it's time to look at the metrics. So the question stated that we were supposed to find out the log loss. So I'll just import the log loss from sklearn.metrics, and inside this log loss function, I will pass in the actual values and the predicted values. So actual values are stored in y, predicted values are stored in ypred. So we get a log loss value of 0.55. Now again, similar to RMSE, the lower the value of log loss, the better the model is. So again, let's say if there is another model and the log loss value of that second model is less than this, then that second model would be better than this model. Now we'll head on to the next question. So what do you understand by decision tree? So decision tree is a supervised learning algorithm which is used for both classification and regression. Right. So decision tree can be used for both classification purpose as well as regression purpose. So in this case, the dependent variable can be both a numerical value as well as a categorical value. So there is a flowchart like structure where the topmost node is known as the root node, the internal nodes with children are known as the branch nodes, and the final nodes without children are known as the leaf nodes. So here, each node actually denotes a test on an attribute, and each edge represents an outcome of the test, and each leaf node holds a class label. So let's say this first node over here, we are trying to determine the age of the patient. So let's say if the age of the patient is greater than 50. If the condition is true, we'll come here. If the condition is false, then we'll come here. After that, over here, we'll check if the person smokes or not. And if that person smokes, we'll come here. If that person doesn't smoke, we'll come here. Similarly, over here, the test condition could be whether the patient has any children or not. If the condition is true, we'll come here. If the condition is false, we'll come here. So this is how the decision tree works. And finally, we'll have class labels over here. So these would represent individual class labels. So let's say this represents that the person has cancer, this represents that the person does not have cancer. Similarly, this would represent that the person has cancer, and again this would represent that the person does not have cancer. So in decision tree, we basically have a series of test conditions which would give us the final class labels. Right. So now we have to build a decision tree model on top of this iris dataset, where the dependent variable is the species column and all other columns are independent variables. And after we build the model, we are supposed to find out the accuracy of the model. So let's go ahead and do this. So I'll start off by having a glance at the iris dataset. View of iris. So this is our data frame which comprises of all of these columns over here. And to build a decision tree model, we'll be loading the party package. So library of party. So again, before I go ahead and build the model, our task is to first divide this data frame into training and testing sets. So again, I will load up this caret package, library of caret. I'll use this create data partition function, and this create data partition function takes in the species column as the split column, and I'll give the split criteria to be 0.65. That is 65% of the records would be having the true label and the rest 35% of the records would be having the false label, and I'll store that in split tag. Now from the iris dataset, wherever the value of split tag is equal to true, I'll store that in the train set. Similarly, from the entire iris dataset, wherever the value of split tag is equal to false, I'll store that in the test set. Now again, let me have a glance at the number of rows of the training and testing set. So you see that there are 99 rows in the training set and there are 51 rows in the testing set. So now again that the train test split is done, we can go ahead and build a model. And to build the model, we'll be using the ctree function, which is a part of the party package. So this again takes in two parameters. First parameter is the formula. Next parameter is the data set on which we are supposed to build the model. So here the formula is species tilde dot. So this tells us that species column is the dependent variable, and when you put a dot on the right side of the tilde symbol, that basically means that all other columns except the dependent variable are the independent variables. So sepal length, sepal width, petal length and petal width, all of them would be the independent variables and species would be the dependent variable. And again, we are building this model on top of the train set, and I'll store this result in my tree object. So now that we've built the model, let me plot it. So plot, and I'll pass in this object, which is my tree. Now let me zoom this. So this is our root node, and the root node, the split criteria is on the basis of the petal length column. So we see that if the petal length is less than or great, so see that if the petal length is less than or equal to 1.9, then we come over here and this tells us that the species of the flower is setosa. On the other hand, if that is not the case, that is, if petal length is greater than 1.9, then we have another test condition over here. So here we check if petal width is less than or equal to 1.7. And if it is true, again we have two scenarios. So here we are checking if petal length is equal to or less than 4.7. So if petal length is equal to or less than 4.7, then there is a 100% probability that the species of the flower is versicolor. Similarly, if the petal length is greater than 4.7, then there is around a 60% probability that the species is versicolor, and there is around a 40% probability that the species is virginica. On the other hand, from over here, if we directly come over here and if we check that petal width is greater than 1.7, then in that case, there is almost a 100% probability that the species of the flower is virginica, right? So these are the test conditions on the basis of which we are trying to determine to which class does the species belong to. So now that we've built the model, let's go ahead and predict the values. So I'll use the predict function again. This takes in these parameters. First is the model which we built. So the name of the model is my tree. And then this is the data set on top of which you want to predict the values. So we want to predict the values on top of the test set. And then finally we want the response. And that response I'm storing in my pred object. Now after this, let me go ahead and build the confusion matrix. And to build a confusion matrix in R, we'll be using the table function. And the first parameter includes all of the actual values, and the second parameter includes all of the predicted values. And this is what we have over here. So this denotes all of those records where the actual value is setosa, and all of those actual values have been correctly predicted as setosa. So there are 17 such instances. So this denotes all of those records where the actual value is versicolor, and all of them have been predicted as versicolor. So there are 16 such instances. And this one denotes those records where the actual was versicolor, but it has been incorrectly classified as virginica. Similarly, this one over here, this states that there is one record where the actual value is virginica, but it has been incorrectly classified as versicolor. Similarly, this 16 which we see. So out of the 16 records which were actually virginica, all of those 16 records have been correctly classified as virginica. Now again, to find out the accuracy, we are supposed to divide this left diagonal with all of the values. So that'll be 17 plus 16 plus 16 divided by 17 plus 16 plus 16 plus 1 and 1. So you see that we get an accuracy of 96% for the model which we've built. Now let's head on to the next question. So what do you understand by random forest model, and also explain the working mechanism of random forest? So random forest is an ensemble model. That is, it combines multiple models together to get the final output. And to be precise, it combines multiple decision trees together. Now let's understand the working mechanism of random forest model. So let's say we have this dataset A and we have n records in it. Now what I'm going to do is draw samples from this dataset. So this actually will be sampling with replacement. That is, I'll take one record from dataset A, take note of it, and enter the same sample in dataset A1, and then put the record back to where it came from. And I'll repeat this process n times so that there are n records in dataset A1 as well. So what you need to keep in mind is, out of these n records in A1, some of them might have come twice, thrice, or even several times over, while some records from A might not have made it at all to A1. So I've created A1 like this. Now I'll go ahead and create multiple datasets the same way, and each of these have the same number of records as A. And the X over here, it could be anything. Let's say 100, 500 or 1000. So from just one dataset A, we were able to create multiple datasets for our advantage. So just for our sake, let's say the dataset A has 1000 rows and the value of X is also 1000. So it would be 1000 cross 1000, which would give us 1 million rows. That is, from just 1000 rows of data, we were able to create 1 million rows. Now for each of these X datasets, we'll fit X decision trees. Now let's say this A1 dataset over here has 10 independent variables. So what happens in a random forest is, each time a node is being split in a decision tree, not all 10 columns will be provided to the algorithm. This is important, so I am reiterating it, guys. So each time a node is being split in a decision tree, not all 10 columns will be provided to the random forest algorithm. So now the question arises, what would be made available to the algorithm? So only a random subset of these 10 columns will be available to the algorithm. So let's say I want to split this root node now. So instead of providing it all the 10 columns, only a subset of the columns will be provided. So let's say 3 columns. And it could be any 3 out of the 10. And with those 3, the algorithm goes on to split the node. And similarly, from the left node over here, it is again going to be provided with a random set of 3 variables. And it is not necessary that the left node should get the same 3 variables. It can be a different set of 3 columns altogether. So whenever we are splitting a node, it is given a random set of m predictors from the entire predictor space. And the reason this is done is to make each of these X trees very, very different from each other. Now let's say a new record Ri comes our way. Then we are going to pass this record to each of these X trees, and we are going to get each tree's prediction on what class this new record is going to represent. And since we have X trees, we'll get X predictions in total.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And to get the final prediction, all we have to do is select that class which would have the majority of the votes across all the predictions of the individual trees. So guys, this is the working mechanism of random forest. So now we'd have to go and build a random forest model on top of this CTG dataset where NSP is the dependent variable and all other columns are independent variables. So let's head on to RStudio and implement the random forest model. Alright, so let me start off by loading the CTG dataset. So I'll use the read.csv function and load this file. Now let me have a glance at this data. So view of data. So this is our dataset which has all of these rows and columns. And this is our dependent variable where we have these three values 1, 2 and 3. So this 1 basically means that the person does not have cancer, 2 means that the person is suspected to have cancer, and 3 means that the person has cancer, right? So these are the three different levels associated with this NSP column. Now, let me have a glance at the structure of this dataset. So structure of data. So you see that this NSP column is actually an integer. So we'd have to go ahead and convert this integer type into a factor. So I'll use the as.factor function and convert that NSP column from an integer to a factor, and I'll store that back to same column data $NSP. Now let me have a glance at the structure of it again. So structure of data. So see that initially this column was an integer. So using the as.factor function, we have converted this into a factor with 3 levels. Now let me have a glance at the frequency of the values of this NSP column. So see that there are 1655 patients who don't have cancer, 295 patients who are suspected to have cancer, and 176 patients who do have cancer. So now, before we go ahead and build the model, we are supposed to divide the data set into train and test sets. So first we'll set a seed value. So that seed value would be 1, 2 and 3. Now I'll go ahead and create the data partition. And the split column is basically this NSP column. And the split ratio which I'm giving over here is 0.65. That is 35% of the records would be in the test set and the rest 65% of the records would be in the training set. And I'll store this in split tag again. Now from this entire data object, wherever the value of split tag is equal to true, I'll store all of those records in the train set. Similarly, from the entire data object, wherever the value of split tag is equal to false, I'll take them and I'll store them in the test set. So we have our training and testing sets ready. Now again, let me have a glance at the training and testing sets. So n row of train, there are 1383 records in the training set. Similarly, n row of test, there are 743 records in the test set. So now that we've divided the data into training and testing sets, I can go ahead and build the random forest model. So for that purpose, I'd have to load the random forest package. So I'll use library of random forest and I'll load up the random forest function. Now again, I'll set a seed value and the seed value would be 222 and I'll build the model. And I am building the model on top of the train set. So I'm using the random forest function. And this random forest function again takes in two parameters. First parameter is the formula. Second parameter is the object or the data set on which we are supposed to build the model. So the formula is nsp tilde dot. That is, this nsp column is our dependent variable and all other columns would be our independent variables. And we're trying to determine whether the person does not have cancer, is suspected to have cancer or has cancer with respect to all of the other columns. And we are building this model on top of the train set and I am storing this result in the RF object. Now that we've built the model, let me go ahead and predict the values on top of the test set. So again, I'll be using the predict function. This again takes in two parameters. First is the model which we've just built. So the model which we've built, the name of that model was RF and we are supposed to predict the values for the test set. So I'll give in test over here and I will store the result in the P1 object. Now let me build a confusion matrix for this. So table, and this table function will take in the actual values and the predicted values. So the actual values are stored in the NSP column of the test set and the predicted values are stored in the P1 object. So this is what we have. So this left diagonal represents all of those values which have been correctly classified. So this 567 which you see, so this represents all of those records where the patient actually did not have cancer and it was correctly classified by the model that those patients did not have cancer. So this 8 which you see, this tells you that there were 8 patients or 8 records where the patient did not have cancer, but then again it has been predicted that the patient is suspected to have cancer. Similarly, this 4 over here, it represents those records where in actuality the person did not have cancer, but it has been predicted that the person has cancer. Similarly, if we take this row over here, this 20 represents all of those records where that person in actuality is suspected to have cancer, but it has been incorrectly classified that the person does not have cancer. And this 81 represents all of those records where the person is in actuality suspected to have cancer and it has been correctly classified, and that is how it goes for the rest of the records. So if we have to calculate the accuracy, we are supposed to divide this left diagonal with all of the values. So that will be 567 plus 81 plus 51 divided by all of the values. So 567 plus 81 plus 51 plus we have 2 plus 3 plus 8 plus 4 plus again 2 plus 5 plus 5. And this gives us an accuracy of 96%. So what I've done is I have divided this left diagonal with all of the values, and for the model build I got an accuracy of 96%. So guys, these are some of the questions which you frequently come across when you appear for data science interviews.
Okay guys, a quick info: if you're looking for an end-to-end certification in data science, Intellipaat provides a complete training on it, and you can check out those details in the description box below.